Hey, Bottleneck. We'll get started here in a little bit. Be a little more serious today. Yesterday I was playing some games and I was messing around with some other stuff, but we're gonna hammer all this stuff out today. We're gonna go as far through the book and the labs and everything as we can. So, anybody wants to do labs? Today's the day. There's Ranger. Look at Ranger down there. He's had food. He's got plenty of water. I think it's going to warm up today in Phoenix. It rained yesterday, so we were only about high 70s instead of the 90s we had been. So, all right, let's get going here in a minute. We're on YouTube, but we're also hanging out over here on Twitch like we normally are. And get going here. So, pop up the lab. Stop this thing from rotating. Whoops. And I'll pop me up on stream here. And let's go through some screen commands. We'll do a little bit of screen. You might have noticed I inverted the book, so it's also dark mode. I know people prefer dark mode on stream, but we'll do that. And this lab starts out. Here's the book over here. Here's the task. Learn about a tool to increase your connectivity and view a command line based instruction. So we typically log into systems as Linux users at the command line, right? We jump in and we do whatever we need to, and everything that executes as a child process of that shell stops when the shell leaves. Now, we can change that behavior with Nohup and some other tools and stuff, but we're going to look at a whole environment that's been Nohupped. And what Nohup means, hold on, make sure these are rotating. Okay. What Nohup means is that the process, the child processes of the main bash process, when we leave that bash shell, the orphans are allowed to persist. The orphans are the children that are left over when the parent process dies. With a Nohup environment, they can stay. They can keep running. So that's what shell's going to be, or that's what a screen's going to be. So we're going to do that. Yeah, Inspector, we're going through the book. So, by the way, if anybody's wondering how I did this, when I was using the book yesterday, it was all in light mode. And I came in here, and there's some advanced options, and you've got this little page here, right? So I went and looked up their documentation, but it was actually just as easy as changing the text and the background color. So when you flip these, it goes from black to white and white to black on the text. So that's how I flipped it. In case anybody ever uses the Sumatra open source, it was super easy to just, if you want to invert and go to dark mode, although Notepad's not dark mode. But if I had opened that in OneNote, or OneNote, I do use OneNote in dark mode, but also Notepad++ I use in dark mode as well. Just it's easier for people to look at, I think. So, by the way, there's going to be some parts to this lab that we're going to use today, and I really like this CSS with square brackets. No, but I am going to show you guys, this is a really nice screen reference that I like if you're going to use the screen tool. Some people are Tmux to the end. I don't fight over that kind of stuff. Use whatever tool is effective for you guys, right? But this is a nice little screen reference, and I keep this in case I need to do stuff with screen. I can have this. So, all right, I'll leave this open too so I can play with it here in a little bit. But here's our lab. It says you are a new system engineer for a small Linux-based tech company. All right, you're doing Linux work. The other engineers set you up with a tool called Screen and gave you a basic configuration for it. Inspect the configuration and see what advantages you can find for this tool in your daily system activities. So, like, why would we use a tool like Screen? Like, if you think about it, I was mentioning this a little while ago. Why might I use Screen here? If you look at the bottom of this, Why would I have these different environments that I can jump into? And then if I just close this out, what happens to my screen session if I have a jump box, right? So these are things to think about in the Linux world, because if you just are in the habit of jumping into a Linux server and doing whatever you need and then leaving and it stops all your processes, you're not going to get as much done. You're going to need the nice thing about having a jump box and then being able to jump off anywhere in your environment and having a screen session there is you can have a persistent session that runs things, that runs across all your servers. You can have processes running in there. You can do all kinds of things. All right, I got it. Oh, what is that? What is that? That was loud. I don't know if that was loud for you guys. That is one of the worst sounds I think I've ever heard. What the hell is that? Hold on. I'm gonna like see if I can delete this song. What the fuck is this? That was weird. Alright, well, we'll skip that song. Alright. Hopefully the song's better. Sorry about that, guys. That was like just static to me. Okay, inspect the configuration tool and find what advantages, and then so we're going to inspect our root screen RC file. We're going to start screen on this box, and then we're going to create multiple screen windows, rename them, and move between them. Right. So we're going to do some little screen tasks inside of here. So the first thing I do is say cat the screen.rc and look at this file and see what's going on. Here's the original author, right? He's got it out there, and then here's some values that were put into screen that allow it to behave a certain way. One of the nice things about it is you can go change this file any way you want, but if you don't need to change it, you just leave it the same. Right? You just leave it as it is. So now, the first thing I can do is start a screen session for this environment, and if I am now in a screen session, how would I know it? Right? How would I know that I was in a screen session? Well, I've got this little bar at the bottom that's new, but I can also do a screen ls, and I can see that there's a screen session on the system that is attached. So I'm inside of a screen session right now on this box, on the server. Then I can say, to split the screen horizontally, I can say Control A and Shift S, and now I've got these two different terminals right here. They're actually the same one, and then I can jump between them. I can hit Control A and Tab to jump down here. So now I'm in the bottom session. Horizon, I don't know if it is. I still use it. I think screen's perfectly fine for everything that I need. Down here, I see that I'm down here in this shell, but I don't have anything going on here. So I might need to hit Control AC to make sure that I'm in my own thing. Now I can hit Control A Tab and move back up to the top, and they're independent of each other, right? But I can hit Control AA up here, and I can jump between the ones that I have at the bottom here. So I say rename the window you're in. So window 1 here, let's hit Control A and Shift A, and I can change this name to maybe something like window 1, right? So now I hit enter here, and you notice that now, right here, I'm in the same one, right? I'm the best around, right? Some kind of Rocky thing. Your team leader forced you to use Tmux. I've never been for. I've had people recommend I use Tmux, but I've been using Screen so long, I just stick with it. And yeah, it's unfortunate if somebody's forcing you to use a specific productivity tool, unless other people are also connecting to it, which very rarely happens in my environment that somebody would connect into my shell. However, I do want people to be able to do it in case they ever need to see what kind of work I've done. But anyways, okay, so there's that. And then what I can do is I can jump to one of these other ones, and I can rename this one as well. I can call this window 2, right? And then now I can jump between the two windows, and I can jump between the two environments, and also jump, oops. I think I've frozen this one. Anyways, I should be able to Control A and then jump between, yeah, there we go. Yeah, there we go. So now I can get them, oops, I want to use capital clear. And now I have two windows in two different places. And look, some people like splitting windows like this. I'm not a big fan of chopping up my windows. All I do in my environment is name things at the bottom, and I can jump between them with Control A-N to move forward, control AP to move backwards, and control AA to flip between two. It's a very common one that I do in my daily work and that kind of stuff, right? So now I said create a new window and name it window 2, and then we have the two windows split, and then we also have them in different environments here. Now, you can attach other people into a screen session as well if people need to watch you while you work or something like that. I think Tmux does all the same basic things, but again, I never really got into Tmux much. All right, so validation successful. Now I say to detach from the screen session and verify it's still there, reconnect and then kill the screen session, and then create a new screen session with logging enabled. So you can set logging to always be there. If you're somebody who doesn't do a very good job of, you don't do a good job of pulling out your notes. Ow! Oh, man. Gotta sneeze. All right, hold on a second here. Let me wipe my hands off with my little tissue paper here. Let's kill the screen, or we'll detach from it and then reconnect to it to make sure it's still there, and then we'll kill it off. Hey, thanks for the follow, Hundo Man. Hopefully this stuff's useful to you. Let's Control A and then Shift DD, and that should detach us from our screen session, so we're no longer in screen. I can still do a screen-ls and see screen there. It's still running. It's just attached. I'm not connected to it. And then we have a few different connection ways to get back to it. We can use a screen-r, but a screen-r, by the way, it only works on a detached screen. You also have a screen-x, which will allow you to get into a screen even if somebody else is on the shell. So you can share a screen with somebody else. And that's kind of a useful one for maybe watching people or training when you want somebody to sit kind of side saddle with what you're doing. You can do that, okay? So now if I want to, I can reconnect to it. So screen-r, right, to reconnect. And now I see the different pieces, right? I can jump between these things. I have to reset up my split if I want to be able to do the split again. But I can for sure jump between the two windows. Here's my two windows. Yep. And I can do that and change whatever I need to. Now I can hit Control A and Shift K, and I'll really kill that window off. So now if I do a screen-ls, screen is... Oh. I'm in the screen. I only killed that window off. That was my bad. So now I can hit Control A, Shift K, and kill that one off. And then now I'm really out of screen. There's no screen running on this box anymore. There's no longer a Nohup environment where it stays persistent even if I disconnect, right? So, questions over here that are about the lab. What connection information do you see when you type screen R? Well, you see how you connected to it. You see which one that you did connect to. And I say, what information is captured in the root screen log file? So let's run that. So we're going to say screen-L to turn on logging. And then we're going to say the log file is root screen log.log. All right. So run that. And then now I can just make some command up that's just going to loop over and do uptime or something. We'll just run this. Let this run. Then we're going to detach right here. We'll hit Control A, Shift DD, and we've detached from that screen session. But then we could tail-F on root screen log.log, and we should be able to watch that thing write if it's still writing. Doesn't look like it is writing, so that's fine. Whoops. Yeah, okay, it's still writing. Yeah, that's what we expect. I would expect it to be writing. I don't know why Tail's not following it in real time, but we should expect every 1 second for that to write out and for us to see it, right? Yeah, there it is. They're showing up. They're just not showing up in real time. Maybe the logging is on some kind of cycle. I'm not sure exactly, but it's definitely updating that as it goes. So that's interesting, right? I can do a screen-ls and see the screens that are there. I can screen-r to reconnect to the screen. I can Control C and stop it, and then say echo I am here, just throw that out. Control A, Shift DD, and I'll disconnect, and then I can look at the tail, and I should be able to see all of that information. So the question over here is, what information is captured in the root screenlog.log file? Well, the things that are happening at the standard input are being logged, and things that are going to standard output are being logged for sure. And then something that we're not showing here but is true is standard error is also being logged there. So all three things that you might care about are logged. What did I type in the command line? What commands did I run? If you're building a process, if you've never deployed like an Oracle database before, and you run a screen with a log session, it will keep track of all the things you did for you. It'll give you the output if you want to use the output to show your engineers or to put into the install instructions, because maybe you got to do this again. And I think it's just kind of useful for keeping track of things. Our other option is to do stuff like this, which is something some of us do, where I just come here and I dump it into a notepad as I go, and then I keep track of what I'm doing. It's just, why not let the system do what the system does for you, right? The system can do all of these things. What is this doing? I think I was looking at all the, I was giving an example here, I think, of all the packages in the system or something, right? So anyways, the point is, you can use screen to add to your productivity in a system. So one of the things I use, and some of you guys have been around here enough, this is my Homelab here, right? And this is P01 Jump 01. This is my jump box. And at any time, I can just stand up a new window, Control A, Control C, sudo -I to become the root user, right? And then now I can just call this, right? This is my hello stream one, and then I can do all my stream stuff that I need to in here. Maybe I go into my streams and then, go do some stuff in there or whatever. Those are some of my older Ansible stuff that we did. But now I have this connection. If somebody were to turn my laptop off or I were to disconnect, I'm going to Mexico next week, right? I'm going down to Mexico. And one of the things I do is I jump in remote. I jump in remote and do stuff in my Homelab all the time. So I can go from here. I can hit my external remote home connection, which is a dynamic DNS, so it's always pointed to my home, no matter what my IP address is. But inside of the Homelab, I can just jump there. I log in as my user, right? And now, if I am anywhere in the world, the idea that screen is running is like a pane of glass, right? Screen-ls, screen-r, I'll reconnect, and there's all my stuff again. And as long as this box doesn't go down, as long as P01 Jump 01 isn't rebooted, I've got all of my stuff. And this is a really nice like persistence element for us. If you're running stuff directly off your laptop, when we used to go in the office, you're working in the office 8 or 9 hours a day, and then you leave and you go home. But if you were connected and doing stuff off of a terminal on your machine, you lost all those connections and you lost everything. But what I used to do is I just jump up into a jump box, and that would be my layer of persistence. That's always there in my environment. I'd go home, connect to my VPN, just reconnect to that server, continue doing whatever work I was doing. And you might say, well, that sounds inconvenient. You're always connected. Well, not really. I could just be connected, and then if I need to watch something finish, or I need to kick off something for a change management at on a Thursday night or something, I can do that. And I tell you guys all the time, I do that on my work machine over here, and then I sit over here and I watch Netflix while all my stuff runs, right? Like, that's how automation works. I build everything so it works, and then I just go. So screen is a super powerful tool for doing that. And if you've ever, if you're doing stuff for fun, yeah, fisherman, I got nothing to do all weekend. I have no college. Let's see, I've done all my college work for going to college. I have no college students this week because everybody's off until Monday, so I have no classes to run. And I do have work stuff to do, but my work stuff over there I need to get back to. I'm deploying Rel 8 in an environment, and I'm building all the pieces of it, and I'm also building an updater script, so there's all that stuff. I have a fault. You said when you worked at Google, you had a jump box that connected to the internet IRC from after I left. My coworker said it's still logged into. Oh, you were still logged in? Oh, that's funny, man. That's we had people who had cron jobs still running at Lockheed Martin like months after they left, and eventually we had to go in and like dig them all out. they weren't doing anything malicious, and we were on an air-gapped, we were in an environment, but that's a security concern, right? Like, we need to properly disable accounts and that kind of stuff. Dayton, you said, how come you use PuTTY instead of using the terminal? I'm just curious. Well, I'm using PuTTY because I'm on a Windows machine. I could use, look, I do have, in Windows, you have SSH nowadays. So, I mean, I could use SSH right off of here. Right, I could connect this way. Oops, that's not the password. Right, so I could be here, and then I could do a screen-ls here, and do a screen-x, and connect to that screen, and then now I'm in the same screen session as the one back there. No, I don't use WSL. No, you know what? I tried to set up WSL, and it didn't work on this laptop, and I just said, you know what? Me and Michael Pesta were working on it a while back when he was telling me, this was years ago, he was telling me about it, and I'm like, you know what? I have a whole Homelab environment. I want my desktop to just say clean. Yeah, I had a lot of problems getting it to work. So I do all of my stuff in here, all of my Homelab stuff. In fact, this one only has a GUI on it because I was building Nix for fun. But most of my stuff is all just run level 3. There's no stuff. Yeah, yeah, guys, the reason I use PuTTY, if we're being 100% honest, is because it works. And I am a minimalist in that I can use any tool to do anything I need. All I need to do is get to a command line. That's literally all I need. Yeah, Comet, I did, we did all that, and for some reason there were still weird errors, so I said, you know what, F that. I've got all my Linux here. I can jump into, you know, any number of Linux boxes that I have in my home environment. So I'm just like, yeah, that's fine. So anyway, so that's kind of my thoughts on it. If we go back over here on the lab, I said digging deeper. What other tools exist out there to give you more screen real estate? Can you find a comparison between Screen and Tmux? Which do you prefer? Some of you guys that are on here swear by Tmux. I actually have no problem with it. My only thing, and you guys will find this about me the more you kind of hang out, is I will just find a tool and stick with it as long as it does what I need, right? The word do's doesn't exist. As long as it does what I need, I will just continue using it. So Screen works perfectly fine for me and always has. And I've been using it for years, and it doesn't, you know, bother me any. Terminal app is arguably more minimalist since it's Windows native app, and you just got to add it to the App Store. Yeah, any of those things are fine. I'll tell you guys, like, everything that everything you will ever see me do here professionally, and all the labs that I show you and stuff, as long as I can be at a black background with green or white letters, I can do whatever. PowerShell's fine. I actually have, it's funny, I don't really advertise this much, but down in our Discord, I do have a set of PowerShell challenges to get people into using PowerShell, and I have used PowerShell professionally a fair amount. There's a really good tool. It's like, this isn't a Linux stream anymore. Hold on. There's a PowerShell ISC. IDE? ISC. I thought it was ISC. Yeah, Windows PowerShell ISC. If you guys have never seen this, this is such a really useful system for people that are going to use PowerShell. And what it does is at the top, you can put whatever script you want in. And at the bottom here, you can actually execute the script or individual commands. So you can run things right here. Like if I just want to set variables or something like that, I could set them here, and then I can actually just run this. And if any of you guys want to see what our labs look like in that space, these labs aren't out there in the world anywhere, but they are on our Discord. These labs are here. Hold on. I think I very shamefully have these hidden away. Yeah, they're in PowerShell training. I have a whole bunch of challenges for PowerShell if people want to do that. Just need to figure out if I can add SSH key to log in without password. Yeah, absolutely, you can do that. Dead. Or dead in. But here's my little PowerShell challenges, and they walk you through. This was originally for AAA with a tool. I had built a program at AAA called The Seat, and I have a stripped out version of these, but this is what it looked like. And you can go and you can run some of these commands: get date, start date, slow down, do all this. I can drop this in, And I haven't even run this in forever, but I can go drop this right in my PowerShell ISE, and I can run it, and I can see what the output looks like. And it says, interesting. And I got a bunch of information, a bunch of outputs. I don't know why the hell. I don't know why the hell it's got this weird background like we're in some kind of video game, but and then you can run this as many times as you want. We'll just keep executing. But yeah, the syntax of PowerShell is also messy. We use it a lot in AWS and Azure. You can actually use there's all kinds of PowerShell logins and plugins and things that can control things. But really, all these challenges do is they get you doing like really simple PowerShell stuff. And then we had more complex PowerShell stuff that starts around Lab 5, where we were going out and hitting, see, do I have it? Yeah, so the az511.gov is a local Arizona set of cameras that the AZ DOT runs, which is the Arizona Department of Transportation. And I showed you guys how to go hit it and how to go pull the information and then pull down the image. And then you could change and validate. This was inside of the tunnel. In Phoenix, there's about a 3/4 of a mile tunnel that goes under. Goes under at around, I think, like maybe 7th Street or something. No, where is it at? Anyways, wherever it is, it's downtown. It's I-10, and I took a bunch of pictures, and then I stitched those pictures together, right? And we used PowerShell to do all that. I showed how you could do it. It's weird. They've changed it. You used to be able to get one image every second, but then a few years back they changed it to where now you can only pull an image like every minute. It's very weird. I don't know why they did that. Why would you even have cameras up if you can't pull? I don't know. It's stupid. But maybe bandwidth reasons. But anyways, maybe they shouldn't have running Windows if they don't want that, like running images. But anyways, all right. So that's the lab on screen. I don't go super deep into screen here, but if you go and look at this thing that I linked earlier, which is the periodic screen references, aperiodic.net, I think that they've got a pretty good thing that can get you set up for, just the basics of screen. If you're one of these guys that likes to split out and have windows everywhere, you can do that. One of the guys in our server that I worked with, Pico, I worked with him over at Best Western years ago. He always had like multiple windows. He doesn't use screen though. He uses he's got like another terminal that he uses. He doesn't even use PuTTY. He uses some other terminal tool, and he could split his windows. And he liked to have multiple windows up. I, again, being kind of a minimalist, I prefer a lot of screen space like this, and then I can jump between my windows. So visibility for me, this has always been the way I like to see things. I want to see the full damn screen. I don't want this split up. But I jump to the window I need. I go, okay, that's the inside of my sudoers file. Then I come back over here and I change it, or I grab what I need and dump it over. But I'm much more of a this guy. Some people like it whatever different way. Yep. So all these different ways. But I tell you guys, however I connect into a system, it does not matter to me as long as I have a shell. As long as I have a bash shell with a prompt, I can do whatever I need to. All right, so we hit check there, and it says, look at you learning Linux. You use screen to run in different sessions. So we use screen. The questions were, could you do tmux? And I said, what is the concept of Nohup that screen uses? So you can go spend a little time in a Google Safari if you want to read about Nohup. And why is it so important that a Linux connection establish Nohup sessions? Well, Nohup means that you are not going to be killed. Your child processes of your bash shell are not killed when the parent process dies. If a parent process of bash dies and you don't have a Nohup running on a process underneath it, that process dies as well. So most of you have probably done that before, like you start something and then you close out a shell and you come back and it's dead. Well, that's the behavior of Linux. That's what we expect bash to do. But if you Nohup that process, it is not going to die when it is orphaned. That's the term for when the parent dies. The process is not going to die anymore. The process dies, you die in roll. I will never die. Who knows what's that from? What's the scene where she says, if you promise me right now that you won't die, he said, I can't promise you I won't die. And she goes, if you promise me you won't die, I'll make love to you right now. And he looks at the camera and says, I will never die. Who knows what that movie is? It's a funny movie, and then it's a really awkward scene after that of puppets having intercourse. Anybody know the movie? It's an older movie, but it's a funny one. All right, so now the next one is working with DNS. So we're gonna do some DNS work. If you guys don't know what that movie, it's Team America: World Police, right? Yeah, Team America. Fisherman knew. Team America was an early 2000s movie by the same guys, Trey Parker and Matt Stone, that did South Park. So if you guys haven't watched it, it's just an absolute ridiculous F fest of a movie. It's really bad. F festival, yeah, that's fair. It's pretty bad. All right, so we're gonna do DNS, working with DNS. So I'm gonna pin this for people that want to do the lab with me. Labs are free. I'm gonna pop it over on the YouTube side if anybody's on YouTube and wants to hang out and do that with us. And it looks like we're at a commercial, so we'll hang out and wait for the commercial to end. Pop this right here. All right. I'll wait here for a minute for people. Waiting for ads. Guys, wait for the ads to end. If you don't believe me, I'm gonna jihad all of you. Yeah. And then where they think it's uncanny because of his acting skills that he looks like he's infiltrated the communities of violence, and yeah, it's pretty funny movie. You guys haven't seen it, but I think it offends enough people's sensibilities that I can't talk about it anymore besides that one sex scene. All right, let's see. While we're waiting for ads, let's go look at Ranger. Ranger's breathing. I can see him breathing. Also, I gave him food and water earlier because, you know, he wants that every day. That's how dogs work. Kids too, by the way. Lab environment looks fine. I have stuff to add to the lab environment, and I have some projects to do. So we're going to do some labs, and then we might jump over and do projects, and then come back. And yeah, it's going to be all tech stuff today, right? I'm not going to play video games today. I was playing video games yesterday, not most of the day, but probably like half of it. So as far as the stream goes. Also, yesterday was by far my longest stream. I've never streamed for 7 hours before, so that's pretty long. But you know, the wife's gone, the son's not here, so SON. Yeah, he's not here, so it is what it is. All right. Task: learn about Linux networking. That's the main thing we're trying to do here. Understand how the get back over here. Understand how the Linux system sees the other systems on the network. That's what we're doing with DNS. DNS is a way to resolve common names or easily rememberable names to IP addresses that the system wants to use. That's how DNS works, right? That's it in a nutshell. So our condition is given a bash prompt complete in the allotted 60-minute time. We only have 60 minutes in the lab, so that's fair. And then the standard is complete all the actions in the lab. Here's some reflection questions that'll make you think about what we're doing. I gotta back that up just a little bit. Okay, there you go. Also, Fisherman, I don't know if you were around. Did you see I inverted this? In Sumatra, you can just come here and you can actually just flip these numbers right here and it'll make your screen dark mode. So if anybody ever uses the open source tool Sumatra, that's all you have to do to change it. So yeah, we got the book in dark mode, right? So right here it says your team is going to be doing some DNS work and you have to figure out how to use the tools in your Linux system. So you got to play with some Linux tools, right? That's the goal of all this stuff, is to show you guys the Linux tools that are available. How you end up using them, how your company goes about using Linux is, I don't want to say like not important, but it's less important than understanding how the tools work, because your job as an engineer is to make sure that things are working properly and fix problems. Those are the two things you do, right? You set things up the way the company needs, and then you fix them when they're busted. Those are like the two primary sysadmin and systems engineering tasks. Systems engineering goes a little more into like the architecture and some of that other stuff, but at the end of the day, those are the things we're doing. I even have a little diagram for this for you guys that want to see. This is how Linux system administration works. This is how all engineering tends to work. You've got a PPDIOO operation. This is a Cisco model. You prepare, plan, design, implement, and then you operate and optimize. And then you constantly spin through those things. The stuff on the right is project work, and most people think it's more fun. And the stuff on the left is where the sysadmins start, where we operate. We do keep the lights on. We run the NOC. We run the security operations. So that's network operation, security operation, help desk. We keep things working. We respond to tickets. And then we also optimize the system to make it better in actual practice, right? This over here is focused on what we call fit for use. And this over here is what we call fit for warranty. And from an ITIL standpoint, fit for use is, does it check all the boxes? Is it a Linux box? Does it have connection to a network? Does it have a redundant virtual IP? Does it have heartbeat with another system? Those kind of things are over here. Does it check boxes? Over here is how often it runs, what's its uptime, those kind of things. That's what we call fit for warranty. And fit for warranty is the idea that, do you keep something running like as often as it needs to, right? All right, anyway, so we're over here. Lab is pinned. You guys can do the lab with me. Hey, Monkey Man. By the way, Monkey Man, do you know there's a movie coming out with your same name? I don't know if you know that. And it actually looks like a pretty good fight. I'm a big fan of like fight movies. I mean, I grew up with, you know, Jackie Chan, Jet Li, all these people. Obviously, Bruce Lee back then too. But is it really good? I haven't watched it yet, but I love good fight movies, man. Like good fight scenes. Like some of my favorite fight scenes in general of more modern era is, I really like, there's a movie that's probably less well known nowadays, but it's called Kiss of the Dragon. That's a Jet Li movie where he's in France. That one was well done. Fight scenes were really well done in that one. And then another one that had really well done fight scenes from Jet Li was The Chinese Connection. And Fist of Legend. But Fist of Legend is a remake of the old Chinese Connection, which was the Bruce Lee one, which was also good. So, yeah. And, yeah, hopefully this stuff's useful to you guys. That's the goal of this, right? So we're going to dig in and we're going to find out how DNS works in the system. We're going to play with it a little bit. So use host, dig, NS lookup, and figure out what type of information we can find about systems. And then check the contents of your etsyresolve.conf. That's where your system goes to look for things that it doesn't know from its host files. By the way, the order that things look up inside of Linux, you can control as well. So if you want to use your host files first, you can. If you want to use DNS first, you can. We're going to set all that here too as well. And then I say do a trace route to some of these different things and see what kind of information's out there. You like the Bourne movies? Yeah, those were good. I remember I accidentally watched the very first Bourne movie. I was in the Army when it came out. I accidentally watched that the day it came out. I didn't even know that it was just coming out that day. One of my buddies was like, "Hey, you want to go see this movie?" And I was like, "Yeah, I'll go see the movie." I was single. I was living in the barracks at the time, so I was like, "Yeah, I'll go see the movie." And it was like packed in there, and I was like, I didn't know this movie was going to be this popular, but it was the opening night. So I saw the very first Bourne movie the opening night, and every other one since then I've just seen as it came out on video or in like Netflix or something. I didn't go out of my way. They were fine. They were good movies. They were fun. I just didn't go out of my way for them, right? So let's go look at Google. Let's do host on Google. This is a tool that you have in Linux. And hey, Mushroom, hopefully this stuff's useful to you. Look at this. So we have two types of addresses that came back. If I knew nothing else about these addresses, I can look at that and go, well, that is definitely different than that. Even if I didn't know how they were different, right? Like if I didn't know in any way that they were different besides that, I could tell that this is a shorter number than this one. This one is also using only numbers, as best I can tell. We also know that from the rules. But if you didn't know the rules, let's just look. This one is also using letters, so what the heck are those? But fun fact, those aren't letters, those are actually numbers for the purpose of this, but I know what it looks like. When you use hex and you go A through F, those are technically numbers, but it doesn't matter. The characters that we're used to in the English language call those letters, so okay, whatever. Doesn't matter. The point is, if I didn't know anything else about this, IP address and IPv6 address are definitely different. So I have two ways to identify Google right here, if I knew nothing else about it. So, then I say, let's go dig Google. So we'll dig google.com. And now there's a whole bunch of information that comes out of this dig command. Uh-oh. Hold on, I got to look at some. The wife sent me a picture. She's up in a retreat, and she bought a new sweater because even though it's like 90 in Phoenix, it's really cold up where she is for her little. She's doing scrapbooking with her girlfriend. So.
right.
Also, some of you guys, will you talk about zone transfers later by chance? I probably won't, Mushroom. I'm not gonna. So, are you talking zone transfers of like your DNS to other places? Or is that what you're talking about with zone transfers? I don't think we do. But no, I wasn't gonna talk about zone transfers directly. No. I guess I don't do maybe that enough for that to be something. Sorry, people are still texting me. I meant to say something else too. I'll tell you guys about that later. But right here, what do we see with dig? It tells us about the command that we're using, and it tells us what our target is. So that's good. And then it goes and it tells us if there's any special options we gave it, and it tells us we got an answer back. Here's the header. We were doing a query. We didn't get errors, and come down through here, and it tells us that here in the answer section we found out that Google has an A record. The heck and heck's one of those? It's an A record, and it's going to give us back for its A record some kind of IPv4 address, right? So I look at this and I go, okay, well, I also know what server I used. I use 8.8.8.8, which is maintained by Google, and port 53, which is DNS. DNS is always 53. It is 53 TCP and 53 UDP, by the way. And then it says when it was sent and the message size that was received. Now you can set dig to work different ways. So I could I could do a dig with a -- help, and it should tell me about what I could do. And I should be able to come in here, and if I wanted to, I should just be able to say dig, and see if I can just man dig real quick. Oh, man dig, and then say /IP IPv6, right? And if I wanted to use IPv6, I can give it a -6. So there we go. There's our -6. So then I try this, and I do the same thing again. I do a -6 on it, and this should give me back that same type of thing, but now it should give me a quad A record. Quad A is 4 A's, and then that should give me an IPv6 address. And if it doesn't, maybe there's something else going on. Looks like I had a timeout. Let's try. So Google doesn't always respond to anything. Let's see if Yahoo will give us that. No servers could be reached for that. That's okay. That's fine if it doesn't work. I just wanted to mess with it a little bit. So how many A records do you see? I see just one A record. The prompt gets you to wonder where your system gets its DNS configuration. So check your etsyresolve.com. Ah, I see what you're saying. Yeah, it just uses transport. So we would have to have that, which probably isn't set up. So there you go. Yep. So let's cat our etsyresolve.com, and let's go look real quick. Where is our system trying to resolve from? Well, there's two places. There's the name server 8.8.8.8 and 1.1.1.1. We talked about this. This is maintained by Google, and then this one I believe is Cloudflare, right? We were talking about this last night. Pretty sure somebody pointed out that's Cloudflare. And then there's another one that's commonly used, that is the Cisco one. And I have those. I can never remember them, but I have them here because I go and I hit them right here. 1.1.1.1, and then this is the Cisco one, 208.67.222.222. And by the way, I could take this, I can copy that, and I can go put that in my etsyresolve.com, right? I can add that right here. Right? And now my system, when I dig for whatever address, I'm going to go find that from that other server by default. That's the one that I'm going to use. Interesting. All right, let me get rid of that monster. So we just edited our etsyresolve.conf just for fun. And then we can go and we can look at the namespaces, and we can throw that into root namespaces, or name servers, that's what I called it. And then I say, so traceroute is installed on the system. Let's traceroute Google and see, do we actually get a response of all the devices in between? Traceroute under the hood is using ICMP messages to track how fast it goes to each of the next hops. And the problem with it is a lot of devices, I'm surprised it's only this one, are designed to not respond to ICMP traffic like that. A lot of network devices, we don't want people to map our networks typically. So we turn off ICMP responses for, or ICMP replies for any type of requests like this. So a lot of times with trace routes, you're going to get a lot of black holes. Let's go to yahoo.com. There you go. Boom. Right? And I'm very surprised that we're getting nearly as much as we are there, because normally, again, you'll get a bunch of dashes. Let's go check HashiCorp. Who knows how HashiCorp was in the news? How are they in the news even just 3 days ago? Anybody know? That's what I expect right there. What happened with HashiCorp 3 days ago? HashiCorp, by the way, is your Terraform, your Vault, your all kinds of things. Inspector, yeah, I mean, I guess that's a fair way to put it. They were completely sold out in that they were bought with cash by IBM for $35 a share, right? For about 6.4 billion total. By the way, fun fact, I did a college post on that earlier, so I have go to my annotations, my older references. Here is the link if anybody wants it. There's the link. Well, I don't know if they're going to destroy, I don't know what they're going to do, but they have had Red Hat, so you might have to fix you guys might have to copy that. It might not link directly, but they did do a number on Red Hat. So they've had Red Hat for the last 5 years. They bought Red Hat in 2019. There's the release of theirs for, these are APA references, by the way. Here was them being bought, or here was them buying Red Hat. And some of you guys know I was at the Red Hat summit that year, and it was absolutely the weirdest thing I've ever been a part of. So this is what happened. We walk into there's always a keynote, and it's giant. And there were a couple weird things. They gave us these little things that were supposed to be like, they were almost like the little discs you get at a restaurant that alerts you when and they were supposed to switch colors and do all this other stuff. And the only thing they ever did was like vibrate once. So I think their system was busted for the keynote. But anyways, at the Red Hat Summit in 2019, and I'm quoting personal experience. I was sitting there. I was in the audience. The keynote speaker for that year was the CEO of IBM, because they had just bought it. So he comes out to the Red Hat thing, and everybody's clapping for him, and I'm sitting there going, what the fuck? And the other keynote speaker that shared the stage with him was the CEO of Microsoft. And they were like, and I'm like, you motherfucker. These guys have been the open source community enemies for the last 25 years that any of us have been involved with it. And all of you are just clapping. I'm not shitting you. I was literally the only person that I could see, and there were thousands of people in this room, that was not clapping for these two people. And I'm like, Are you guys, like, I mean, big guys with beards that I'm sure have been doing Linux for 40 years? And I'm like, are you fucking kidding me? Am I, like, in the Twilight Zone? It was weird, guys. It was like one of the weirdest things I've ever experienced. Like cult groupthink type thing. Never seen anything like it. And I was looking around for, like, somebody else that was, like, looking around going, what the hell's going on? There were none of them. Every single person in that room was just forward like this, like, and I thought there's this old book, probably nobody here's ever read. It's called Left Behind. And there was this guy in it, Nikolai Carpathia, and it doesn't matter any of that stuff. I read it in the 90s when I was a teenager. And Nikolai Carpathia just goes up and he just walks up in the end of the first book and just shoots the guy in the head. And then he looks around at everybody and goes, what you saw was he pulled out the gun and killed himself in front of all of you. And they go, yeah, that's what happened. And they all rush off to their news sources. And the one guy who's not, like, affected by his spell, let's say, is like, what the fuck just happened? Anyways, that's what I feel like was happening there. Like, everybody was just like, and dude, the guy from Microsoft, the CEO from Microsoft, I couldn't quote his name, we can go look him up, but he was like, yeah, if you guys don't know, Microsoft's been the biggest contributor of Apache ever since Apache project started. And I'm sitting there going, I'm pretty sure that's not true. Yeah, it was weird, man. And I don't try to get in here and like do all the I'm not trying to like make content that's about conflict and shit. I'm just telling you guys something that literally happened to me, and I was sitting there going like, what the fuck is going on here? Weirdest thing. Probably to this point in my life, that's one of the weirdest things that's ever happened to me. So, and I've been through some stuff. All right, look at all that. That's all non-responses right there. Those are all hops that didn't reply, but still had to be connected to for us to get to that HashiCorp.com site. And that makes sense. That's load balancers and other things in between here and there with that resolved IP that aren't responding. And that's about fair. That's hitting their infrastructure and all their things not responding, and that's fair. That's what I would have expected on some of these. I'm actually surprised that we got nearly as much of this back as we did. But yeah, that's what I expect to see typically when you trace route to a open entity. And a lot of companies, by the way, traceroute, just walk-in DNS are all the things that come into what's called OSINT, right? OSINT, which is just open source intelligence. Things that we can go gather about a company well before the attack occurs. We could just start gathering stuff. One of the ones I'm always telling you guys about that's like a really good one. Q, do I cover System D Resolver? No, I have a little bit on System D in one of the future labs, Q. It's, let's see what lab it is. It's, I'll tell you what lab we do System D a little bit. It is... It was funny, I don't think I even put that lab in here. Oh, there's another one. I'm pretty sure I got another lab to add to this. I missed it in the book. Anyways, no, I don't cover that, but I do have a lab on that. So, or I don't cover that here, but now that you've looked at the tools you have, let's figure out the order that your system looks for resources in, right? Name server. Well, we'll look here at the Etsy NS switch file and we'll see all the things. I think they might have pulled that all out. Little cache things locally. Okay. No, I don't really go into that. I didn't even really think about that. I don't use Ubuntu professionally, so like a lot of this stuff is just the high level stuff. Q. Doesn't allow ICMP. What other ways do you go about troubleshooting your network? So better yet, Shark. That's actually a thing in networking. Sometimes you have to turn it on so that, or sometimes devices will respond to ICMP from certain traffic. But for the most part, you turn a lot of that stuff off. Assuming you work for somebody. Yeah, so some companies don't allow that. But better yet, a lot of times the network admins will have rules that allow their stuff to communicate. So interesting. Okay. So let's look at this. Etsy NSSwitch.conf. This is the way that your system, right here under hosts, this is the order that your system looks things up in. This is the way right here that determines that we're going to look at Etsy hosts before we look at DNS. And here in the lab in a minute, we're going to flip these so we look at DNS before Etsy hosts, and then we're going to verify that that is the behavior, right? This is one of these things where I like you guys to, like, you can believe me all you want, but why don't you just go do it and see, right? This is the thing that I'm always talking about, one test is worth 1,000 expert opinions. We can sit here and talk all day about it, but why don't we see what the behavior of the system is? It's kind of, important. Fisherman, are you still around? Did you hear that? I know that when my phone vibrates over here, Fisherman always thinks it's his phone, which I think is funny. Anyway, so let's look at this. So we're going to verify that our system is looking at DNS first, and then go there, and then change the order of the host lookup. So let's do this real quick. So we'll cat Etsy NSSwitch.conf. We've got that. And then we're going to curl Google real quick, and we're just going to see that this is what a Google page looks like. Generically, this is what Google looks like. A bunch of the words Google. Okay? And then we're going to go, we see a lot of Google in there, and then we're going to go test value for Yahoo, and we're going to get one of the Yahoo addresses. Any one of these addresses that we want, but I also have one of them here. Hopefully that's still accurate. And we're going to throw that in to our Etsy hosts as Google. So cat Etsy hosts, and at the bottom, Google is going to resolve to this name now, which should be one of the Yahoo addresses. If we needed to, we could fix that command and put in one of these ones, but I think that'll still resolve. All right, so then now if we curl Google, we're not going to get the Google page anymore. Now we're resolving, we're not even resolving through DNS anymore. Now we're using hosts, and hosts is giving us this BS, and this BS is actually something that we just verified came from Yahoo. So now we're getting a Yahoo page on our server. So we just broke. You might look at that and go, Scott, didn't you just break everything? Yeah, we're breaking it to prove how our system works. Our system is looking at its Etsy hosts first, as per the etsyresolve.conf or etsy-switch. etsy-switch.conf. It's looking at files first for that incorrect entry we did before the DNS. Yeah. So we did that. We curled that. And then now we're going to VI our Etsy switch. We're going to change this behavior. VI Etsy switch. And we're going to take right here on hosts. I'm going to hit YYP, hit I, and pound out the old one. Right? So we just got the original. And then we're just going to make this thing DNS before files. So we'll use DNS first in our system. We haven't changed anything else. We just changed that one thing. We still have that incorrect entry inside of Etsy hosts. But now we're going to go to Google and see if Yahoo and Google, we're searching for Yahoo or Google there. That's what that grep is going to do. It's an enhanced grep, so it's like an old egrep with I to ignore case, looking for Yahoo or Google. If it's a Google page, we're going to get all that Google shit again. If it's still going to files and is busted, it's going to be a Yahoo page still, right? So we're going to do that. And look, it's back on Google. Look at all that Google stuff. All right. So if that works, you successfully change the order of your system names by doing that. So we could fix that. There's a couple ways we could fix that. We could either VI our Etsy hosts and just pound that out, because why is that thing there? And that would be fine. Or we can also fix our etsy-switch.conf to be the old value again. Right? And then this would now, since we've commented that out, would now be proper again. So, all right. So we fixed all those things. And I said, look at you learning Linux. You looked at DNS tools to find resources and change the system so it looks in different areas. And some of you guys got to remember, there's a lot of awesome tools, but sometimes if somebody's never like touched DNS or played with it, you got to at least do these basic things, right? So what were we doing here? We clear the screen and then we just say history. These are, look, there's all the commands that I did. It literally starts right here. Those are all the commands we did, and then the questions over here are what type of addresses are returned by the host command. Well, what did we see? We saw an IPv4 and an IPv6 address. What answers did you get back from traceroute? Well, surprisingly, we got pretty much everything mapped for both Google and Yahoo, but HashiCorp gave us a whole bunch of these, and what does that mean? That means that next hop in ICMP, as traceroute went and did each of the things, did not give an ICMP reply. We did an echo request to it. We did not get a reply back from it, right? I said, what is the default order of host lookup in etsy-switch.conf for most modern Linux systems? That's going to be hosts, or it's going to be files, right, which is your host file, and then it's going to be DNS. That's the default order. What's it look like in like a Red Hat type system? Actually, this is an Ubuntu system. Let's see what this one says. This is a newer Ubuntu. This one does files, DNS, and then My Machine. I don't even know what My Machines is. I don't even know what that tool of facilitation is. However, if I were to set that first and start to see funny business, I would go back to those basic tools of my dig, my host, and I would look at how my system is resolving. You know, is it resolving from here? Is it, like, what is it doing? By the way, I think this is what you were talking about yesterday, Q, or yesterday, a few minutes ago. This looks like this is what's being resolved on this one. Yeah. Oh, I didn't know that's what that's for. That's good. Yeah, I think this one is set up like you were mentioning. The name server is the local one. But I can override this in this box. Unless this gets generated every time when it comes up. And then I got to go look at something like Etsy Net Plan and figure out. A lot of these boxes have an Etsy Net Plan. Yeah. And then in Etsy Net Plan, you can set up scripts that cause things to come up certain ways. In fact, in my labs or in my home machines, I really just have them set with their internal IPs. This is the internal IP for this box with its mask, and then its default gateway. And then I can also put resolvers in here too. So it resolves locally home, and then it resolves on 8.8.8. Yeah, unless you systemctl disable. So, guys, a lot of this stuff, like Q's talking about, these base things will work as tools to go and hammer out any Linux box there is. Like, I can go to any Linux box for the most part on planet Earth and say host, dig, ns lookup. Those things are going to be my bread and butter. Are we resolving DNS the way we want? Like, I don't even know on this box. ns lookup, www.google.com, right? Is my ns lookup going to do what I expect it to? And it looks like it is. So it's one of these things where I don't know, like Q's pointing out with the system disable resolve D, I don't know how any of that works. I've never even used that. I've never even played with it before. But I can see that my system is doing what I expect or it is not, and then I can go dig further in. And that's, I want to call that like the, let's say that's like the heart of the hacker mentality, where like, I don't know a thing, but I understand these tools I have. And I can lay these tools out, and I can hammer here and hammer here, and go, okay, that sounds pretty firm. Sounds like it's metal. I need to use my metal cutters. Or I go like this, and I go like this, and I go, that's a loaf of bread. I could use this like knife and cut it, and whatever. But the point is, I can figure things out with these basic tools I have, and that's why I try to show you guys. Like, you go read about stuff and you figure stuff out. That's a big part of engineering. Reading your man pages, going and reading, the blog and the release notes and stuff. But another aspect of it is just seeing how the system is working. Because especially as you come in as a junior systems engineer, systems administrator, you're going to be running stuff that was already built. So presumably it works, or it worked at one point, and then now your point is to figure out how it works and keep it working, right? So I don't know. Anyway, so I'm saying that's a lot of words to say, guys. There's a lot of stuff to study here, but we can test things to make sure they work, and then we can go look at the tools that we need for this other stuff. That's interesting behavior. I didn't know that things got blown away, so that is very valuable. I said, what happened when you put your Yahoo address in Etsy host for Google? Why did that change? Well, because our system looked at files before it looked at DNS, and then when we flipped it, it looked at DNS before files, so it ignored that BS, and then we flipped it back and commented out, and it was fine again, right? So run some local unbound and DNS mask resolvers for customizing responses. Nice. Spectrum, nice. Yeah, and internal to your company, you have a lot of control over how things get allowed or denied in your company. And then digging deeper, I say, what are some common ports for DNS? It's almost always 53 everywhere. And I said, why does it use both TCP and UDP, and which protocol is used for which type of traffic? When you have TCP and UDP, UDP is almost always your control traffic, and TCP is almost always like your data traffic. That's not a universal thing, but that's probably true. And I don't know if that's true for DNS, but that's something to go test and look at. If you want to play with DNS and see it break, I do have a different lab. It's over in the Kubernetes labs that I have, and it's called building a 3-tier app. And when you build the 3-tier app, the last thing we do is we secure one of the network sections, and we block everything that's going into it. But if we don't allow 53, like in that lab, if we don't allow port 53 on both TCP and UDP, all the traffic is going to stop working for DNS. And I break that in some of the labs for you guys to see. 53 is for a lookup. Yeah, nice. UDP 53 is for lookups. TCP 53 is for zone transfer. That's perfect. Yeah, so that's something to know, right? That's a thing to understand better the behavior of your system, right? I said, if you filter traffic and only allow UDP or TCP on the DNS port, what types of name resolutions might you run into? Well, you're not going to get all the information, that's for sure. And I had accidentally broken that before in Kubernetes deployments. Well, when we were building them, not in production, but when you're building them, if you lock down network policies, then you allow them for like UDP, you'll get some stuff back, but again, like you're not going to get the TCP responses back, so then you're going to have problems. So you might as well just allow them all. And I said, when setting up DNS and using it for deployments, why is it so important to understand client timeout? Why is it important to know that you don't control client timeout? So this is a question that comes from like an AWS standpoint. This is like a cloud thing. And what I mean by that is, if you use DNS, as your means of flipping a blue-green environment. Like if you're using DNS to point at an old resolver and then you flip your DNS over so all new requests come over here. The reason it's important to understand that you don't control clients, like there's no, like Google right now, well, I can't say that because I'm using Chrome, but let's say Yahoo. Yahoo, www.yahoo.com exists out on the world somewhere. DNS resolves to that, and then my client here, which happens to be a web browser, has a cache of that. So if I go to yahoo.com, which I don't think I've been to in months, and I click on that, this client here, this device, this web browser of Chrome, can hold that DNS information for up to a day. By the way, it could hold it forever. You could write your own one that does the query once and holds on to that DNS resolved information forever. So what I'm saying there is, and good clients will check every 5 minutes or sometimes more often, but sometimes people like to cache to keep traffic down, right? But what I'm talking about this is so important because a lot of us in the AWS space, we will flip things over at the DNS resolver level. But what if the client is not a proper behaving client or like a good steward of the community, and it keeps information for 24 hours? So now your users are pointed at some bullshit old link that doesn't work anymore. 90% of your people cut over here, but some people are using, I don't know that Safari does this, but let's say Safari browser keeps that cache and keeps pointing at the old link, and they're getting an old version of the stuff, they're getting stale data, they're not, and maybe you're a banking app. Look, let me show this for you guys. AWS blue-green deployments. This is a good way to look at this and understand this. They've got some good docs on this, and let me see if I can pull this up as a PDF. When you go here and then you say DNS, they talk about updating the DNS routing here. But again, what if the client that you don't control, some client out in the world, is still pointing at your old one? And you say, well, F them. They should have been pointing the right way. Yeah, but on the business side of things, they can't say F them. They got to say, I got to get my users correct. The technology side of things was easy. We just flipped the DNS resolver. It's like it's literally either a command inside of a shell, or you just go up there and flip the DNS resolver, and now everybody's on the new one. But some people that are still using the old cache are not. So if you guys want to read about that, there's a bunch of crap there. A lot of stuff there, in fact, to go spend time with. DNS is a big beast. I'm just showing you guys some basic little simple tools and then giving you some stuff to think about with it, right? Because again, you got to make sure that your system's resolved. We don't want to be writing host files. Nobody wants to maintain a 5,000 line host file. That's a nightmare. 5,000 lines would be small if you were trying to do stuff out on the web, right? But I'm just talking like an internal cluster. And I work with 5,000 line host files, but they're generated automatically, so that's not that bad. But keeping them synced between machines is an issue, and all that stuff too. So, and you say, why would you do that? Well, because that's actually some of the clustering tools inside of HPC that have been around for 20 plus years. That's still how they do some of that crap. All right, so let's jump out of here. We've done all these labs. We did a bunch of them yesterday. We started on 6 today, but we looked around Linux. We did kernel and package. We looked at disk mount points. We looked at ports and networking. Then we did some pushing and pulling of files and screen, and then we just did DNS. Now we're going to do some bash stuff, like simple bash that gets you thinking about how some of this stuff can work. Some of you, I'm going to give the caveat here that some of the stuff that we're going to show here, you still need to know, but some of the stuff that I'm going to show here is also easier with Ansible nowadays, especially when you're hitting multiple systems. But looking things up, doing the logic of looping and these kind of things, and doing decisions in Linux, very important, like computer science-y things to know, right? Even if you're not a computer science major, you got to kind of know these things. So I'm going to link this lab for anybody that wants to do it. I'm going to link it over on the YouTube side, and I'll link it over for you guys here on the Twitch side. I'll pin it. So there's the lab for anybody that wants to do it. And we will start it here in a couple of minutes. I'm going to go check on Ranger too. How's Ranger doing? Go check on Ranger. Take a quick little break, and I'm going to manually unpin that at the end of the stream. Okay. I'm going to put my little hourglass up for a second. And I'm going to say, think about break, and think about this next lab. So here you go, break and think about the next lab, and then we'll check out Ranger. Golden ratio, Vagrant is fine. However, I think a lot of us are kind of waiting to see how it's going to behave under IBM, because so many things are changing. Although Ansible is also owned by Red Hat, so it's also owned by IBM. So all of our good tools are owned by IBM now. So that's fun. All right, guys, I'm going to get up and take a walk around for a little bit. Take a break. And you guys think about this stuff. Feel free to hang out. Follows are free. And I will be right back. Yeah, Vault is deep in the industry. Q. There's places like I know ASU out here in Phoenix. Well, it's over in Tempe, but the Arizona State University. They have they are deeply involved with open source Vault, and I was at a not a Hashi, it was technically a Kubernetes conference a while back. There was like 80 of us there, and we were all doing talks, and the guy from ASU was talking about how they do, 180,000 Vault requests a day for their students to be able to log in their systems and stuff. And I wonder how much that's changed with, well, one, the business source license that happened last year, and then now with IBM taking them over. I'm interested to see how these things change, right? There's a lot of, again, I try not to get political. I try to just sit here and do the tech stuff, right? Because like the tech stuff is simple. I feel like at the beginning of the movie Gladiator, when Marcus Aurelius has won the first fight against the barbarian hordes, and then he comes back and he's shaking hands in the tent, and the senators are like, "Do you support this or do you support this?" And he goes, "Hey, I'm a soldier. I get to look at my enemies in the eyes on the battlefield, right? I don't have to like worry about this other shit." And that's kind of how I feel with a lot of this. Like, we can do the basic stuff and like do it well, and we can let other people hash out what kind of tools and the business type of stuff. Although it does affect us a little bit because I love Ansible, and I'd hate to see Ansible turned into something that we can't use anymore. But I mean, they've also owned it for 5 years, and they haven't changed the way that we can use it on the open source side. So I'm pretty okay with that. Obviously, Red Hat under IBM did the CentOS thing a couple years ago, and that was kind of a CENTOS. There we go. CentOS. Yep, better. Send to us. Oh, it's funny how my CC doesn't get me. All right, I'll pop back up on here. We still got a little bit of time for the break, so if anybody walked away, give them time to get back. Ranger is obviously laying around downstairs. If anybody here cares, I have a write-up. This is also in the Discord, so we won't go over this right now. But I have a talk that I did a while back in the HashiCorp space, and it was Vault, and it was my presentation to the Kubernetes group. This one here is up in our Discord, and it deals with something that I was doing where we wanted to have. Hold on, let me get this out of the way. We wanted to have. Yeah, look how long ago I did this. I did this for the hash. This was a Terraform. This was a fucking Kubernetes group. God, why can't I remember it? And I went and talked to them about building out the tools. So some of you guys have seen that. So that contact information is old, anyways. But all right, fucking A. Now I can't get the damn. Super annoying. Super effing annoying. But all right. We will start the lab here in a second. Ranger's good downstairs. We'll go switch over here and make sure I have the right size here for everything. All right, start. All right, I'm gonna give that until it ends because maybe somebody walked away. Man, I'll tell you what, IBM. If you guys ever want to look at something wild, go look up LavaSoft. LavaSoft, open source. So what happened with LavaSoft is they got sued to shit by IBM for what happened with Platform LSF and Open Lava. And I was using Platform LSF when this happened. And, wait, hold on. Is this right? Sorry, not LavaSoft, Open Lava. I did that wrong. I thought it was LavaSoft. Hold on. What was the name of their company? I thought it was LavaSoft. Oh, guys, sorry. This is Open Lava. This is so what Open Lava is IBM bought Platform LSF, which it was Open LSF. It used to be an open source tool, and then IBM bought it, right? Because you could go and buy the rights to a tool from somebody, and then they took it closed source. And when they did that, some of the original people that worked for it, and this is what was alleged and then what was proved in court, they worked for IBM supporting it, and then they also spun off their own Open Lava project. And as this says, Open Lava was pirated from an early version of Platform LSF after Open LSF was taken closed by IBM. Platform LSF is still huge part of IBM's flagship high performance compute stuff. So if I ever talk high performance compute and you want to know like the IBM side of stuff, this is what happened to a company that tried to fork it, but some of the stuff made it into the open source side that had been done proprietary by the same supporters with IBM, and that's why they got sued, and that's why they got canceled out. And you can go look at that and how that happened. That went for a long time because I remember I was evaluating on my team using Open Lava instead of Platform LSF. We were an all IBM shop, but there was this cheaper alternative, and it was bad. So feel free to read about that and go. There's a whole rabbit hole there of what IBM will do. There's also some pretty wild precedent for like what Oracle's done. I mean, if you guys watch what Oracle did to Sun, it was brutal to watch from a participant, because I was using Lustre at the time. I was using Solaris boxes, I was using Solaris hardware, because Sun hardware used to run all the Solaris, and it I mean, most people nowadays, again, in the industry will never even hear about like Solaris or Sun. They'll hear about Sun because Sun invented Java, but you won't hear about like Lustre unless you're in the high performance compute space and that kind of stuff. And Sun was really taking Lustre to be like a very viable file system. But anyways, all right. All right, it says right here, you are a new system administrator at a company. You've decided that you need to start gathering system information so that you can use it in scripts. You know that this will give you more capabilities for automation and collection of system state. Like, you want to do more than just this, right? This is fine, but that only gives you an output. You want to start finding out things about what's going on in your system. So let's check our bash environment variables. We're in a bash shell. I can echo $bash. Or echo shell, and I can see that I'm in bash. I can also find out a bunch of stuff about my environment. Things like ZFS and dtrace survived in the BSDs. Yeah. And Solaris zones, which, you know, Solaris is an OS that still is around. I think I could put Solaris on something, but it would be like a little sideshow thing for fun. It wouldn't be like for professional Linux, you know. And Solaris zones was my first time ever working with containers. I would have a server, and then I would share its libraries down into these zones, but only the libraries that I wanted. And from that, I could have multiple libraries up in the main one, and I could share versions down into the zones, so I could update servers, well, server zones, and they would act like their own little machine. It was the precursor to what we do with containers now. By the way, it all comes from jailing. It all comes from CH root jails, but it's that. Well, job had some ancient Solaris stuff that they pulled on a contract from Oracle to migrate to Oracle Linux. Yeah. And Oracle Linux is just I'm interested. Oracle Linux is just a downstream of Red Hat, so I think that's always been interesting. Once IBM bought Red Hat, I was surprised that Oracle Linux has survived. But you got to remember, Red Hat, and this was the thing that was mentioned at that keynote that I was at. The CEO from IBM said, "Yeah, we just bought a company for $34 billion that doesn't actually own any software assets." And at the time, that was mostly true. They owned Ansible, and they owned the name Red Hat. But if you look at what Red Hat is really like one of those little sausage grinders on a table. And all of the tools and all of the things that are being set and put pipeline down into Red Hat are all open source tools. The Red Hat name and the Red Hat operating system is really what people are paying for. Is simply the well, that's not good. 202 draining nodes in a cluster of 1,200. That's not a good email. That might be bad. I just saw a bad email. Oh no. Anyways, doesn't matter. Well, I'll work on that later. I'm not on call, so I do got to keep an eye on that stuff. They ran Oracle VM Server 2, which was so jank. Yeah. And then, by the way, Oracle picked up Zen, right? So now there's no Zen is you can run Zen still, but it's owned by Oracle. And then XCPNG was a fork when Zen got bought. Yeah, you pay for the support and the security. And what we used to say on government contracts is all U.S. government contracts always have a clause that you have to have vendor support for any open source, what we call FOSS, free and open source, FOSS. Yeah, FOSS is free and open source. Or you have COTS, which is commercial off the shelf. Yeah, and it's a neck to ring. That's exactly what it is. I need to be able to call somebody and wring their neck about this thing, and I need to be able to put that into any tickets in our ticketing system. We have talked to vendor is engaged. Whether that actually moves things along, like having, I don't know if any of you guys have ever dealt with Red Hat, and again, I don't want to get into the sensationalism that a lot of people use. I just want to do the tech stuff, but I can tell you right now, Red Hat level 1 and level 2 support are fantastically bad. They are fantastically bad. Like, I don't even know who they have doing that, but level 1 and 2 support, literally all those people will do to you is send you back docs that you could have read yourself. In fact, you probably did read those docs already. They are literally just document monkeys. So, like, if you go, well, why do 1 and 2 tech support even exist anymore? I don't know. They could do that with AI. They could have a fucking little AI bot that just responds to your shit. And by the way, it goes like this, too. It, like, flips you off and tells you to go fuck yourself. Because you're like, I already read this shit. I already did all this stuff. Put me to a person, right? Typically, you got to get to escalated to, like, a level 3 support at Red Hat before you get any, like, real type of support. So, I don't know if any of you guys have dealt with them, but that's the thing. All right, let's stick to Linux. I'm just going to work myself up. Here's our task. Learn about Linux variables and conditional testing. So we want to understand how conditional testing works. This is also the most basic primer of computer science, right? So if you've ever taken, like, even the most basic computer science course out there, you've got to understand how to set a variable, and you have to understand how to test it, right? Given a bash prompt, complete in the allotted 60-minute time. Well, I've already talked for 15. Complete all activities in the lab. So now there's some reflection questions for you to think about stuff, and then there's some digging deeper over here, so you can go look up and or logic, or what I would call truth tables, very important, and then look up the logic of and or and see if you completely understand the underpinnings of them. So all right, anyways, let's go over here. And we start with print env. Print env is going to dump a bunch of our environment variables to the screen. It is very similar to the env command. So I'm going to type, whoops, where'd that just go? Come over here and type env, and I'll get very similar stuff. And then I can do a declare -p, and declare will give me a bunch of information about my shell. And also I can use set. So I have a tremendous amount of information and variables and things that are set inside of bash from these 4 commands. But how are they? We're gonna throw them all through a word count -l and see kind of how they compare, because there's a lot of information here. Let's go over here. Let's run this command, and it's going to do all of those commands, but it's going to pipe it through a word count -l, so it's going to count all the lines for us. Print env and env, I think, are pretty similar. They're probably the same thing. They're both 16. But declare is going to give us 63 lines, and set is going to give us 64 lines. So that's a significant amount of lines for maybe whatever's running. Here's our SSH client. Here's our SSH connection over here, somewhere else. Like, there's all kinds of stuff going on that we can see about, and all of those variables are usable for us at the shell over here. So we can do whatever we want with those. So then I say test the output of a variable. We're just going to make a variable called name. I don't know why I have a $sign on that. I should just called it name. But let's echo the output of name. And, well, there's nothing in. If I go to a box labeled name, right, and then I look inside the box, but nobody's ever put anything in the box, that's what I'm going to get. The value, the output of the labeled variable name is nothing, because there's nothing in there, right? So what if I use uname, and that'll give me the name of the operating system. Here's Linux. And then I set name to be equal to uname. So now if I run this name variable, what do we think's in the box, right? This is the old what's in the box. So what's in the box? Well, now the box is populated with the output, the standard out of that command uname, right? This is an assignment operator. It is an assignment operator in that what's on the right gets assigned to the variable label and goes in the box for what's the name, right? So this is not an equal sign in this case. This is not a test for equality, rather. Test for equality is 2 equal signs in most of these languages. So anyways, echo name shows us that, and I say, okay, that's cool. But what if we wanted to check, what if we were just on the server and we did a ps-ef and we grep for HTTPD, and I see that HTTPD is not running. I do get the grep coming back, but that's fine. And then I can fix that with actually the output that I showed there. This will cause it not to be seen. And then what if I also do SSHD, and I do see SSHD running, which makes sense because I'm SSH into the box. So now I have a value that came out in my system. If I do a $? Which is the return code of the last executed command, this will give me a 1. And if I do this one, which I know is running, and I do an echo $? That'll give me a 0, which means that it returned good. It returned without error, and it actually found something. So when we look at these, you can take this 1 and this 0 and make them analogous to true and false. Now, I realize that that's backwards for most true false, but we have to go with what the system's showing us. There is nothing found by this grep, meaning the grep failed, meaning that that is not on, even though it's a 1. And the one where it is on, it comes back with it found it, therefore it's a 0, right? So we can make an analogy out of that, or what we call an analogous thing, to be able to put those variables in. So I'm going to make a variable called HTTPD check and a variable called SSHD check. And I'm just going to make those variables. And then if I go look again, so now I echo out my $HTTPD check, that's a 1. And if I echo my SSHD check, it's going to be a 0, right? So it's something to think about. All right, where's that? Hold on, what's going on here? Hey, thanks for the follow. Hopefully this stuff's useful to you. We are taking it easy today, but we're still doing some Linux and walking through some system stuff. For some of you guys, this is going to be super basic. For some of you, maybe you've never seen it before, so we're just walking through it and working on it. We have a book, and I wrote a book, and it's just all of our labs. If you wanted to do the labs by themselves, they are completely self-contained. You do not need the book to do the labs. All the labs are on Killer Coda for free, and I have one pinned right now that we're doing. So that's the whole spiel. There's also a Discord out there. People that like Discord. We have almost 1,100 engineers down in that Discord. Engineers, architects, security guys, all kinds of stuff. We're over 10,050, so that's pretty cool. Here to learn by osmosis. Yeah, Q. I mean, when I'm not swearing, it's probably okay. Did I say 10,000? Sorry, guys. 1,050. That was my bad. Sometimes I just talk and then I hear myself later and I'm like, what the hell did I just say? It's 1,050. We just hit 1,000 right at the end of last month, and I was pretty happy about that. It was pretty cool. We've been working on, we've been running the professional Linux users group for like 10 years, and we've been running that Discord for almost 5 years, and we've just been trying to grow the community, get more people involved, get more people wanting to do systems work, all that kind of stuff. It's a Wendy's in there. Yeah. You can't talk about your own stuff. You gotta just talk Linux. We use the term professional pretty loosely. All right, but anyway, so we hit check. We move forward, and now I say test the decision structures of Bash. There are generically, from like a computer science standpoint, 3 types of decision structures. There are probably other ones, but like at a most basic level, when we're first talking about this, there are single alternatives, there are dual alternatives, and there are multiple alternative structures. Those are the primary ways that logic in general works, right? So test each of these structures with the variables you have from the previous thing. So a single alternative structure is my program is walking along, it's procedurally going from the start to the end of the execution, and as it gets to a certain place, we test for if something is true or false, do a thing. If you just have an if-then, you're dealing with a single alternative structure. What happens then is if you get to that test, and I say, if I walk home and I find a stick, then pick it up, and I go along in my logic, what would happen is if I don't find a stick on the way home, then I wouldn't do anything. I would just continue. So a single alternative decision does not force the code to split or do any kind of decision. It's just something either happens or it doesn't, right? Yeah, we're nowhere near 10,000. I don't know why my brain, like, every time I see it in my head, and I said this to my wife the other day, and she's like, 10,000? And I was like, yeah, thanks for making me feel like my wife, man. A wife's a really good foil for keeping you at what, your head never gets too big. But anyway, so single alternative structures only happen if they need to, but they do not force a decision. A dual alternative structure is an if-then-else, generically. If-then-else, when I come to the decision, I have to go. It's a fork in the road. If I find a stick, then do this. Else, do that. And logically, that's a fork. That one of the two things has to happen. So in a single alternative structure, by the way, and some of you probably care about logical theories, or logic. If you take all the probabilities of outcome of some event occurring, does anybody here know what all probabilities add up to? In like, if we're talking about probabilities of the outcome of an event, and you have, well, in a single alternative, you only have one. What are the probabilities of something occurring? Anybody know this? Anybody remember their stats? Well, I'm going to tell you, they always add up to 1. If I have a 25% chance, which is 0.25, 0.25, 0.25, 0.25, all the outcomes that can come out of a process, they add up to 1. All the probabilities. If you have 4 and by the way, if you ever don't have them add up to 1, you don't have all the probabilities of an outcome, right? Well, anyways, with a single alternative, things don't have to happen. Yeah, they normally, yeah, somewhere between 0 and 1. Well, with single alternative, it can either happen or not, but there's no forcing it. So with a dual alternative structure, all of your outcomes are going to go one of two ways. They have to. But with a single alternative, it's still going to be it either happened or it didn't. But the point is, there's no forcing the program to do the thing. So it's kind of an interesting thing. And then multiple alternative, we keep adding more. And these can be case, these can be nested if then else, nested if type conditions. There's different ways to do that. We're going to do it with case statements though, because case kind of looks clean and it's easy to see. But you don't have to memorize all these. These are just the things that you're going to run into. So I say here, and this will pop up over here on the right when we hit it, but you hit the button and you say if test HTTPD check is equal to 1, then echo HTTPD is not running. And then we have to have, as a control structure, FI. So it's if, then, FI. Right? Those are kind of like keywords to all this. And it said HTTP is not running. And then I go check for SSHD, and I say if SSHD is equal to 0, then SSHD is running. And it says that it is running. So now we have these tests to check for if HTTPD is or isn't running, right? And you might say, that seems really, really simple, Scott. Yeah, but you know what? Back in the day when we used to run bash shell scripts against systems, and we wanted to determine, am I the root user? Am I on a node that's in the right subnet that I expect it to be for this? We could use simple checks like this to call blocks and functions and all these kind of things. We could set different variables for the environment. Maybe it's a prod node or a dev node, and we could do these things in our shell scripts to cause these things to behave a certain way. And again, this is the simplest form of logic, where you have just a check and then you just output something. Instead of outputting something between the then and the FI, I can execute any blocks of code I want. I could make this thing go ping Google and make sure that it's on, and make sure that it gets a response back. And if it does, then I set some variable. And if it doesn't, in this case, nothing's going to happen. It's only going to do it if that check tests to true. There's no then else. There's no else. There's no catch all for everything else to make all possibilities add up to 1, right? There's none of that. So, all right. So we come down here and I say, can you make do these look like what you expect? Can you make them logically incorrect but still work according to their syntax? Ah, that's interesting, right? So can I set HTTPD check to 0 and then run this, and this will still run, but it's wrong. And then, what if I did that same thing for SSHD check equals 1, and then I do my check, and now I'm no longer getting the output I want. Block spheres diameters 2. So check this out, right? There's a kind of important thing here to understand. There's only 3 types of errors generically that you'll ever run into for sure in Bash, but in computer science in general. Does anybody know what the 3 levels of errors are? They get more insidious the further you go. But like you watch anybody on software and am I still in hold on, I'm still in just chatting, aren't I? I just realized that. I was thinking about it, I'm like, I'm in just chatting still. I should be in science and technology because we're doing all science and technology. Hold on, let me change that. Science and technology. Hold on, I need to be back over in science and technology. I don't know why I put myself. I think I left it in just chatting. So we should be in science and technology now. We're not messing around with video games today like we were yesterday. Anyways, real quick, think about it. What are the 3 levels? If you watch anybody in science and technology or software and gaming, any of these places or software and development and gaming, whatever that channel is, what are the 3 types of errors? Somebody can look it up. What are the 3 types of computer science errors? But let's keep going. By the way, I've got to set my checks back because otherwise things are going to be all busted for the rest of the lab. But I wanted you guys to see. By the way, when we first made these checks, how did I find those checks, right? Up here? I actually created them by doing some kind of check, and then I generated the output and put it in there later. But now I'm just manually setting them. So that's also a skill. You can just manually set variables if you want. You can procedurally generate them, which is what I've been doing. But there's that. So now I say, let's use a dual alternative structure. So this is if then else. We're forcing a decision. And the first one is, we're either going to see HTTPD running, or we're going to see it is not running. So in this case, we've got this then condition that was met. So this tested to true. So the then condition is echo HTTP is not running. So that's fine. Then we came down here and we checked for this and we said SSHD is running. So this is a logical test. The structure here is if, then, else, phi. Still the same type of thing, right? We're adding more and more keywords that all have to be there for this to work. By the way, the 3 types of errors, I don't know if anybody's still typing them up. Probably nobody's going to answer me. That's fine. The 3 types of errors are, they're syntax errors. Syntax errors are easy as shit. Watch this. You want to see a syntax error? Watch this. Let's just take this thing off. Well, how quickly did we find that syntax error? This is one of the things when I was saying about them being insidious. That syntax error was immediate. That's a syntax error right there. I have something wrong and the computer goes, look, dummy, I don't know what to do with that and I'm not going to guess, so you're an idiot. That's what it did. It told me I was dumb. That's a syntax error. The next type of error is a runtime error. So a runtime error would be if I do something like this. So the syntax is good, but maybe I set SSHD check equal to like this. Hold on, this might do it. Hold on. That still captured. Let me think. Let's just do this. So what we did was we set SSHD check to nothing, and then as it ran, the syntax worked, let's say, but in the runtime, it didn't find what it expected to come out, so it broke. That's a runtime type error. That's not a great example of it, but a runtime error is all the syntax checked out, but something broke in the runtime. And then there's a third type of error. Does anybody know what the third type of error is? Third type of error is the worst. So we're going to set that to 0 again and make sure that works. Okay, good. This is a logical error. Logical errors look like this. Is SSHD running on this box? Yes. Is my syntax good? Yes. Is my runtime good? Yes. But the logic is wrong. Logical errors are the most insidious type of errors because I don't know what I'm doing. That looks good. I don't have a syntax check error and I don't have a runtime error. It worked, but I have the wrong output. I give somebody a dividend in their bank instead of withdrawing money. I do the wrong thing and somebody loses money somewhere, right? Or somebody loses, something's wrong with my logic. Logical errors are the worst because they're, you have to find them, right? So anyways, that's something to think about. Come down here, and now we do a multiple alternatives to output multiple possibilities, which is greater than 2 possibilities. And when we run this, I know people are on ad break, but we can still run it. Now we're using case in, and then we have each of the cases that are available here. And then at the end of a case statement, you have an ESAC, which is just case backwards, right? And in this case, we could have SSHD is running, we could have SSHD is not running in the case of 1, or we could have something is really wrong. So let's set SSHD check to like some other number, and let's run our case. Whoops. And in our case statement now, something is really wrong. JPAL hates it when your software bugs create or destroy money out of thin air. Yeah. So there's our case stuff. And we can see everything, how that works, and then we tested some other numbers, and then we found this is a catch-all at the end, right? Just anything else. You've got a 0, you've got a 1, and you've got everything else. And this causes us to have, it's a multiple select, so we can, with a case, we can check something else, and then leave if we want to. So if you're writing a menu, a lot of times you'll choose the menu items, and then if they do anything else other than what it is, then you continue and you come back around to the loop again, and you lock them in a loop until they choose one of the values that you want them to. And that's a way that Bash, if you ever seen like a well-written Bash menu come up, that's typically what they're doing. They're dropping you in a loop, and until you select the right item, the case doesn't let you leave. We have an example of that in one of our GitHubs. I haven't been in my GitHub for a long time. I'm surprised I'm still logged in. In our stream setup, which is an Ansible playbook that deploys a bastion, if you go down in here and you look at our files, our bastion.sh, this is the shell script that you get blocked into. Yeah, JRC, you can go play with them whenever you want. There's a lab book. You don't need the lab book, strictly speaking, but some people like it to just give you something to write about. But real quick, here's the bastion.sh that I drop you into. And this is what it does. It has you... Oh, yeah, I forgot that I updated that. So it sends you to each of the different nodes, and then it'll drop you into each of the nodes as the inmate. And I believe I have the keys set up in there. Oh, no, I think you need the password. And then it drops you into each one of those. I forgot that I had updated that. But look at here's a simple case statement for me. Lab book is up on LeanPub. The lab book, by the way, the lab is the only thing. This book right here is the only thing that costs anything. Everything else around here is free. You guys can hang out. You don't need any of that stuff to do the labs. The labs are free. But the lab book is like, it's up on LeanPub. I think it's like $20. But you don't need to do any of that. You don't need to spend any of that. That's more for like the guys that have been around for a little while, and I feel like people probably just bought it to make me feel better about myself, and you know, like then I can pat myself on the back and say I've sold a book. But you don't need to do that. Also, all this stuff is up here for you guys. I have it as something for people that really want to spend some time with this and dig in. But this is a simple little bash script. This, by the way, this supplants a bash shell. So when you drop into a jailed environment and I don't want to give you any other things, one of the things I can do is lock you out of bash. Like, I don't even give you a bash prompt. I just give you literally a loop. And if you leave, I just kick you out of the host. And that's what happens in this jail environment. I don't have the jail up right now, but I can turn it on later if you guys want. If you guys are like, oh, I just want to see a jail running. We also have a lab on building a jail, and it'll show you some of the pieces of what you can do with a jail. That's coming up here. I think that's... when does the jail... When do we build the jail? We build it at the end of security, so it's a ways away. We'll get to it today, though, because I literally have nothing else to do. I don't have a college class today. Normally, I'd have to drop at about 11 for my college class, because I teach... I teach a bunch of college stuff, but my Saturdays are my huddle sessions with my students that need additional help, so they'll jump in, and I'll work with them on different stuff. But for this here, I'm just walking you guys through. So, okay, so here's some variable stuff. And again, if you've never played with this stuff, this is probably really useful. But some of you, if you haven't played with it, here's our Discord, by the way. Discord's all free. There's our labs. Those are all free. And there's the book. All right. But anyways, yeah, if you've never done some of this stuff, it probably looks kind of daunting, but it ends up being pretty simple. And some of you are probably looking at it going, yeah, that is pretty simple because I've been doing it for 20 years. Some of you have been doing it a long time, and some of that's probably overly simple to you. But think about the new junior admin that's coming in and touching Linux for the first time. By the way, one of the reasons I tell you guys that I like doing Linux as an engineer is I work with engineers that are 20 years older than me and been doing it for 40 years total, Linux and Unix style systems, and the basic stuff hasn't changed that much. So you spend time learning how these things work, and by the way, all of this logic that you're learning here is the exact same logic if you go to Python, JavaScript, C#, C++, I don't care whatever language you do. What'll happen though, you'll have different syntax, but the logic is still exactly the same. You never get away from this logic in computer science ever. Oh, it gets more complex and deeper, and there's more ways to manipulate it, but at the end of the day, you take a variable, you test it against something, and then you get some type of output. That's literally all we do in all of computer science everywhere. Oh, some people get better at doing it, and they're more abstract, and they make it visual, and there's all these other things, but that's all it is under the hood. And us down working the mines of the Linux world, this is what we do with our simple shell scripts. This is the start of how we would build shell scripts and stuff. Oh, okay, so wait, sorry, I forgot. I realized it wasn't done. I have to add some basic decision logic. So now we're going to add an inclusive or an exclusive AND to the equation. So let's make sure, let's set our SSHD check back to, I believe that was 0. And what's our, What's our HTTP check? 1, yeah. So we've got these set back to the right values. And I say we can check if HTTPD check is equal to 1 and SSHD check is equal to 0. So if both of those conditions test to true, then the system is good. By the way, we're back to a single alternative structure. We don't have a then, the system has failed. We could put a then in here. We could say then, oops, right here. Or sorry, else. We do have a then. I need an else. Else echo, the system is real bad, right? And that's not going to show up. But then I come up here and I change my HTTP check to something that's not what I expect. I change that to 0, but we know it's a 1, and now it says the system is real bad. Or alternatively, in the real world, I could have a bunch of checks. I can have them a bunch of different ways, and at the end, if they're not all good, I can just say the system is bad. There's a different way that I would do that, though. I wouldn't do it this way. Typically what I do with those is as I'm running through things, as I'm doing stuff, I will have a warn or a check flag. And I have an example of that. Hold on. I'll show you guys how I do it, because I learned this from Perl and Nagios. Hold on. So I learned this from, I think it's in my regular Linux group. When I worked for AAA long ago, I had put together a plan to deploy Nagios. This was when I first started over there. This was something back in 2016, and this was a deploy I had done in a lot of different places before. Nowadays, I would use different tools. I would use Grafana typically, but we get down here, and this is a simple. No, this is how we populate the servers. Hold on, let's get to my check. Here's my check. I know this is hard to read, and I know that it's a lot, but this was a system check that I had written. This was an example one that I gave. And what can happen is we set warn check to 0 and crit check to 0. These are Perl variables. And then as we go through all the system checks, whatever system checks we wanted, we could go through all the system checks that we wanted, and just whether if a Unix version was not at least version 327, which in this case I expected somewhere in there, the subvariable of 327, I would give the message is not the most current kernel. And by the way, that adds to the message. So whatever the message was already set to, which was 0. So we could have all of these different messages that get appended as we do multiple checks. And then my test condition at the end was simply this. If warn check is greater than 0, then we exit 1, because that in an exit code of 1 in Nagios is a warning. If crit check is greater than or equal to 0, then we exit with 2. And then else print message 0. Now, by the way, this logic is not great, and the reason is because if you have a crit check and a warn check, I would rather the crit check come out, and this one is going to leave with a warn check before crit check. So really, I should have changed this logic, and I leave this like this to show you guys. The crit check should be first, because I want to exit if there's a crit message. And if any kind of message, if crit check is equal to 0, because it starts at 0, but if it got incremented in here anywhere, just like the warn check would have, then it would execute. And this is a way to go through and just keep adding to those variables. And again, remember, look, we're checking to make sure anything's greater than 0. So if warn check or crit check hit multiple times, we would still warn out back to Nagios, and then Nagios will turn yellow or red, or if it's 0, it'll stay green inside of a Nagios system. By the way, I don't really show this, or I don't really talk about this much, but I do have Nagios running in my system still. Right here. There's a Nagios frame underneath Ranger. Probably most people don't recognize it because you're too enthralled with Ranger. But I do have a Nagios pass-through, and Nagios is running in my Homelab. Although a bunch of the old nodes are gone forever, and I don't really log into it much. But I can go to Nagios. Let's see. Let's see if I can go to any of these. Yeah, I can drop into Nagios and then go to any of my stuff in here. Up nodes, down nodes, here's my different nodes. I can go and actually look at it if I need to. And go right back here to Nagios. And here should be my generic Nagios right here. Here's all my stuff. Tactical overview of my environment. Got a bunch of nodes that are down because I haven't played with them, or I've taken them down over the years. And I actually like this view right here. But then, I don't really dig into that much because I don't really use Nagios much anymore, but I do still have it running in the environment, and it goes and checks things, and I really need to go strip nodes out of it But when I deployed it years ago, I used this script right here, and this is the one that I used to go pull all my nodes out and print them out like this as Nagios wants it. Right? It's all old Perl crap. Been a long time since I played with any of that stuff, but anyway, so we do all this stuff. We check everything. Let's go set our SSHD check back to 0. Right in here, and this should come out the right way now. So now we could also do an OR. We get an OR check, and it'll say the system is good. But the OR check, I said, can you break this one? Does it matter if one is true, or does it only have to be true for one of them to work? So I want you guys to think about what you know of OR and think, if I have this one or this one is true, do I evaluate to true as part of the test? So here's our conditional test right here. If I have an OR in there, is one side true and the other side true? Even if only one side evaluates true, does the output come out as true? And then I say over here, think about truth tables. So go look up some of the logic tables that you can find. There's a good Wikipedia article on it, or any of these other places that'll teach you basic logic, and find out if and or works each way. The way I always explain and or and truth to people is, let's say that you're dating someone and they tell you, I went to the store and I went to the park. They say, I went to the store and I went to the park. And later that day you find out that they did not go to the store. Did they tell you the truth? Think about that. And then later on in the day they say, I went to the store or I went to the park. And then you find out later that they didn't go to the store. And is that true? It's also real weird that somebody would talk to you like that, but I'm just saying, like, which one is telling you the truth and which one is not? And those are the kind of logical things that truth tables will help you to understand if you struggle with that. So that's what over here in the lab book, talking about that. You guys can also see it right now, but these are the things that we're kind of talking about. So we go here and we say, check. Look at you learning Linux. You captured variables and decisions. Base output based on and or logic. More information can be read about and worked through here. So this is the tlpd.org, the Linux documentation project, and they have some really cool stuff to go spend time with and reference on bash scripting. I probably use tldp.org. If I had to guess nowadays, I probably use it about once a week. But I used to use it all the time when I first started. I don't write a lot of shell scripts anymore. Almost everything I write now is Ansible. I do almost exclusively Ansible as an engineer. I still do quick and dirty stuff with shell script. If you told me right now, hey Scott, we're gonna pretend for the next 5 minutes that we're in a incident call. There are 5 nodes that are having problems. Start doing stuff. I would almost exclusively use bash to hit all those nodes and stuff because I've been doing this so long. But Ansible has a lot of power to, for a lot of my deployment type stuff. What's going on over here? I gotta check these systems real quick. Hold on. Okay. Sorry, we turned off a service last night that we suspect of causing Slurm problems in our system. Slurm is a scheduler, and we wanted to make sure that this tool that was checking the scheduler was not causing too many open connections or causing problems. So we turned it off to make sure, I think to exonerate it, because I haven't seen anything that causes it, but it's one of these things where, when we need stability to come back, we need to make sure that whatever changed is going to go off. However, the problem is it's been running for like 3 months, and this problem has only, been happening for the last week. So I don't think that we're going to find that the system was the problem, but this is the way sometimes things go in the engineering world. Sometimes we get asked to do things that we don't like, and we have to do it, even though it turns off our data gathering. All right, so that was that one. Let's get ready for the next one. The next one is going to be some looping. We're going to loop around and have some fun. Who remember? Well, nobody probably remembers that. All right. We're going to go to conditional and counting loops. I'm going to link this for people that want it. and unpin the old lab, repin the new one. I'll also drop it up here for people on YouTube that want the lab. There's a lab if you're on YouTube side of things. And we'll get going on this. All right. So here is, and by the way, you know what? One of the things I realized from yesterday, I was replaying as part of the stream yesterday. I replayed for about an hour and a half some old networking stuff, and I was thinking about this, and I'm gonna do each of these. I'm gonna do them. They'll be very similar to this, and I'm gonna record each of these as their own little modules, and I will do that with the book up, and I will do that, and then I will probably in some future labs, maybe even on Sundays when we do our all lab days, I will play through the labs that I have recorded, and then I will still be here to answer questions. But I'm going to use that so I can work on some of my college stuff. And I actually think that'll work pretty good, because then for you guys can still be working on stuff. I'll still be here answering questions. In fact, I'll even be on video if you guys want, because I'm going to record them without me on video. And then I can pop up and answer questions, and we can talk about stuff if you guys want. But also it'll be something that will be like very, I want to call it like very canned, and I will have it done in a way where I'm not talking about all these asides and other stuff. You guys know, if you watch stuff live like this, like somebody will ask me something and I'll be running off like squirrel and talking about that for 45 minutes. But I'm going to record these as individual blocks of me going through these, and then I'll be able to play them back. And I think that hopefully that will be a pretty good value add. I'll also put those up on the YouTube so that those are persistent. But I really want to do that, because then, one, it'll save my voice. Two, I can keep getting this kind of information out there for you guys for free. Hey, how's it going, Robodom? We're going through the book. We did 6, 7, and 8. Now we're on 9. We're not messing around today, Robodom. We're back in science and technology, and we are going to do some Linux. And I was just talking about how I'm going to record these, and then I'm going to put these up. And then I'll probably play these back kind of like I was doing last night a little bit. All right, so Linux Lab 9, Conditional and Counting Loops. Here's our task. Learn about Linux conditional and counting loop structures. That's the most important thing I want you to understand about all this. Given a bash prompt, complete in the allotted 60-minute time. We've got 60 minutes. Free, right? They're always free. Complete all the labs and activities. Then there's some reflection questions. So as we're walking through this stuff, we'll do that. Mushroom, you know what? I don't, but I do talk about that a lot down in our Discord and stuff. Like if you guys go on our Discord, there is a tremendous amount of us messing around with memes and joking with each other, and we've got food and our animals and all these other things that if you looked at it, you'd go, the fuck? This isn't a professional Linux users group. You guys are a bunch of hooting and hollering idiots. Like when I went to the zoo last year, and the monkeys, when you start walking by the monkeys, they just start hooting and hollering. One of the most important things that I found as an engineer is you've got to find a way to decompress. Like if this right here, and like I've got 5 screens in front of me and I've got all this stuff, if this didn't help me decompress, I would not do this on my free time. But this is kind of fun to me. I like hanging out. I like meeting Robodom, and we've worked. Robodom and I have actually worked together now. We weren't on the same project, but we worked for the same company. But like I've watched people like go and get jobs, and one of our guys just is moving from Florida up to New York and got a big pay raise, and like all these different things. I'm not putting anybody's business out there, but like all these different things that have happened, and watch all these kind of things, and that's pretty good to me. But if this stressed me more than like my normal engineering stuff, I wouldn't do this, because you have to have your downtime, guys. You have to have a way to decompress. One of my major ones that I use, and look, everybody's going to be different. Not everybody likes physical activity and physical sports, but I do a sport called Brazilian Jiu-Jitsu. I've been doing that for 20 years. And it's the only thing I've ever found in my life that can turn off my brain. And you say, what the hell do you mean by that? I'm going to tell you right now, when you step on a mat and you stand across from somebody and you try to kill each other for 5 minutes, you are not thinking about this shit. So that's a way to decompress. And I've also found if I think through it in my head, then I can actually kind of go off and daydream. I've never daydreamed my whole life. Never. I don't have that ability. My brain just spins. But with like when I think about jiu-jitsu and I think through techniques and stuff, Tani is also a jiu-jitsu person. That's the only time that I can daydream, is when I sit around and think about jiu-jitsu. In fact, I found out I can't do that when driving, because I actually can daydream. I'd never had experienced a daydream before doing jiu-jitsu, and it's not safe for me to drive and do that. So I don't do that when I drive. Anyways, I am a black belt. Yeah, I've been training Brazilian jiu-jitsu for 20 years, and I got my black belt 3.5 years ago. So yeah, I've been doing it. I'm out here in Phoenix under J Pages. So if you guys know that, yeah, involuntary yoga or folding clothes when people are in them. Oh yeah. You guys, if you guys haven't caught this before on stream, look at this. So in my Homelab, right, in my data section, these are all jiu-jitsu videos. I have 900 gigs in here of jiu-jitsu, and I have a little bit of backup where I back up like my college stuff and some other stuff. This is a Samba share off of my Linux boxes back here, but all of the rest of this is jiu-jitsu stuff. Yeah, Robodom, it's folding clothes while people are still in them. Yeah, that's the jiu-jitsu. But this is all jiu-jitsu stuff that I've bought over the years. Probably a library worth, if I had to guess, $600-700 total. I normally buy things on sale, but it's stuff in jiu-jitsu that I like. And then I have a little bit of my backup stuff, and I have my Attack on Titan stuff out here too, I think, because it was taking too much space on my old computer. That might even be in my back. Oh, and I have my old P90X3 stuff out here as well. So, from one of my buddies juiced the videos down for us years ago. So, yeah. That's one of my favorites, is the doing laundry. All right, so let's do, and I also teach college. I've been teaching college for 15 years for people that don't. In fact, I think I have. Hold on, if you do my commands, there's all my commands. But I think like, I don't know if I have it on any of these. I don't think I have anything on there. Yeah, I don't have to have anything on there. I probably should put Brazilian Jiu-Jitsu as a command on there. But yeah, I've been training for a long time. I mostly train in the mornings now with a bunch of guys that were all vets or firefighters and police and stuff. And I have a group of probably about 40 or 50 guys I still roll with pretty regularly. But yeah, I'm pretty active. I train about 4 or 5 times a week. So, yeah. Tani, I have so many mean chokes like that. There's a choke in jiu-jitsu we call the mother's milk, where you get mount on a person, so you're just on top of them, and what you do is you open up your gi, and then now I wear a rash guard because I'm a bigger individual, but some guys don't wear rash guards, and then they have like hairy chests or something, and you put the gi and everything right over the person's face, so you're on top of them, and you just smother them, and we call that the mother's milk choke. You basically just put your chest on their face until they are like, it's like giving them rug burn and shit from your rash guard. And then we joke around about my rash guard needs a rash guard. I think I have a whole bunch of memes of jiu-jitsu too somewhere on my computer. But yeah, I have a whole bunch of stuff. I am probably more invested in Kimuras than most people that play the game, and I am also very involved with leg attacks and heel hooks and stuff. I do quite a bit of that, even in the gi and even against white belts, and it's super funny. People are like, you wrist lock and heel hook the white belts, and I'm like, hell yeah, they need to learn sometime, don't they? So I'm kind of mean, but anyways, I do a whole lot of jiu-jitsu, and it's pretty fun. In fact, I'm going down to Mexico next week. On Friday, we're going down to Mexico, and then we're training the first 3 days that we're down there, me and a bunch of my buddies that have been doing jiu-jitsu a long time, and then we're hanging out the rest of the time. So I'll post some pictures up in the Discord when we're going. A younger player tried to throw me, just grabbed his leg, picked him up, and gently placed him in side control. Yeah, we're gonna, so it depends if we're doing no gi or gi. I've been doing a lot of gi lately, but no gi, I love doing stuff like that, Tani. And I do catch wrestling too, so I'm part of scientific wrestling. I've been doing catch wrestling for a long time too. Catch wrestling is like the mean shit where like nobody wants to be your friend anymore. It's like what we call like big brother stuff. Like if you ever had a big brother and your big brother's mean to you, that's what catch wrestling's like. It's like full Nelsons and stuff, like cranks on your neck. Stuff that you are not allowed to do in jiu-jitsu because we're the polite killers, that kind of stuff. But yeah, I love Brazilian Jiu-Jitsu. I've been doing it a long time. I'm mildly good at it now from doing it for many years. But I tell people I never got any better. I never got any better at Jiu-Jitsu. I am just as bad as when I started at No 3. The only difference is I have all kinds of stupid tricks. That's it. And people get caught and they'll be like, "Damn, man, you were controlling me the whole time." And I'm like, "It was just a series of tricks. It was all trick after trick that just happened to work." So, Origin gis are good. Actually, Origin has a really good camp up in Maine. But I used to go to Maine for a Globetrotters camp, so I do Brazilian Jiu-Jitsu Globetrotters as well. But yeah, I like origin geese. I have all my geese are downstairs, or I would pull them up and you guys can see. I'm a real big fan of inverted gear. Yeah, yeah, Tawny. I just keep pulling stuff out of my trick bag, and what I tell people is the more I've done the sport, the less you can put me. And this is what I would tell anybody if they're like, I want to wrestle you, and if they're like, I'm just gonna beat you up in wrestling, I'm gonna be like, look, man, this is one thing I 100% for sure know. You cannot put me in a position that I don't understand. What that means is, I might not beat somebody. Like, if you put a young college wrestler against me, he's probably going to beat the fuck out of me. Let's just be honest. He's going to slam me down and pin me. But he cannot put me in a position that I do not understand. What I mean by that is, like he slams me down, he gets me in side control. I might get him to roll at least once, especially in gi, but it's not going to be super easy. And if he ever falls for one of my tricks, he's going to be tapping. And it happens all the time. Bo Nickel, man, I've seen some Bo Nichols matches. That guy is yeah. Bo Nichols a powerhouse, and there's a lot of that. And then when I was younger, I did do the wrestling stuff when I first got out of the army. In fact, my main training partner was a college. So, Jake Paul or Tyson. I think Tyson would win 20 years ago, but I have a hard time thinking that a 60-year-old guy is going to beat a young guy. But that's just because time wins, right? Like time. I don't know. But anyways, yeah, Inspector, I don't know how that's going to go. I don't do boxing anymore. I did boxing when I was younger, but all right. So check this out. Your new system administrator, guys, this lab is pinned, so if anyone wants to do it, you can keep talking. You guys are welcome to talk jiu-jitsu. I enjoy jiu-jitsu talk. And yeah, we joke around about Linux jiu-jitsu or Linjitsu all the time, me and my buddies. In fact, when I was first coming up through the ranks years ago, I used to trade Linux lessons for jiu-jitsu lessons with my buddies. So guys would come over and they'd train with me for an hour on jiu-jitsu, and then I would teach them Linux for an hour. Full stop. I've always had Saturdays, so if you come in a Saturday, you could always just use my time. But for some of my buddies that wanted to get into the industry, this is kind of why I started doing the Linux group back in the day, was because people always wanted my time to teach them Linux. So I would be like, well, let's do some jiu-jitsu, and then we'll also do that. So, all right. So anyways, yeah, it was, and it was free. Yeah, this is like a Linux dojo. In fact, that's why so our damn God, our subscription thing that's like a little penguin doing karate. I asked the guy when I used like a $5 for that, and I said, hey, I want him to be like sitting there doing jujitsu, like so in a jujitsu with a white, blue, purple, brown, or black belt. And he came back with him doing this type of karate thing, and I'm like, I might have to make this shit myself. So anyways, our subscriber badges are actually a very, very failed attempt from years ago to me getting us like a nice little like jiu-jitsu related, because they, by the way, are white, blue, purple, brown, and black if you ever look at them. Yeah, I used $5. Yeah, gold belt. All right, so let's do a systems administrator at a company. You're a new guy. You decide that you need to start using loops to increase your productivity and monitoring of the system, right? This is, rubber meets the road, low-level stuff. We also, guys, we have other ways to monitor systems, but sometimes you need like fresh, piping hot data right now, and you need to understand your control loops. So there's two major types of loops that we use in Bash. There are conditional loops and counting loops. That is also true of computer science in general, but we're going to use conditional loops and counting loops. So I said create a conditional loop to watch CPU resources every 5 seconds. Some of you have seen me do that a lot, or you've done this, and you're going to pop that out. Then we're going to create a conditional loop to count to 10 with various different starting and ending numbers. So let's see if we can do that. The first one, I use this literally all the time. While true, do, uptime, sleep, 5, done. This is going to, every 5 seconds, well, what's it going to do? It's going to say while true, and it's going to test true for truth. True is going to evaluate to true. It's going to go to do and drop into a block. It's going to run an uptime. It's going to run a sleep. It's going to get to done. It's going to walk back up, and it's going to test the next condition. The next condition is true equal to true. Then it's going to go down. It's going to drop into the do. It's going to execute all the code between do and done, which is uptime and sleep. It's going to get to done. It's going to go back up. It's going to evaluate true, and is true true this time? True. Then it's going to drop in, and this right here is an infinite loop. This is Bender, right? This is Bender. It's actually Fry did it. Fry, when he was in love with Lucy Liu's head, if you guys recall, or sorry, it wasn't Lucy Liu's head, it was Lucy Liu's bot on Family Guy. Anybody remember that? And he's like, I love you more. And she's like, I love you more. And he's like, I love you more. And she's like, I love you more. And the professor goes, oh no, she's stuck in an infinite loop and he's an idiot. It's one of my favorite I have some really like favorite Futurama jokes, but that's probably one of them. So you might look at this and very quickly surmise that is very bad computer science. Yeah, don't date robots. They've got the little like school teaching, like the school lesson on why you don't want to date robots and they'll stop everything. Fry eventually ends up becoming his own grandfather, so let's not even talk about that. That's why his brain doesn't get affected by the brain bots as much, because he's his own grandfather, which is absolutely ridiculous. His own grandfather? Yeah, his own grandfather, right? Not his own father. Yeah, because it's his grandfather. Yeah. Because his father is the military guy. Is the old crazy military guy, and his grandfather was the one at mind bottling, like all your thoughts are up in a bottle. That's from a movie too. It's mind boggling normally, right? But yeah, what happens when idiots? Oh god, that one was ridiculous. But anyways, okay, so a conditional loop that's written like this is very bad computer science. This is a failure of any computer science course any of you have ever been in or heard of, because you've created an infinite loop with no stop condition. This is really, really bad computer science. But it's really good systems administration, because I can sit here and talk to you guys while this crap loops all day, and we can talk about what's happening in my system, and then I can Control-C it and stop it. So this would be terrible. This would absolutely be terrible to put in a script somewhere. This would be absolutely terrible to put in some executable code, whatever your loops look like in some, code. But it's great at the command line where I'm sitting here watching something happen while I talk to you and we try to work something out, or we're, people call it like pair programming or pair engineering, where we're trying to find a problem and the dev teams are standing behind me and we're trying to figure stuff out. That's a super awesome tool, right? So anyways, that is a basic conditional loop with a test condition that always evaluates to true. So let's instead go down here and set a variable to 0. You know how to set variables from the last one, so count is equal to 0. And then we're going to set condition to 10. So now we've got a count and a condition. We've got something to count over in condition. By the way, their names, we could count over condition. We can literally use these any way we want. Their name is immaterial to the discussion, but the names mean something to us, so that's why we use them, right? This is engineering. This is computer science. And then now I've got this other one, and I'm going to go ahead and run this, and it's going to say while count is less than condition, so count was 0, less than condition, do echo I am counting on count, so it gives me the count. It pops out the variable as it interpolated the variable of count in there. And then I come here and I increment count by 1. That is count plus plus. So each time it steps through, so what happened was say while count, which is 0, is less than count, which is 10. Do echo I am counting on count. There's our 0. Then it incremented. It said done. It came up here and it said while 1 is less than 10. Do echo. And look, some of you are probably like, Scott, do you really have to go this slow? Some people get really intimidated with syntax. Some people look at that syntax and go, I'll never understand it. I assure you guys, if I can understand it, you can. In fact, I used to tell my college students this, and I'm going to promise every single one of you, so we used to be in a physical building back in the day in college. We're not typically anymore, it's online. But I'm going to promise you right now, if you did not understand logic, you could not have driven to some building. You couldn't go out and drive around for 5 minutes without crashing your car and dying if you did not know logic. What you struggle with or think you don't know is the syntax. And maybe that's true. But the condition of like, while I'm going straight, continue straight, and if light turns red, stop, that's conditional logic. You use that shit all day, every day. You just don't ever probably think about it. You're what we call unconsciously competent. You're doing it without thinking about it. We have to break that and come back to so if you've ever seen this model, if you've never seen the unconscious competence model, it flows like this. Open image in new tab. So this is a really awesome tool to understand. So you're over here, you're driving your car around, you're doing all this other stuff, but you don't ever think about it. And this, by the way, this model, I learned this model in college, like when I was in my undergrad, and this is tremendously useful to me if anybody ever asks me, like if anybody ever wants to train jujitsu with me. I ask people, like, why do you do the things you do? And when I used to coach wrestling when I was younger, like, you sometimes get to an area where you do things well, but you don't understand why you do them well. So we don't ever want to exist here if we're learners, if we're like lifelong learners and lifetime like getting better at engineering and system stuff. We actually never want to be here. This is skating by. This is actually a bad thing for engineers and people that want to keep learning. We need to be somewhere over here. This is also a bad place to be. I don't know what I don't know, but I think I know, and I'm an idiot and whatever. But when we get down here, what we really want to get to is conscious competence, where we're constantly learning things, but we're still good at them. And you can read about those. I'm not going to go through all of them right now, but this is a model of learning that I think is tremendously important for people to understand. You start out, you don't know, you walk into jiu-jitsu class, you get roughed up real bad, and you don't even know what's happening. And then now you know that you don't know anything, and you spend a long time here, and then you spend a long time over here, and eventually you do move up to here. I can go to jiu-jitsu and not even think nowadays. I can just stand on top of people most days. There are guys that give me problems. I'm not saying there aren't. But what I'm saying is like, I can do this stuff, but I find that I learn better when I stay down here. So this is a really interesting model for how humans learn. And if you don't know where you're at, you're probably over here somewhere, guys. But then as you start to learn, like I try to stay here. I never want to just be on autopilot in my career. Like, oh, I'm doing Ansible and I'm doing the same Ansible I always do. No, I want to learn how to do it better, and I want to think about what I'm doing and you know, all that stuff. So anyways, all right, that's the unconscious competence model if you've never heard of it. So that's a thing. But so we know how this works. But one of the things I point out, if I run this again, what do you guys think is going to happen? Is this going to loop even once, or is it going to not do anything? Why is that? Well, because count is equal to something. I got to reset the count. But also, wait a minute. I wanted to count from 1 to 10, but why did it only count from 1 to 9? Wait, can I set count to 1, and will this count? So, oops. If I just set count to 1, will this count the way I expect it to from 1 to 10 now? Right? And some of you already know the answer to what I'm talking about here. But it depends where you increment. Do you increment before your output, or do you increment after your output? And then do you test if it's less than something or less than or equal to? So watch this. If I wanted to set this back to 1 again, and I wanted to run this as it is, and I wanted to count from 1 to 10, I can say less than or equal to, and now it'll count from 1 to 10 for me. But if I set that back to 0, now I'm counting 11 iterations from 0 to 10, and that's one more. So what I tell you guys, or what I tell junior engineers as I'm showing them this stuff, you can count however you want. You can use less than or less than and equals to. There's all kinds of different ways to do this. What I'm going to tell you is one of the best practices I've found as an engineer that does not do this all the time, and maybe you guys that code all the time want to do it differently, but I'm going to tell you, for me, I always try to use the same type of loop. I always try to use the same type of logic. If I'm going to start my counting at 0, that's fine, but I need to know where I'm ending. Because if we were doing bank transactions and you do one more or one less than you're supposed to, that's probably going to be your job, right? And I use that as an example because that's a place that would get audited often and that kind of stuff. But anyways, we don't want to be making those kind of mistakes, right? All right. By the way, we come down here and I say, okay, so what are some things about the loop? What did you notice about the conditional loop and how this works? So these are conditional loops, and strictly speaking about them, we expect a condition to test, and in this case, while the condition tests to true, we keep doing whatever we're doing. We can also do other types. We can say until a condition becomes true. We can wait. There's all kinds of other types of loops. And that kind of logic is going to be based on what you expect and what you want your data to look like and all that kind of stuff. So that's a conditional loop. And real quick, I think I have it over here. How do they vary from a computer science standpoint? I have a very, very simplistic way of describing the difference between a conditional and a counting loop. But feel free for anybody that wants to guess what the simplistic way I think of a difference between a conditional or a counting loop is. There's a whole bunch of differences, But I have one way that is very simplistic that's always true of the difference between them. So let's go to the next one now. Now we're going to do counting loops. So counting loops that count over a list of numbers, a generated list of numbers, or a file read. These are three ways that I use this often in the engineering world. In the systems world, I constantly am hitting blocks of servers or lists that people give me of tasks against a bunch of different project files or folders or whatever, because I work in high performance compute, so I got big data out on GPFS, and we have to sometimes hit them with a loop, right? So this is a counting loop, and a counting loop can work like this. We can say for I in a bunch of things, and I can just give the numbers at the command line, and I can give those numbers out as long of a list as I could put characters into a bash terminal. I could do a whole bunch of them. But what if I sat here real quick? I'm going to do this real quick. I'm going to go, all right, guys, we're going to do 100 now. And you guys would be like, what the F is that guy doing? And most of you would leave, and it would be like me and Robodom sitting here going, where did we go wrong, Robodom, right? But you can do that. You can do that. And by the way, you can change these. These don't have to be numbers. These can be right? They can be things. And you're not really counting over them. You're iterating over them. You're not really counting over them. We said we were... Oh my God. God damn it. I hate when I spell things wrong in my... And then and it's funny because there's quite a few people that review these for me, and we still miss stuff like this. Counting in conditional loops, step 2, text. I am counting... God, and I copied that, so it's wrong in all these places? Jeez. Create a counting loop, guys. There's no word named counting. How do we miss that everywhere? Terrible. Absolutely terrible. That lab's been up for a long time. Surprised nobody... So we always have pull requests against our thing. Against our... That lab will be fixed for people that come in later. All right. So then I said, look, for dessert in whatever, and I am counting over that. But you're not really counting. You're just looping over the things. And then we come down here, and I say, what if I wanted to do 1,000? Instead of typing out all the way to 1,000, I can use sequence. Sequence will generate a number up to whatever I say starting at 1. Or I can actually give the starting number. So instead of like sequence starting here, maybe I wanted to start at number 314 for some reason. And this would start there. Or I can change it, and that's what this next one is, where I can say, okay, well, let's start at 345 and count by every 5. And this will count every 5 every 1 second up until it hits 1,000, right? So you can do sequence a bunch of different ways. I give it, can you make it count by 5? It's sequence is just generating a list of numbers, and then it's coming out. And I said, remember to stop this if you don't want to watch it all complete. So we can do that. And then I said, let's go ahead and make a file called fruit. And if we cap fruit, there is our file, apple, banana, pear, and grapes. And then we can read all of the items out of the fruit file by catting it, and they'll all come to the screen. And then I can say, echo, I am reading each item, and I can pop out each item. This is tremendously useful for me when somebody gives me a list of servers and says, hey, Scott, can you hit these 10 servers and go pull all of the variable names for me? I go, yeah, I can do that. And then can you pull all the kernels and make sure they're all the same box? Well, here we put root servers, and I say for server in root servers, go ahead and do SSH to the server, give me a host name and an uptime for each of those servers, and be done. And it'll go control plane and node 01. Now, there's one difference. This thing right here works really good in this lab because this lab always works. But if I have like 10 servers that recently went through patching and I'm trying to make sure which ones are up, I will do this instead. I will say do echo, I am checking $ server, right? And then here I'll say timeout 3 for the server. So now it'll hit those servers, but if there was a timeout for a server that's not there and something was like sitting there hanging, then I would after a little while I would see that I am checking, but I would not see the fact that it actually did the check. So this is a thing that I do when I've got to loop over a list of servers real quick and make sure that they've maybe all been updated. So instead of uptime, I might do like a uname-r to see the kernel version. Boom, boom, they've all been updated with the kernel for the night. I could throw the uptime on there as well, if I need to, right? Just to make sure that they've been rebooted in the last day. Yeah, these have only been up 59 minutes, so they've been rebooted. Boom, boom, boom. I can pull those servers out as I call them good, and then I'll just get down to my trouble servers and go kick them over to my junior engineers. And like I'm running the big patching effort for the night, and my junior engineers are just running around fixing all the servers for me. Typically with procedures I've either put together or we've just, you know, learned and documented over the years of how to kind of repair the different stuff. And sometimes I'll even put checks in there, like if it's not returning yum, or maybe it's not. So yum is you're not getting your satellite, right? Your satellite repository. You shouldn't be yumming out to open repositories. So, you know, is your satellite connected? We could check RPM database, make sure our RPM database isn't the problem. We can make sure that our storage and var spool. The hell is it? CD to var cache. I was wondering why my brain wasn't working. Var cache and then yum, and everything in here. If we do a du-sh in here, it's 1.6 gigs. Well, everything in here can go away because it's all a cache. So du-sh dot, right? And in my Homelab now I've got a clean directory, but sometimes in some directories you won't have a lot of space available left. I've had this happen on servers over the years, and you know you got to go clean that out so that you can pull the most recent stuff, or you need to go clean this out. But this is one of those places, the x86 64, whatever different versions you have, you can always delete what's in there because it's just a cache directory, right? Var cache yum. And nowadays it's probably var cache DNF or whatever, but the point is it's something you don't need to worry about. Anyways, so do you have that many useful... Okay, so why would we hit this one or this one? All right, so then we go here, and I say let's script a loop. Let's do something with these things that will go, and we're going to push it over, I think, to the other node, and it's going to create 100 files on both of our servers. So create a script that loops over a list of servers, logs into them, and then creates 100 files called temp file 1 to 100, right? And then here's the solution for you guys. Also, the questions over here. How can I start on Killer Coda? You just literally go to Killer Coda right here. The labs are free. All you literally have to do is sign in with like a Google federated account, or you can sign in with any other email. They don't even send me emails. They don't even bug me. So those are labs that I've made, or Fisherman, who's around sometimes. Fisherman Guy Bro, he made some labs that are pretty good. His even get into large language models. So if you've never built an AI and had it talk to you, his labs will show you how to do that. So lots of stuff there for you guys to mess with. Also, yeah, we're trying to get him to stream more, so there you go. So let's write this real quick. Yeah. Man, I'll tell you, this is one of my favorite things on the web because it's free. These guys just have this service up for free for any of us to build labs, and all these labs that I've built are there for you guys to use. I think I'm up to like 57 labs total, and they're on Linux, which we're doing now. They're on Ansible. I've got a lot of Ansible labs, and they just teach you how to use the tools and teach you how to walk around. And I mean, what's better than like breaking an environment that's just you literally reset it like this, and that's the whole cleanup. You just redo this and all these servers go away. So that's way better than in a Homelab, where if I blow up some of my servers, I'm going to have to spend some time rebuilding them, right? So anyways, let's keep going on this. Now we got to create this script file. So I'm going to vi root file create.sh, and then in here I'm going to hit I, and I'm just going to capture this little block right here. And what does this thing say that we're doing? It says bin bash. That's what we call the shebang line. It's at the top. It tells our server what interpreter to use, but fun fact, strictly speaking, inside of bash you don't need this. And you say, why? Well, because bash is already going to use bash. But if I were to port this somewhere else, the bin bash will tell the server that has like maybe C shell and K shell and bin bash, and maybe it doesn't have bin bash as the default, that this is the default. Okay? But by the way, sometimes you need to check that. So I'm going to right quit that, and I'm going to say which bash on the system. And user bin bash is the way that my system does this. But if I do an ls-l, does bin bash work as well? And the answer is yes, bin bash is there, but my system by default is going to look at user bin bash. So really when I create the script, if I wanted to, I really should say in this system, user bin bash. But most of us use bin bash because that's where bin bash is almost there on pretty much all modern Linux systems. So I would just leave it. But if I didn't have the shebang line in here, my shell is already bashed, so it's going to use bin bash anyway. So something to think about. Okay. So we're going to make that an executable file. You got to make it executable, otherwise it wouldn't run. Oops. It is executable now. It is 750 because it is 7 for the root owner. It is 5 for the group owner, and it is 0 for anybody else. Why some people use user bin environment bash? Probably because that's like they have a special environment for things. It just depends. You can always check which whatever. So if I have env on the box. So environment allows you to set up different shell, like different environments within your shell, and they're almost like their own little virtual environment. And then I know with Python we call them a lot. And then we can define in there. So they probably got a if they call it like that, they're probably setting an environment up a certain way. And then you could use user bin environment with all kinds of different names as well, and call different environments as you set up different ways. A lot of guys do that so that all their packages that they're importing are in one environment and they're not affecting other environments on the machine. It's like you have your own little blast radius where you can build stuff. One of our guys, Salty Catfish, who's around quite often down in our Discord, and he streams probably a couple times a week, maybe 3 times a week. Salty is really good at Python coding. He's been a programmer for I think like 12 or something years. He's been around a long time, and he shows how to set that stuff up for you guys. So if you ever want to see that more, I don't do a lot of stuff like that because I don't do a lot of programming. Hold on. Oh, we got a message over on the YouTube side. It says, hey Tanis, knowing only Linux at an expert level enough to embed system engineering. This question is to understand the field better. It could be nonsense. Wait, hold on, what's the question? It says, is knowing only Linux an expert level enough for embedded systems engineering? Colorman, I'd say, yeah, you can do, I think you can do systems level engineering if you just know Linux, sure. Yeah, if you understand how your kernel works, you understand how compilers work, you understand how to add modules into your kernel and pull them out, I think that you can, that's a pretty good start for doing a lot of systems engineering inside of Linux. On our day-to-day systems engineering, systems administration, we don't do a lot of that because so for me, you got to remember, I tell you guys this often, this is one of the things about engineering. Like everybody wants to go work on the fastest machine, and everybody wants to put their foot down and build like the fastest thing they can. But most of us end up just working for a company that just needs its 100 or 200 Linux servers to be up, to have high availability. Basically, everybody wants to work on the Formula One cars, but really what's needed is somebody to support the fleet of Supras or the fleet of Toyota Corollas that are just going to drive all the agents out to their stuff. So what I'm saying about that is, like, there's all these things to know in the Linux systems engineering world, but what I think you guys really need to know is how to keep these systems up, how to keep them kind of fed and happy, and the care and feeding of servers. Keep the servers working so that they're updated to the security level and stability level that the organization needs, so that then the devs and whoever's building stuff can pop up or whatever. So yeah, we are on YouTube. We had a question, and he was asking about like knowing Linux and being an embedded systems engineer. I think that that's perfectly acceptable. All right, let's run the script. You can execute the script like this by calling it by name. And then if we go and we look, we would see that there are, in fact, 100 temp files on both of the nodes. So it did do the things that it expected to. And I say, do you see the output you expected? Why or why not? There you go. So then there's some questions over here. What's an infinite loop? Why did we make one in our first command of the lab? Is that good practice or bad practice? Well, it's really good system administration. really bad for putting into something that's going to execute where you're not around, right? So there's that kind of stuff. So yeah, Colorman, thanks for hanging out too. I know I see the YouTube stuff every now and then, but I haven't been watching it as much as I probably should. But you guys are welcome to hang out in either of these two chats. We have all this kind of stuff here. Also, all of this stuff is persistent up in the Discord for the most part. Discord is free for anybody that wants to hang out in there. And you can find my Discord if you're on the YouTube side, which I know a few people have been in and out of there. In the Killer Coda site, you can actually find, if I go to my creator, if you go to our lab link, and go to Hetanis here, you should be able to see on our profile our Discord link there. So there's a way to get into our Discord and that kind of stuff as well. So you guys are welcome to hang out. Look, this is one of these things where you get as much as you want of it, right? You take as much time spending with engineering and Linux as you can. I would advise people spend, at least like 10 to 15 minutes a day doing something. It's the same way, like if you told me, hey Scott, I want to get in shape, I'd say, well, you probably spend, and you're out of shape, you spend 10 to 15 minutes a day walking. The Army used to say at least 28 minutes of cardio, right? But like at least get up to where you're walking, go do one of those couch to 5K, which is 30 minutes a day. And I'd tell you to start there. Same thing with systems world. If we're talking about it and you're like, hey Scott, I want to be a systems engineer, and then a month later I say, how much systems engineering did you do this week? And you're like, not any. And I'm like, do you really want to be a systems engineer? We gotta, like, I can't tell you guys how to spend your time, but I can tell you a lot of this stuff, even if it seems super simple, get your hands on it, and over time you'll find that you are the person who knows how to do all this stuff. And I've been doing this stuff for 20 years. I just do simple things well. That's all I do. So, all right. Let's see. So we did all this stuff, and we check, and we say, look at you learning Linux. You executed some commands and counting loops, understand how they're used and all this stuff. Here's some more information, which is the tldp.org, which shows you some more information about Bash. And you might say, that's a little outdated. I say, yeah, that's like 20 years old, but that's still active. That's still accurate for us Linux engineers. So now I got a bunch of questions over here, and I'm gonna do a little hourglass here, and I'm gonna say, on the hourglass, this is your time to reflect on the lab and answer those questions for yourself. We'll put it 5 minutes. I'm gonna sit here and sip some water. Maybe go get some more water here. So think about that lab. All the questions are over there on the right. And think about some of those things. If you need to, go reference them, right? But you can feel free also to throw them into a notepad and answer them for yourself so you have some information about it. Also, I don't know if my little Ranger alerts have been coming up, but thanks for the follows. A few people recently followed. You guys are welcome to hang out and talk shop or do whatever. I'll be right back. Robodom's in charge till I get back. Ah, Robodom is ruling with an iron fist, I see. Alright. Yeah, I've been trying to give more time in between labs. Like when I finish a lab, let's just say one person was, let's say nobody's doing the lab. That's fine. But if one person's doing the lab and I just go run off into the next topic, I'm trying to give a little more time for people to, if you are doing this, maybe there's only one person that's doing it, but they want to chew through and think about what's going on, then I'll just stand over here like this and be like, I'm just a guy who's a hero for fun. I love it. I love Saitama. So funny. How many labs do you run for this stream? Well, we've done 6, 7, 8, and 9 now, so we've done those 4. And Rhoda, I got nothing to do today, man. My wife's out of town, my son's not here, so I mean, I'm just kind of gonna be doing this most of the day. I might even take a break in the middle and do like I did yesterday and run the. I did the networking one yesterday. I didn't finish it all though, but I might run the high performance compute recording in case anybody wants to watch that. And then I'll be just sitting here working on stuff while I let that run. So if anybody wants to do that, we'll do that. Yeah, family's away, time for Linux, and it's me like this. Do it live. We'll do it live. It's one of the funniest, stupid. And then that, I can answer that for money. All right. So you guys finish up the lab and asking yourself these questions. Reflection questions are designed so when you do anything, kind of like that conscious competence model, you could literally have went through any of the labs that I have and just next, finish. And congratulations, you're basically a Windows admin, right? That's awesome. I guess that's fine. You press the button a bunch of times. But to really learn some of this stuff, you want to spend a little time kind of mulling it over and being like the old philosophers and thinking about stuff, right? Philosophy just means the love of knowledge, right? So you're sitting around and thinking about like how does this work? Like, and I tell people all the time the difference between an administrator and engineer is the administrator runs the commands and does the things, and the engineer runs the commands and does the things. But the engineer knows why the thing works the way it does, and the administrator is just running through the tasks, right? But an engineer probably makes $60K more a year on average than an admin, right? At least on the low end. So one of the things that we strive for is to be the engineers, not because we want the title. I don't care. People have called me engineer. They've called me architect. They've called me principal. They've called me late for dinner. They've called me whatever they want. I do not care. But for me, like outside of work, it's the pay, right? Like I want. We were talking earlier about how engineers relax. I want to make a lot of money in my job that is difficult for my brain, so that when I'm free on my free time, like I was thinking about this. If I want to go get lunch right now, I can go get pretty much whatever I want. I don't have to like check the bank account and stuff. Like I remember when I was in my teens and 20s, I'd have to check the bank account before I went and ate something. And I told the wife, like that's kind of like how I feel like I made it. But also my point in saying all that is like engineering can be kind of like a change in lifestyle. Actually, the way I told my wife I knew I had made it, again jokingly, but it's kind of true, is that the one time I went to go get gas one night, this was years ago, I was in my late 20s, and I went to get gas and I didn't have to check my bank account before I got gas. And I remember thinking, that's like one of those life things where it's like, God, man, like all my life I've always had like not enough to, just fill up half my tank or whatever. But then when I had been engineering finally for some time, it was finally like, no, there's going to be money in there for the gas. Like, it's not a big deal. But it was when I was younger. Trust me, I grew up I had 5 brothers and my parents did not make a lot of money. So we were just under what you would call like middle. We were definitely like lower class economically. If you guys didn't know that, I haven't checked your bank account to make a purchase. Yeah, right, Robert. That's why I want you guys to do this engineering stuff. Is because people will pay you a lot for this, but it takes time, right? You got to spend time with it. You got to learn this stuff. All right, so that's conditional counting loops. So now we get out of all of those first 9 labs that we've done yesterday and today. The first 9 labs are all about Linux as a system. Now we're starting to set things up in Linux. So these are discrete tasks and playing with technologies that you will do as an engineer. So all these things were called Let's Do Linux. Now we start calling it Let's Do Linux configuration. So this is a shift in the labs where now, and see how the lab goes to 100, because the 100s are all the ones that deal with this. So NFS, network file system, NFS, is going to be, even though it's much slower than all these other types of tools, it's like old reliable. This is like that little diesel generator sitting in the corner of an old shack. NFS is always there, guys. I don't know how to describe it, except it's like one of those little like toy dolls in a movie, like in a horror movie, where they throw it away but then it's back, and they throw it away and it's back. Or if you've ever seen what is it? Mo throws Barney out and he turns around. He's like going like this and he turns around and Barney's sitting back on his stool. That's basically how NFS is. I've never worked in my entire career in a Linux environment that doesn't have NFS in it. And you say, wait a minute, what about up in the cloud? Oh yeah, they call it EFS in Amazon, but it's still there, right? There's still EFS, and EFS is still super convenient because I can just bring my boxes up, have an EFS, and have them pull their configurations down. It's super convenient. So, man, NFS, it's here. Hold on, if you guys have never seen that scene, Mo throws Barney out. If you've never seen this scene, you know, Mo throws Barney out.
Barney, how do you keep getting back in?
I'm a drunk. I don't know nothing about how I do anything.
That's an old favorite from when I was a kid. But you see, he had to throw him out like 3 times, and then he went to do it again. Yeah. Anyways, all right. So let's do this one. We've got this whole setup, and it says your team has determined they need an NFS share to facilitate file system access across multiple servers from one central location. That's NFS. Robodon, my point is not that you can't get rid of NFS. I'm just telling you, like, NFS is always there. So at some point in some engineering decision before you got to some team, somebody was like, we could use NFS for that. By the way, I don't have any problem with NFS. I'm not saying it's a bad service. I'm just saying it's noticeably slower than all kinds of other things. But it's like old reliable. It's always there. It always works. So we're going to set it up because why not? Like, this is something that you will probably maintain in your career. You will probably have to add a share on a box. Why don't we learn how to do it, right? So we'll deploy an NFS server on node 01. We'll share out a file system from that for anybody to connect to. And then we'll verify that the system is being shared out. The file system, right? That Simpson scene will help to understand NFS. Yeah. It's not that you can't get rid of NFS. I'm just telling you, it's always there. Like, I know I've got some Linux engineers on, with 40 people here, there's got to be a Linux engineer. Guys, I guarantee you NFS is probably in that environment. And they're probably like, wait, think about it. Yep, NFS is there. It's doing something somewhere. All right. And there's nothing wrong with it. It's a supported protocol. It's fine for what it is. I love using it for configurations. If I have a lot of boxes that all come up and need to grab a configuration and pull it out, it's pretty lightweight. It's great for static configuration files and like how a system is built to a certain baseline. It's great. XCAT uses it. XCAT is a tool that does deployment. It's called Extreme Configuration something tool. I don't know. You can look up XCAT if you guys want. We have a lab that does it. I've set up Samba because I have a low Windows machine at home. I can access the files from any of my PCs. Yeah, movie time. If you haven't seen this, for some of you guys, as you think about this, let's go look at my Homelab real quick. This box, hostbox. So hostbox in my environment is my export FS will show you, or show mount -E will show you what's mounted or what's exposed. These are the shares that I'm sharing out to the world from this box. Now, I also have those same things as Samba shares, but these are my NFS shares. Now, look at the ISOs real quick. We'll CD to ISOs, and we'll do an ls-l on ISOs. There's all my ISOs in my Homelab, right? There they are. Boom, ISOs. Then I come over here, and if I go to any of these machines like NixOS, and here's my NixOS, here's a list of all my library ISOs. Those libraries are the exact same libraries right there. In fact, the NixOS is right here. NixOS GNOME 23116510. That's the one that's mounted on this box, and that's how I built this, is because NFS is being shared out. XCPNG can have an NFS ISO library, and then you can share out and connect it into any of your virtual machines that you build up and down your cluster. Super convenient, super easy. Is that fast? No. But for an initial build or like a prototype of a system, it's pretty fast. I didn't have to pick up a CD and go put it in a virtual machine that, by the way, I can't put DVDs or CDs in this box anymore. None of my boxes have DVD players on them. But a .iso is that format. I can download it, put it up here, share it out, immediately have it. And because it's Samba, look, it's also over here. So I come to my Windows machine, I go to, not data, ISOs. There's those same ISOs right there. So I download them on my Windows machine, I put them in there, they're immediately shared out here, and then all the way through my environment. So that's NFS. NFS is doing all that stuff. Super convenient, super easy, right? So our task here is to build an NFS server and a client setup and verify its full functionality. Make sure everything's flowing. All the data, it's like, have any of you guys ever played those games where they have like a data source over here and then, or something over here, and then they've got these little pipes and you've got to spin the pipes until the data flows all the way to the end, or you've got to do the lasers. They like doing this in like puzzle games or horror games where you've got to turn everything until the laser goes all the way through to the other side, and then it unlock, or the circuits. It's a lot of times it'll be like circuits and you'll have to turn all the things so that it flows through. That's how I think of the systems world. Everything in the systems world is, I turn this on, I turn this on. I make sure that they connect. They don't connect. Why do they not connect? Are they not talking on the same protocol? Are they not the same type of system? Everything is chutes and ladders. Everything points to everything else. And then when I start to when I finish, as long as everything's communicating, everybody's happy and nobody bugs me, and I can just sit at home and watch Netflix or whatever. Given a bash prompt and 2 servers, complete in the allotted 60-minute time, complete all activities in the lab, have NFS communication between the server and the client. That's what we need to do. So, here's our solution. SSH to node 01 and install the NFS kernel server. That's the name of it in Ubuntu. By the way, look at that. We said to install one thing, and look at what it did. It did all these things. In fact, it installed a lot more things than we wanted it to, but it's because they're dependencies. The package manager is one of these necessary evils, but it added all these other things. So now if I look, I only said to do this, but it also added, I only said to do NFS kernel server, but installed NFS common, which is the client to connect, and also gave me whatever this NFS ID map 2 crap is. I don't even know what that all is, but it's there, right? It's a dependency. So I come down here, and I want to make sure that the service is running, and it shows that the service is running. It's active. I see a process ID for it. I can see that's running. I can go listen. I can see that I'm listening on port 2049. 2049 is a common NFS port for listening for an internal connection. And then I do a show mount -e to see if anything's being exported, and, well, it kind of makes sense that nothing is, because we didn't export anything yet. So it says all these things. I'm going to check for the firewall status to make sure that the firewall is not on the server. And then I'm going to make a directory called share, and I'm going to share out that, I'm going to make that directory as owned by nobody and no group. So if I do an ls-ld on share, I'll see that it's owned by nobody and no group. That's what I want. Then I'm going to go look at the Etsy exports directory. I'm going to hit Shift G and O. So hold on. What happened here? My thing stopped working. Hold on. I don't. Wait. Test. There we go. Okay. My closed captioning had broken. Did you guys notice that? Probably nobody even noticed that, but I looked over and noticed it, and so I knew. So here's my NFS. I did Shift G to go to the bottom, O to go down, and then now I'm going to add this line, which is going to say, go ahead and share out /share to everybody. There's no restriction right here. There's any address with read write, so people can read write to it, sync, and no subtree check. Those are all just default variables that or default values that we can leave in there. We can go look up that connection if we want to, but I'm going to hit right quit. And then real quick, let's do a show mount -e again. We just changed that config file. Do we think that that is immediately being shared out inside of our Linux box or not? Is NFS reading the Etsy exports in real time or not? And also, why would we want it to, or why would we not want it to? This is a thing for us to think about here. So I want you to think about that for a second. And then we're going to test, right? One test's worth 1,000 expert opinions. It is not being shared out. The reason is because as a security and stability tool, this is a function of stability and security in the system, you have to restart a service before that service will go and read any of its basic configs. Now, let's talk about it from a security standpoint. If somebody could modify that file, but they can't restart the service, you've protected against maybe that security issue of people doing that. And then the other one is stability. What if it goes to look at that file and somebody was working on it and they did like a :W, which is just to write, but they didn't leave the file, and then they kept working on the file and it reread the file and the file's in a broken state, so it breaks everything. That would be terrible. That would be useless, right? That would not be something we'd want to do. Hey, thanks for the follow. Hopefully this stuff's useful to you. So let's run this and restart the NFS service. Restart the server, and now we do see share being shared out. Now we exit, we go back to the control plane node. We have set up a server, we have shared out, and we have a share that can be connected to anybody that can hit this node. And we don't have a firewall on or anything to stop us. We have a different lab that shows us how to set up a firewall. But now everything's set up here for connection in. So now we're back on control plane. We hit check. All that validation checks for is that server is working. And I say, so far you've set up an NFS server and share. Now we have to connect to it from another system. So here we're going to install the NFS common client. We're going to mount that share to /MNT on this box. By the way, we can mount it wherever we want, but we're just going to use /MNT for now. And then we're going to make node 01 share permanent setting in here with the etcfs tag. So we'll do that so that it always comes up. So let's install the NFS common. While that's installing, we can look over here. And I said, why do you now have 3 NFS packages when you only told the system to install the one? Well, that was dependencies, right? apt will go out and get all the dependencies it needs. So it's like that little otter pulling everything in and going like this and feeling all the little rocks and making sure it has all the things it needs so that the package will work properly. It used to be, guys, that used to be one of the most maddening things when I started. And I'm not trying to be like, oh, stay a while and listen like Deckard Cain. And I'm not trying to like tell you guys I walked uphill in the snow every day or whatever. I live in Phoenix, so there's no hills and there's no snow. But I can tell you this, it was a effing nightmare to go find dependencies for packages when I first started this. It was like, oh, we're gonna install that and we've never done it before. Here we go. You know, like it was this package is needed, that package needs this. These apt and yum and DNF and these tools that do it for us, I'm not going to say they make our lives easier. They just make that part of it not a problem anymore, and I love it. We have other things to worry about now. But my point is, it's great how much these things do for us, because then we don't have to worry about those other pieces. And this is the same thing I tell you guys as engineers. If I toss Robodom my keys to my truck right now, and he goes and he turns my truck on, and my truck just starts, and he's going to go grab lunch or something because I'm thinking about lunch, he would not have to get out and open up the hood and go look under the hood to make sure everything's working. The truck started, so he would go about his day. He might check the mirrors and stuff, but he's not going to open the hood up. However, if he goes to turn the key and it goes and it stops, well, then he's probably going to be like, there ain't no gas in it, right? He's going to be like that guy or whatever. But the point is, he's going to have to go troubleshoot, and it's the same thing with this. If everything works, everything works. But sometimes we have to go dig in on where these things go and that kind of stuff. I probably should make one of these labs about how we set up more sources in apt. We set up the sources in some of the labs, but I never really talk about what that looks like. But okay, we've got all the tools we need. We can do a dpackage, dpkg-l and grep for NFS now. And now we have NFS common. And then we have these other things. That's from the other one. That's the same one as the other server. But this is new. We didn't have this on the other one. But those are NFS client libraries, right, that are useful. All right. So now, let's just do a simple little mount test. We mount from source to destination. Let's just see if we can mount that system. And if we did mount it, we should be able to do a df-h on mount, and we should see that mount is now mounted off of node 01/share. That's that other box. So, a couple of tests. I should be able to touch a file in there and see that it was built with nobody and no group, but we did test it and we did build it. And then if I unmount that and pull it out, but then I do that touch mount ls, this is a different file. Let's say I rm-rf mount test, right? And then I do an ls-l on mount. There's nothing in there. Then I remount it for fun, and I go look at that again. I just go look and mount. It's back, but it's that other file. Whereas here it was a local file. So that's an interesting question. I don't think it asks you over here. But why, when I created it out in mount test, why was it automatically nobody, no group? And then when I unmounted it and made it local, why was it automatically root, which is my root owner? And what's the behavior of that? And it may help you to look at mount grep-i node. Whoops. Let's clear that. Node 01. We just want that one. Why might the system, by the way, it's NFS 4, that's the default system that we have. Why might it have automatically built that file that we touched over there with the nobody and the no group? Let's just touch it here local again so you can see the difference. Right? And by the way, here's another thing. What happens if we remount that file system? What if we mount that file system over the mount that has that test 1 in there? What happens to test 1? That's interesting behavior. Where do you think test 1 is? Do you guys think that we can get at test 1 that is now we have a mount point over the top of it in our system? So we have a test 1 that's there out on the NFS share that we're looking at. But now we have in/mount a test 1 file that's been, I don't know, clobbered, if you want to think of it like that. There's something over the top of it. And if we unmount it, is it back? So if I umount and then T and I look at it again, it's back to the other one. Do you guys think that's dangerous to do? Like, would you want to do that professionally, to just have things hidden underneath other things? Something to think about, right? So I want you to let that question sit there for a second. Would you want to have them? Oh God, keep them guessing. That's funny, Robodom. But also, I don't want to be guessing. I don't want my system to be guessing. I would never want that share to not come up. Maybe the NFS share is down, and then my system goes and configures itself off of some other thing that I left there. I would try to keep this directory empty. That's me. But that being said, no, there's no. It won't delete it. It won't clobber it. It's still there. It's just mounted over the top of it. Okay. So, all right. Somebody said stop and write me a conditional loop. All right, we'll write a conditional loop. We just did conditional loops in the last lab too, right here. So we were just doing conditional loops. But over here, conditional loop looks like this: while true, do, uptime, sleep 5, done. That is a conditional loop that will run forever. Oh, and by the way, I didn't even ever tell you guys the answer earlier. Earlier I asked, what's the difference between a conditional and counting loop, and why would you, I mean, we know why we would use them, but what's the primary, like, computer science-y difference between them? I never even got around to that. I say you just did, yeah, I literally just did this. But this conditional loop will conditionally test to true forever. So now we're stuck in this until the lab ends in 42 minutes. But no, you guys are welcome. By the way, you guys can use your points however you want around here. I got a whole bunch of little point things. But that is a conditional loop. And if you wanted a conditional loop that really had a condition, we could say something like count equals 0 and condition equals 10. And then we can say while test, I don't know, count is less than condition, right? In here, then we can say then echo I am counting $count, and then we can say sleep 2 done. And by the way, what's this gonna do? It's gonna break. It's not done, it's fi. That was my bad, guys. Fi. If then What? Oh. Oh God, you guys gotta stop me. It's wild dude done, man. Jesus. Guys, this is how you know that I'm like, yeah, this is gonna be an infinite loop. But how do we know it's gonna be an infinite loop? Well, right there. I'm not incrementing it ever. But that's good to know, right? Like I made a mistake. And my mistake is right here. I need to increment count plus plus. And then now it's gonna properly increment. And then it's going to go, and this is going to stop at 9 or 10. That's another question. Will this stop at 9 or is it going to stop at 10? Inspector, you passed. Inspector has been very clear to us over the years, at least a year, but maybe a few years here, that he only inspects diameters. He does not inspect anything else. That's all Inspector does around here is inspect diameters. He does not adhere to any other types of inspection or any other type of testing. He's only here for the not radiuses, not radii, it's diameters. That's it. He's got no point. He's got no stomach for any of that other stuff. So, all right. Anyways, if you guys don't know, Inspector is often down in the Discord talking shop. So we have to make this percent. So that was the loop. Anyway, so back to this. We've got a. Let's check where we're at right now. df-h, I don't remember where I left it off. df-h on mount will tell me it is not mounted right now. So I can do a bang on, actually I'll just do a history real quick on grep-i for mount. And here's all my mount commands. And I can just bang 19. So bang is an exclamation mark, right? And it'll remount it for me. Now I do a df-h on mount. And I have it mounted again. And then the next thing we want to do, let's umount -L mount. Oops, -L mount. That's a lazy unmount. You don't typically want to do that, but that's fine, especially not radii. Yeah. And now we're going to go look at our etcfs tab. And our etcfs tab has some other nice stuff going on in it about how the system was mounted. But we're going to add this line, node 01. That's the path to the share that we want to mount. And then we're going to say mount it to mount. Use NFS as the file system. We're going to give all the defaults. We'll take whatever defaults the server gives us and 0, 0. Now, if we break this all down, node 01 is the location that we're mounting from. Mount is the place that we're mounting to. NFS is the file system of the type. That can be ext4, xfs. In this case, it's NFS. We can also explicitly give the NFS version, but we tend to do that in the defaults. So if we wanted our client to force that server to go back to client version 3 or server version 3 instead of we want to connect on version 3, we could do that here instead of defaults, but we're not going to do that. And then we have 0 and 0. This 0 says I will never do an FSCK on this file system. It's a remote file system. This should always be 0. And this one says I will never do a backup on it. That's what those last two mean. They are not often used by anybody, but that's what they mean. So if you ever go look up an etcfs tab, this is the mount point, or this is the mount location where we're mounting from. This is the mount point where we're mounting to. This is the file system. These are defaults, and then 0 is the number of FSCKs. If we're ever going to do an FSCK, never. And then this is if we're ever going to do a backup. Escape :WQ, and this is an old admin trick right here. This is an old. I'm teaching you guys the old ways, something that I had to learn when I started. And by the way, I tell you guys this. I had a great mentor when I first got into Linux a long time ago. I had a really great mentor. His name was Matt Lynch, and Matt Lynch had been a Marine. He was an infantry guy. I was an Army infantry guy. He was a Marine infantry guy, so we got along pretty well. But I'm going to do a mount -A. He taught me a lot of really useful stuff just by watching him, and he was very sharp. When I do a mount -A, hold on real quick. df-h /mount, so it limits down. We're locally mounted, and I'm going to do a mount -A. Mount -A does this really awesome thing where it's going to mount all of the file systems that are known out of etcfs tab. If I do a df-h on mount now, and it works, then I now have what I consider a reasonable expectation that if this machine goes down and comes back up and it runs a mount against everything in its etcfs tab, it will not break because of that line that I just added. So that is a sanity check for me. Because by the way, anybody here knows what happens if you have a broken Etsy FS tab? Bad. It's real bad. If you have a broken Etsy FS tab, your system's probably dropping to rescue. Well, if it's one of your primary boots. NFS mounts typically aren't a problem, especially if you put soft on there. You make them a soft connection, not a hard connection. Yeah, Robodom, thanks for coming by. I appreciate it. Kind of running everything for me. Will you do one last Discord before you go? Let people know that we've got a Discord out there that you guys can play with and kind of talk shop in. Yep, there's our Discord. You guys are welcome to hang out there. There's the book. That's the book that I'm going through over here. And there's all that stuff. All right, so we come down here. Oh, by the way, I mentioned this earlier. Let me see. Oh, there's finally been one other discussion post in my college class. So I'm in a doctoral program, and the college weeks go from Thursday to Wednesday, and we're on Saturday morning right now, right? Saturday? Yeah. So Thursday and Friday, I was the only guy that posted, and all the way up until this morning, nobody had posted in this class. And it's weird because we're in week 6 and we've been doing this for, months now. And I'm really surprised that nobody had posted yet in this class. When I finally did like my 4th post today, nobody else besides me and the professor had posted, and I just thought it was super weird. We have a requirement, you got to answer the 2 questions and you got to do 3 other posts. So I just thought it was super weird that I was like, what's everybody waiting for? We did just have a really big paper that we finished. I pulled this paper. I didn't show you guys the paper, but I pulled it up before. But anyways, it's an analysis of this case study, and anyways, I did external funds needed analysis, which is a type of analysis that tells you if the change in sales or the change of revenue generated by a project offsets the variable cost that's added, like the variable liabilities, I guess, that are added as you build it, is it worth doing the project or not? And is there going to be return on investment? And also, are external funds needed for you to purchase it? That's the other thing about it, right? And that was my type of analysis on this project. Anyways, the point is, we had this big paper that was due last Wednesday, and then nobody, it's almost like everybody quit the class. I was like, what the hell? And I just looked right now, and somebody's finally posted the other part of the class. So let me go look at it real quick. Did somebody respond? And maybe they responded to me. I don't know. Did somebody finally answer? Nope, they answered just for their own thing. That's good. Oh, I might have messed that up. Anyways, we'll be all right. We'll recover, guys. We'll recover. So, all right. Anyway, so we do a really quick little final check. We write a final check in there. We see there's nobody in no group, and then we hit check, and it sets it up. And I see right here, look at you learning Linux configuration. You set up an NFS share and connect it to it from another system. Now, there are so many other things that we could consider in this lab around security. Let me show you some stuff here. So SSH node 01. I don't think I say it over here. Export FS or show mount -e. Either one of these will show you that things are being shared. You can also just do like a tail on Etsy exports, and that would show us the end of Etsy exports. This is what we added. And I might say, could you lock this share down a little bit? Could you show, maybe if I did like an IP adder, and I did a grep for 172, could you make sure that this is our 172.32, yeah. So my IP address on this host, could you maybe lock this down so that now you're only sharing it out to, instead of everybody in the world that wants to connect to this, could you only share out to this network? Could you do that? And then you say, maybe. And then I go up here and I say NFS for export example, right? And then now here's an NFS for how-to for Ubuntu. Look, this is for Ubuntu. And we come down here and it tells us how to, look, I could set it up with this value instead of the value that I use. So I'm gonna link that to you guys that want it down here and over on the YouTube side. There might be somebody hanging out on YouTube still, right? But this is the link. This is how we would go find it. And I go, I could secure that down a little bit. I have to modify this a little bit, but I can modify that real quick. Let's see. Here we go. So let's make sure that we can do this. Whoops, right here. We're gonna IP adder, and we're gonna see that our, I know that's a mess because it's so wide on my screen, but our ENP1S0, we're 172.32.2, so we need to, and it's a /24, so we're gonna VI our Etsy exports, and right here we're going to change this, right, and we're going to share it to everybody in this network with a /24. The /24 matches the first 24 significant bits of the IPv4 address, which is 172.30.30.2 in this case. It matches the first 3 octets perfectly. That's what a /24 means, right? So I'm going to escape :WQ, exit. I'm going to unmount real quick. Unmount that. I'm going to do a mount -A because you guys all remember that it's going to read my Etsy FS tab and mount it. And I'll do a df-h and I see that it's there mounted. Now, that proved that worked, but that was already working. So now let's break it, right? Because I tell you guys often in engineering, you know, when we lock a door, don't we at least have to shake the door and make sure that it's actually locked? Like you put 3 doors in a building and then you lock one of them, but then you never like rattle the door to make sure it's locked. Well, let's test this. Let's go back to node 01. Let's make that some other thing. Oh, by the way, we read the Etsy exports, but did we ever restart the service? We did not restart the service. So that's another thing too. If I do a show mount -E, it's still mounted to everybody. So I messed that up actually. Hold on. We didn't test anything there. We never restarted the service. Now we do our show mount -E and look at share. Remember I said it doesn't automatically read it? So that was me. I was dumb. Let's unmount, make sure it's not mounted. Let's do a mount -A, and it was denied. I should be allowed interesting behavior, right? We're finding out new things about ourselves. Oh, did I use the wrong one? ENP1S0. Oh, I used the wrong network. 172.31. Okay, it was 31. So, well, we did just now rattle the door and make sure it was locked. Now let's go fix it. Hold on. That was my bad, guys. We're on the one network. Now, we're going to do that. We're going to do our show mount -E, see it where it was, restart the service, see it where it now is, come back over here, mount it, still access denied. Why is that on? NP1S0 170.31 24. All right, let's go. We're doing something wrong. No, don't want to do that. SH to node 01. Show mount -E. That's super weird. That should work. The 0 should match to the 24. Don't see anything else. Share should be 172.31. And the .0 doesn't matter because /24 only matches the first significant bit, so it doesn't matter there. And that's super weird. That share should work. Hey, Big Brain, thanks for coming by. We're just, yeah, we're working on stuff. I don't know why that's not, you know what, we're going to be explicit. We'll give that exact node. We won't even try to do the other stuff. We'll give that exact one. I know that's the exact IP address of that machine. 172.30.1.1. Yeah, he's 172.30. Wait a minute. He is 172.30.1.2. He is. Let's just verify. Oh, whoops. Show mount dash E. Cat Etsy hosts. 172.30.1.2 is control plane, so that should be good. And we should be able to mount dash A. Yeah, there's something else going on there. Well, anyways, you can leave it open to everybody. We were just trying to get that to work for the lab, so that's not a big deal. But the point is, you can secure that down if you wanted to. And apparently I can make it so secure that nothing works, so that's wonderful. But anyways, so look through those. I'll leave this, I'll do a little hourglass again. And the hourglass is, you know, you'll have, think about the lab and answer those questions for yourself. Right? That's the goal. Think about the lab, answer the questions for yourself. Do you find door secure? Yeah. The door is so secure, we're like the Mr. Meeseeks. We'll take 2 strokes off his golf game, and we take all the strokes off his golf game when we kill him. And that would take 2 strokes off your golf game, technically, because all the strokes would go off your golf game at that point. So, it's pretty good logic, I think, for Rick and Morty fans. Alright. So think about that. Think about the configuration, what things you can do. Normally, my only Rick and Morty reference on here is this one. I can answer that for money. I love that reference as well. And then the recent one that I just put in, it's this one. I'm just a guy who's a hero for fun. Anyways. Alright, I'll hop back on stream here in a minute, but I'm letting you guys think about these labs. Think about the questions on the right. Think about, you know, NFS configurations and what you might end up seeing or dealing with. All right. All right. A little bit more time to think about that stuff. I'm just sitting here drinking some water, and then we'll get into the next set of labs. Check on Ranger Dog too. How's Ranger doing? Ranger is out. Ranger is out hard. He's conked out hard. That's Ranger Dog for you. Alright. So think about the lab. If you were doing the NFS stuff, what worked well, what didn't, we would probably have to go spend a little more time on figuring out why that share, even though it was saying that it was allowing 172.30.1.2, it was not allowing that box to connect in, right? And, I mean, I'm less invested in it than I probably should be, but it's probably a simple little fix. We just have to go dig around in it to get it working. And I'm less invested in it than I probably should be because I'm just not running over there and fixing it. But this is what we do, right? This is us systems engineers setting things up, figuring out the problems, documenting it so we never have it come up again, that kind of thing. And now I know probably some of you are like, well, that seems really, really manual, like building that out by hand. So we do have an Ansible. If you jump over to the Ansible labs, we have an Ansible lab that does this NFS configuration for you in one playbook. So if you were like, okay, that's interesting, let's see it, you know, you're like, now let's see the business card or whatever. What's the one where he's like, now let's see the, I think it's one of the psychopaths. Was that American something? I think it's American Psycho, isn't it? Anyways, that was a weird movie, and I haven't seen it since it first came out. But the point is, let's wait for this to end. We'll wait for the ad break to end, and then we'll get going to the next part. But if you guys want to see that other piece work, let's stop it over here. And it's an ad break, so I guess I'll just wait till the ad break's over. But we're going to go to the next one, which is configuring Apache. So if you've never set up an Apache server, you never stood up a LAMP stack, Linux, Apache, MySQL, PHP, part of that is this. Part of that is the Apache web server. So I'm going to link this to people over on the YouTube, and then I will link it to people over on the Discord. Not on Discord, rather on the system here. So it'll be pinned. I will leave it up there for 30 minutes. There we go. And all right. So we're all done with that. Commercial, the little break for commercial should end here in a second, and I'll pop back up here. Is everybody that's back from the commercial? I think you guys should be back. Some of you were probably on, some of you might not know because you're probably on Turbo or something, but if you just got back from the ad break, let's go to this next lab, which is configuring the Apache server. This is a hands-on build of Apache from just a basic system. We're just going to install some stuff. We're writing the C code. Yeah, I always do escape :WQ all the time. That's how I. And I know people are like, oh, you could do like Shift ZZ, and there's like all these other ones, and I just. You guys will find out. I don't know 100 ways to do one thing. I know one way to do one thing, and it always works. And then I don't go look for other ways to do it, which is one of the reasons. Like I have no problem with like NeoVim or any of these tools that are out there that probably make certain people who use it all the time slightly faster. But I don't think that some of the stuff I see, like when I see some of the guys running around like that are just like they're just doing stuff like they're rats on Ritalin or something, rats on cocaine. I don't. I just can't get behind it. Some of the stuff that I see people doing on streams and stuff, it's like, God, man, that probably works for like 0.5% of some small little subset of engineers. It does not work for everybody. Not everybody has to do that kind of stuff. Most people probably need to work on the basics and other things well before they need to understand the intricacies of 30 ways to do something in NeoVim. You know, that's my point. I don't care what tool. You guys use any tool you want to get in the systems. I use Putty, do whatever you want. But yeah, I always use the escape :WQ, always have. All right, so let's go. By the way, this Apache configuration, this same one shows up in the Ansible labs as well, and then we do it automatically through Ansible. But let's go this. Your team has determined they need a website to test deployments rapidly. They want like an internal website. Your team, you have been tasked with installing a web server on Node 01. So Node 01, and then dpackage-l. There's definitely no web server on there. Well, no Apache 2 web server anyways. There could be other ones. Capture the version and install Apache 2 packages for your records. Sometimes you need that. Sometimes security wants to know that. They probably have scanners, but the point is you should have it documented what version of a tool you're using, especially if you're exposing ports. Verify that Node 01 is listening on port 80. That's important. And then just verify that the basic web page is working. That's the first part of the lab. So we'll SSH to Node 01. We'll check to see if Apache is there. It is not there, not running in any way. and then we'll install Apache 2 on that box. This is a package manager install. It's pretty straightforward. It's just going to install everything we need. And when that's done, let's look at what's been installed for Apache. What Apache named packages do we see? There's a bunch of them. Bin, data, utils, other things that we needed for this to work. So then we'll go look, and the question is this running? It is running, right? So what is the behavior when we install Apache? Does it automatically get turned on our server? Did you guys see me press a button to turn it on? Or did you just see me install it and then immediately it was on? This is an important thing, important behavior to know, because if you don't run firewalls in your organization to lock things down, and somebody accidentally installs a web server at an older version, guess what you've just done? You've just exposed a possible vulnerability, another threat vector, another way of attack, another, people call them attack vectors, they call them, I don't know, there's all kinds of names for them, but the thing is, you have opened up yourself for another way for somebody to connect to your systems. That probably isn't what you wanted. Then we come down here, we do see that our system is listening on port 80. It's the only port it's listening to. LSOF will tell us that. For this process, it's only listening on port 80. And then it's also only listening on port 80 for Apache 2 as well. So Apache is listening on port 80. We know that. It's not listening on any other ports because we don't see any other ports come up. If we really wanted to, we could just do ss-ntulp and go physically look and go, I see 4096, I see some other stuff, but I definitely don't see anything that's like 80 or 8080 or 443. I really just see the listening on port 80 right here. I don't see any of those other ports over here. Where this is our port numbers here. Okay, so our system is doing what we expect it to do. Check the firewall. Firewall's off. It's in an inactive state. Go back to our control plane. Let's curl that node. And look, there's a web page. We got a web page back. It's HTML. Not super pretty because, by the way, we're not looking at it through this way. If you want to look at that as a web page, you can actually look at it right here. You can go up here in the labs and go to traffic ports, and it'll be a little bright for a second. But on host 2, you can connect to port 80, and there's our little Apache web server up and running. That is what we just saw in the command line on the other node. So okay, we got that. Got that. That's good. I can leave that open so I can hit that here in a little bit. And I said, do you see the default web page? It's okay. You've set the first part. Now let's see what else the team has for us on the next part. They probably don't just want a base web server. But I say over here, what other packages were installed when you installed Apache 2? Why were they installed? They were required dependencies. We needed them for this to work. I said, when you install Apache, does it automatically start on the system? Is it set to start on future boots of the server? So if we go up here, if we just rerun this command real quick. Oh. If we look at this, we see that it is active running, but right here, we see that it is enabled. Enabled means it will come up on the next startup of the server. Enabled means that it has a symlink in the target wants directory so that it will start up when the system boots to a certain run level. So it'll do that. In fact, it may have even told us that when it installed it. Let's see if we can go back far enough. And on the installer, if we can get back that far, let's see. It should have told us as it installed it. Yeah, look, I made a symlink here for you. This is the actual service, and I linked it over to here. So in here, this etc systemd, or maybe we even ls it. And then if I do more on that, it'll tell me, yeah, this is set in the multi-user target wants Apache 2 service. So it's going to start up when the system boots up. And if I go and delete this link right here, it will not start up when the system starts up. That is simply where that comes from. If you're wondering, like, hey, where does it know if it's enabled or not? That's it. Based on whether or not one of these symlinks exists. We used to do this a lot with the old init scripts, and now we're in systemd. Systemd is very common. But here's the thing: is it's going to no, rel is still .service. Yeah, rel is still .service. Now, some of these pathing are different, but yeah, the Apache's to service is still just a service file. Also, can I show you guys, this is one of my favorite things if we're talking services. Systemctl status system, let's say Apache 2 is okay, right? Systemctl status Apache 2, that's okay. That shows you some cool stuff. But watch this. If you do cat, it will tell you systemctl, the systemd daemon, started Apache 2 from this file right here. And that file is found right here. So that's the file. If I more that file, it will have the, oh yeah, HTTPD is a fork from long ago that Red Hat, or well, CentOS used to maintain. Yeah, HTTPD is a fork. You're right, it is, yeah, the service is HTTPD. So we do systemctl HTTPD start instead of Apache 2. That's 100% true, yeah. And I think I have some web servers. Do I have web servers running in my Homelab? I have some things that are exposing some stuff, but nothing to show you relevant to that, I guess, for that. Okay, so now this is where it starts to get interesting. Anybody can set up a web server. I think you guys all can look at that and go, yeah, Scott, I can set up a web server. All right, but now can we split it out into 3 environments? So can we take our web server now and split it out so that we have a dev environment on port 80, a test environment on port 8081, and then a QA port on 8082. So can we do 3 different environments off of that one web server and make that all work? And I said, oh, what user owns the main PID of the Apache 2 server running on our system? So here's Apache starting, and it's the www.thedata user. And if I go and I do my LSOF on port 80, I see that the main port is 16545, that's the PID rather. And root started it, but the primary processes that are running are this www-data is the user, okay? If I do an ID, I can see information about that user. If I grep www-data from etc pass wd, I'll see how that user's set up. By the way, that user is a relatively secure user. They've got a user SPIN no login. Nobody can ever log in as that user. Even if they compromise that account in some way, there's no way to log in. So that's pretty good. We know a few other things. If there was a password, it's stored over in etc shadow. And we know that his user ID is 33 and his group ID is 33 for his primary group. Here's some information about him. That's just some information. And here's his home directory. His home directory is var www. So even if you did log in as him, you would just get dropped into var www, which is a document root of the web server, right? So you wouldn't have a whole lot of power. So as you're setting up different listeners, so now we're going to set up some listeners. So let's go look at what's going to happen now inside of our system. So we'll SSH back to node 01, we're there. And if we were to ls-l on var www right now, we would see there's one directory and it's HTML. So let's hit this button right here and make 3 directories through an expansive wildcard process. And then we come down here and we rerun our www. And look, it made a HTML_dev, HTML_QA, and HTML_test directory. It made all those directories for us. There we go. But those directories are literally just sitting there doing nothing. Now we have to open up those ports with the listener. So we're going to set the listener to allow, right here, we're going to say YYPPP, and then we'll just set this to port 80, 8081, whoops, and 8082. Those are our ports, right? Escape :WQ. And now real quick, do you guys think that when I just made that change there, we talked about this earlier, I do this. Do you guys think that any other ports are open right now, or is it still just port 80? Well, I'm showing you, but the answer is only port 80 is open. You will not see those other ports open and listening until you have restarted the Apache service. I mean, that makes sense, right? We talked about this before. Things don't restart automatically. Well, let's go look real quick. We're going to look at another thing here. If we cd to etc Apache 2, sites enabled, and if we cd in there in ls, there's this 00defaults.conf. So if you more that file, it's going to have a tremendous amount. This is hard to read. Hold on. There's a tremendous amount of information to just show us a virtual host configuration looks like this. That's the start of a virtual host directive. That's the terminology. And that's the end of a virtual host directive. And all of this other stuff in there is commented. So let's actually clean this up real quick. PI000. Let's get this crap out of the way. That's not doing anything. I mean, it's useful to know, but it's not doing anything. Let's get that out of the way, and then let's get that out of the way. This is all I need right here to define virtual hosts to listen on port 80. The document root of it is var www.html. That's the default location. And then here's our logging dir for inside of Apache, which is var w. Our default Apache log dir is var www Apache, right? That's the default one. It comes from another location. Error log and access log. Those are two different things. So I'm going to escape :q. I don't need to save that one. But now let's add this testing team down in here in this directory. And there's nothing in here, but I'm going to add these listeners, these 3 virtual host directives. That's what they're called. They're directives. And when you look at them, from what we just saw, you only saw port 80, but now we're going to listen on port 8080, which we opened as a listener, and that's going to go to dev. Then we said port 8081 is going to go to test, and port 8082 is going to go to QA. And you go look up here, and you go, hot damn, Scott did exactly what he said he was going to do, because he's an engineer, and that's what we do. So I'm going to hit escape :WQ. Now, still not being listened to. We haven't restarted the service yet. Now we need to go put an index.html in each of those directories so that something actually pops up. So let's look at this real quick. Here's, whoops. Copy, Control-Shift-V. So there's our dev page. In our test directory, we'll make our our test page. In our QA directory, we'll make our little QA page. By the way, guys, you can spend as much time on these labs as you want, like on your own. You do not need me around. The labs are free. We are still not listening. But immediately when we restart the Apache 2 server and we do that same listen again, now we're listening on 80, 8080, 8081, and 8082. So now we're listening to everything. So then I say, let's check real quick. Are we listening on each of these? Yes. We're listening to all these different ports. So now we run a little curl real quick, and we can see that against our own machine, there's our dev page, our test page, and our QA page. If you don't like that, you can come back over here to the Killer Coda Interactive, and you can go on that node. Well, what's 8080? We'll hit access. There's our dev environment. 8081. Access. There's our test environment. Then we go here. We go 8082. There's our QA environment. QA, dev, test, QA. There's our pages. Have a good stream. Yeah, Inspector, thanks for coming out. Thanks for hanging out. I always appreciate you guys lurking and being around doing stuff. But there's our environments, guys. There's all of our different pieces for this. So, some people are coming back from the break, but the ad break will be done here in a second. So, give 20 more seconds, guys. 20 more seconds and then the break will be done. This one walks you through. And then for question 4, we say, why does the system wait for Apache 2 to be restarted? Well, because if you're configuring things real time and the system's really up, it's not going to check again until you restart it, because that would break things. So that's something to think about. Okay, look, there's our dev. It's on port 8080. There's our test on 8081. And there's our QA on 8082 right there. So for any of you guys that were working on, look, Ranger Dog. For any of you that were working on that, you can just pull up that right here. You can go to traffic ports and you can actually connect in on any of those ports. The default port is still up, by the way. Port 80 is still default. But now we've opened up these 3 other pages on port 8080, 8081, and 8082. So here's 8080 dev environment. I can change that to 8081 right there. That'll be test. I can change it to 8082 right there in the right there if I want to. Right? 8082. That should be my QA environment. There we go. So now people can just drop their code in each of those different document routes for the web server, or web server routes. People call them both document route and web server route. Hey Sony, how's it going? Guys, I know Sony Chiba in real life. He's a good buddy of mine. We haven't trained in a while together, but I've been training like 4 or 5 days a week in the morning with Jeff and his guys over at M1 Jiu-Jitsu. Sony. They only do gi, man. I haven't done no gi like all year. It's really weird. I've been doing just gi the whole time. So for you guys that know Jiu-Jitsu, that's we wear our big pajamas and try to kill each other. So anyways, there's Ranger. What are you doing? Yeah, Sony. We gotta get you back out. They have a Sunday one. I wouldn't be against going tomorrow if anybody wanted to. I think Jesse wanted me to go train over at Legion tomorrow, but I told him I was probably going to be streaming because the wife's out of town, so I got all day to stream. I've been on for like almost 4 hours. I did like 7 hours of streaming yesterday. That's the longest I've ever been on. What? Somebody better clip that if it really did that. I only do. That would be weird. That would be real weird. Yeah, Sony, you should stream too. Yeah, maybe I'll raid over there in a little bit. I gotta go, man. I gotta go eat something. I haven't eaten all day, so I need to get some food in me. But I might run like I did yesterday. I ran an older VOD that I had, and I might run another VOD while I sit here and eat. So we'll do that. But yeah, Sony, if you're on streaming, I'll be hanging around. Core count, I'll have to go back and look at it. But that's awkward, right? Only 2K, man. Well, I didn't say it again. Oh God. Oh man. I'm married. I got a wife. I got a kid. I got a grandkid. Anyways, all right. So that's the system. That's how we do web server configurations, right? Yeah, Sony, I appreciate it. The Apache stuff that we set up. If you've never set up a web server, that's it. It's pretty straightforward, but you might look at that and go, Scott, that's also pretty manual. You did a lot of typing, you did a lot of copying stuff. I agree. That's not the way I want to spend my time. So then that's where we bring in that tool Ansible. And Ansible is almost like, if you guys have ever seen those stupid little animations that like show the little thing come out and then the thing goes like this and cuts it a bunch and then the next thing comes out and cuts it a bunch. Ansible's kind of doing that. It's like a little automation tool that will put whatever you want out on the server and then it will deploy it and then it will restart the Apache and it'll do all these things. So this right here was a very manual version of what we do automated in one of the labs later. So in one of the labs later, it actually says you were so successful that now you made more work for yourself and 10 other teams want you to deploy web servers for them. This is exactly how it works too. Somebody asked me last night, we were talking about web application firewalls, what we call WAFs. And one of the guys was like, oh man, I would never thought that a Linux guy would be stuck doing WAFs. And I said, when you're good at engineering, people make you do anything. You can do anything. You're a Linux engineer. You can do anything. You go figure stuff out. Fucking here's the web application firewall too. I can't tell you how many times I've had other things just thrust on me because, oh God, it's getting worse. Because of all the terrible, just, if you do anything good and anybody figures out you know how to troubleshoot stuff, it will immediately be your problem for all things. Dude, I get pulled in stuff all the time, and people think I'm kidding about this. By the way, I like this. I'm an engineer. I like solving problems, but I'm going to complain about it a little bit on stream because I think it's funny, but I get pulled into stuff that has nothing to do with my job. And I'll be like, guys, what's going on here? And they'll be like, we want you to look at it. I'm like, okay, because I'm a guy who tries to figure things out, right? Like I will, like when we're in a meeting with like 30 people and everybody's standing there like penguins waiting to get pushed off and volunteered, I'll just be like, all right, let me share my screen. Let's go look at this. And I'll just jump in on stuff. And the reason is because what's the worst thing I can do? The shit's already broken. You already woke me up to call me into this call with 30 people. That does happen, by the way, sometimes. There's like a bridge, and they're like, we don't know what to do. Call the Linux engineers. And if you guys think I'm kidding, I guarantee you, any Linux engineer here knows, you guys are, you are immediately pegged as somebody who knows how to solve stuff. Oh, God. Well, yeah. I like, you know why I like it? I like goodwill with my different engineers. I like other engineers to kind of know who I am so they come to me. Because then if people come to me, I can go to them. And that to me is like, I tell people all the time, I have never had, okay, if you take away my college teaching as a professor, I have never had authority in an organization as like a manager in my life. I've had one soldier ever when I was in the Army. I had a soldier that was under me. He was the supply guy and I was the armorer. And that's the only time I've ever had anybody that I've actually been in charge of. What I want people to come to me for is what's called expert authority. You guys know what expert authority is? Expert authority is you don't have to listen to me, but you want to listen to me. Now, your manager, they've got delegated authority. They can fire you. If your manager tells you to do something, you go, fuck you, that's your job. But if you tell me to F you, I go, okay, break yourself on the truth of the fact that that shit's not going to work the way that you defined it. I am a vet. I'm a combat infantryman, yep. Yeah, actually, up above behind me, I've got expert and combat infantry badges, yep. I was in Iraq in 03, so, yep, did all that stuff. Did all that, got all the prizes, got all the... I didn't get all the prizes, right? I got some of the prizes, but not super fun. All right. Oh, we're going to get into monitoring next. So we go from Apache to monitoring. So monitoring labs have a whole bunch of other components to them. So we're going to get to that here in a little bit. I'm going to be on most of the day, so it doesn't really matter if I jump to something else for a little bit. But we're going to do general troubleshooting here in a little bit. And I'm going to drop off of here for a second. I'm going to pop on a hourglass. And I'm going to say real quick, I'm going to take a break. I'm going to go make some food real quick. So, general troubleshooting. We'll do some general troubleshooting. I haven't done this in a while. But let's say eating and hanging with Ranger. And then troubleshooting. Right? And I'm going to give myself 8 minutes to do that. So I'll be right back, guys. I'm going to go grab me a monster downstairs and some other stuff. Do you guys want to watch Ranger too? Hold on. People like Ranger. He's a good dog, man. If you guys don't know, I talk a lot of trash about Ranger, but he is one of the best animals I have ever known. So, and we are very sad that he is getting old. He is almost 13, and he is a very old dog, very lazy. I'll go give him a treat while I'm down there. I'll be right back, guys. Gotta eat something. Nice core count. Nice. Go check that out. Look at Ranger Dog down there. I gotta eat real quick. Get back to streaming. I'm glad the CC isn't saying general chewing sounds. That's kind of funny. I'm looking at. Huh? That is funny. Sorry guys, I'm chewing these sandwiches down as fast as I can. A lot of attempted logins in the last 6 hours. More than normal. Alright. Need 30 more seconds to finish my sandwiches. Alright, still need a few more seconds. Still munching. Alright, so the goal of general troubleshooting, or troubleshooting in general, however you want to look at that, is not to know a bunch of different tools. It's to know one or two tools very well. So if anything I show you is useful, use that. If any ads. Wait till the end of the ad break. I'll wait for the ad break to end. $40 more seconds, by the way, so there was no way for me to snooze that. So I just kind of went with it. All right, so 20 more seconds and then the ad break's over. How can software engineers join a red team? All right. In 1 second here, guys. All right, I think we're back from commercial break. Should be back from break. Okay. So the question was, how can software engineers join a red team as coders, exploiters if coming from web dev? What I would tell you is, if you don't have examples of it, like here's your options for typically moving within an organization. You probably have to establish relationships with people to move over there, and a lot of times you need to show that you're working towards those skills. And the ways that I know to work towards skills are to build yourself a portfolio showing that you've done it. Go get certifications in the things that are interesting to that team. You know, they might tell you they want like an OSCP or whatever those ones are, or a certified ethical hacker or something like that. For me, transitioning, because I was the red team lead for AAA, for me transitioning over there was just, I had a lot of security certifications, but also I was the guy that was always being called into everything, and I was the lead for all the platform engineering. And they were just like, well, I think this guy can do this, so they moved me over there for that. But I just really had a lot of experience with defending our networks and defending our systems. But the things that you really want to know, if you're asking for red team stuff, the main things that I would tell you to go study are, you want to know your MITRE stuff, so mitre.org. You got to know your MITRE attack frameworks right here. So attackmitre.org. You got to know these. You got to know them well for red team stuff. And then another one that's really big is you got to know your OWASP top 10. OWASP top 10. You got to know those because those are the things people are going to ask you about. Those are the types of technologies and things that people are going to ask you about. So they're going to ask you, if we asked you to do a static application security test or a dynamic application security test against these nodes, what would you do or how would you do it? And you probably need to understand that if it's a static application security test, that means that I have access to the code. I can go run some tooling against the code to see if there's any known vulnerabilities. We probably have that in place already, but then maybe I have some things that I look for where maybe we're exposing ports that we shouldn't, maybe we're hard coding credentials in. These are the things that I look for, right? That's static application security test. Dynamic application security testing is more of a black box where, okay, now I've got the web server up, and then your testing there is going to be like Burp Suite and K6s and maybe any other tools that you have that go and just test the load capabilities of the server and the open, you know, and you could just tell them, hey, I'm going to run Metasploit, but like being able to talk through the methodologies that you're using even before the Metasploit is probably valuable for getting on a red team. Because the whole thing, if a company is going to pay somebody to be a red teamer as opposed to a blue teamer, the red teamer needs to think about abstraction and attacking the system all the time. And people call that the hacker mentality, but it's really just engineering, right? Like looking at something and going, I think I can figure out how to break that. And that's what red teaming is. So red teams constantly are just defending or attacking their systems and then verifying that things are really blocking and that kind of stuff. And then they hand stuff over the wall to the blue and the purple teams and stuff. So, all right, we're back to general troubleshooting, guys. We're doing system stuff. This is engineering stuff. But the first of the troubleshooting steps, this is one that I learned from the military. And it's identify a problem. We've got a problem. Something's not working. Something is outside of the service level agreement, SLA. Something's just not right. We expect it like this. We found it like this. Whatever that is, we identify that problem. We establish a theory of probable cause. Somebody moved it from this side of the room to that side of the room. That could be a theory of probable cause. Theory of probable cause could be identify the problem might be like at 5 p.m. every Friday our web servers go down. What's a theory of probable cause there? Maybe we're under really high load when that starts to happen. Yeah, that song was kind of loud, wasn't it? I don't know why that popped up so loud compared to other ones. Let's get off of there. Alright. Yeah, I don't know why that one was so much louder than all the other ones. They're all set the same. But anyways, so establish a theory of probable cause. What is likely causing this thing? What changes are happening in the system? What's happening as like a whole list? We always look at system. Whenever you get multiple variables in an environment, we have to do a thing. This actually comes from economic theory. So if any of you guys ever work on a master's or a doctorate in business theory, you're going to run into a lot of economic theories. And there's this thing called ceteris paribus. It's some Latin. Caribus. Anyways, it's Latin. Ceteris paribus. It means all things being held equal. And what it says is if we assume that things are staying pretty much the same, what is changing? Oh, we have a really high load of users at this time. Let's focus in on that. And we assume that, like, okay, at 5 p.m. on a Friday, that's not when, somebody's just going and unplugging our servers. We don't go look at those other things. You probably should hash some of them out. Sometimes some of this stuff is happening really fast, though. So that's why we want to understand this, because sometimes this is happening in your head. Sometimes it's happening on a call. Depends on if things are working. There's a theory of how people think called thinking fast and thinking slow. You want to be able to slow down and do these things slow, but you also got to think through them fast. One way that we talked about in the military is battle drills. I need when stuff starts going wrong, I need my body to respond, even if my brain and my hands don't. And that's what a battle drill is, right? Like get down, move online, fire for effect, right? Or whatever you're doing. We were direct small arms fire, so it's always firing for effect, right? But once we've established a theory of probable cause or multiple, then we start to test our theories to determine if that is a thing. Now, that does not mean flipping switches. Flipping switches is one of the things we're going to learn later that we don't want to do. That's what's called the blind man fallacy, where we just turn things on and off until something works, and then we go, wait, it's all working again. What did you flip? That's not a really good troubleshooting method. That is the way a lot of people troubleshoot stuff, but that's not a good way to do it. So, test our theories, establish a plan of action and solve the problem and implement the solution, verify that we have full functionality or at least a level of acceptable, right? Sometimes we don't get full functionality back. We just get an acceptable level with workarounds until we have a plan to do something else, but that's fine as long as we've solved whatever the problem is, right? And then document our findings, outcomes, and actions. I would tell you before step 6 that you should be writing things down the entire time. I often tell people this documenting is the final documentation of things. You should be keeping notes and writing stuff down the entire time, obviously. In my world, it's always here, and then I'm constantly pulling out interesting things that I'm finding about the system. This system just rebooted, or this system's been up 120 days, and I'll go look somewhere else. I'll go to some other box, like Red Note 01. I'll go over to that box and I'll be like, well, this box, something else. Who's on it? Who's been on it? It hasn't been on there for a while because I haven't had it open, but go and look at the things, right? So understanding this process and walking through it is always going to be different, but the process itself is going to stay the same, and it's super useful. Here's another one that's very similar. This one actually only splits out one part from the last one. This is the same methodology, except you establish a plan and then you implement it, right? Whereas back here, you establish a plan and implement it at the same time. So that's the only difference on this one, is 4 and 5 are split out. But there's a bunch of them that are similar to this, but it's basically going through identifying something, establishing a theory of probable cause, testing it, establishing a plan that And by the way, if the first one doesn't work, you come back through and you go to the next most likely one, and then you fix that, and you keep walking through these things. But the point is, you're following a methodology that can get you to a right answer over time. The visualization of this looks like this. You start, you gather information, you identify symptoms, you come down, you question the obvious. It's very common. Follow the OSI model, top to bottom, right? Test your guess. Is it confirmed? No. Do we give up and escalate to somebody else? Call somebody else out? No. We just keep looping right here until we get it confirmed, and then we can start planning the steps to fix the problem. Fix the problem, verify the system works. Is the problem solved? No. Walk all the way back up and question the next obvious thing. Walk back through, test our guess, start fixing the problem. We get down here, could this problem be prevented? Yes, take preventative action. If no, just go over and document things and get out of there. If it could be prevented, take your preventative action, document things, and then stop. And there's a whole bunch of ways to kind of walk through this, but this is a way to do it, right? And I have this in one of my other discussions too, where we kind of walk through all these pieces, right? Then there's one, this one comes from Microsoft. This is an old Microsoft one. It's called Reacting. Again, you're not trying to learn all of these. You're trying to find one or two that resonate with you and think about how you would do this. So this is research, engage, adjust, configure, and take note. The research, engage, and adjust are your problem resolution. So you had a problem, you've solved the problem. If you're doing ITIL, by the way, this is where this gets weird. If you're an ITIL, like I'm an ITIL 3 certified guy, but there's an ITIL 4 out now. And if you're ITIL certified, anything that's actually causing a problem in your environment is called an incident. So this first 3 is actually incident resolution, and then problems are your ongoing stability. So they break it up differently. People are going to call all kinds of things different things. You're going to run into a very common one nowadays is safe agile. So you're doing agile methodology, but it's safe. And then you've got ITIL, and ITIL is up on version 4 again. And then there's just all kinds of bullshit methodologies that do the same thing. All I'm telling you is make sure that you use, well, one, use the one that your organization uses. That'll make your life easier. And 2, get good at whatever you're doing. This one, do your research, engage, ask questions, figure things out, fix things, then come over here and make sure that it doesn't happen again. That's what ongoing stability is. A lot of people like React. This is again, this start. If you go look up React for troubleshooting methodologies, this is a Microsoft one. This is a Microsoft methodology right here, but it's a good one. It works. All right. Then we get down into, this is one that has probably proven the most effective in my career over time, and that is stepping through the OSI model. So, check it out. I come right here. I ping www.google.com and I get through. So check this out, right? If that works, if I ping Google and it works, what do I know about, let's do this, hold on. Let's ping this isn't gonna work. It's gonna fail. But check this out. Yeah, these are all available. These are all up on the Discord. Yeah. Mushroom, this is all up on my Discord. I think it's because most people don't want to learn anything. I think most people want to be infotained. I think I could have way more viewers. By the way, I watch enough Twitch to kind of know how to play the game. The guys that are successful in my space here would come on, and you can go look in most of the successful tech streamers. And what they'll do is they'll present a problem, and then they'll argue towards the problem. They'll set up like a straw man and they'll argue it and cause everybody to argue. And then when they get all of that arguing, then they use that to keep people kind of going. They like stoke up the fire of like fire up the fires of Isengard, and they have people. There's always a conflict. Go to most popular. I can't even stand the popular ones that do tech stuff around here, but go to their stuff and watch them just be like, Rust is the only language. Rust is the only language. You need to be typing like this in Vim and NeoVim for. And I'm just like, oh my God, that's not how most engineers work. There's no way I could work with you, dude. And like, yeah, it's rage. That's exactly what it is. Yeah, rage baiting. And Rust is better than Go, and let's have an argument about it. Who fucking cares? And people, by the way, people will come in here and they'll be like, "Oh, why aren't you using Linux all the time?" And I'm like, "Because I do Linux all the time." Oh, why isn't it my primary OS? Well, because I don't care. Like that's something like for junior engineers and people that are gonna be like admins their whole career. People that like do this stuff and are professional at it, they legitimately can do it from anywhere as long as it's in the terminal. But yeah, it's very common. People rate that. I like that term, rage baiting. So yeah, I want you guys to understand this stuff. But look at this real quick. I pinged this box, and I got no response. But where does ping exist? It's ICMP, which is Internet Control Message Protocol. We're using the Packet Internet Working Groper, right? ICMP. And that's happening at layer 3. I have a resolution for that name on my machine. I have a resolution for an IP address, so I know the IP address that I'm trying to hit. So that's there. But I was unable to ping the box. So if I couldn't even ping the box, it's probably down here where the problem is. On the other side of that, if I were to ping hostbox, and somebody told me there's a problem with hostbox, and I can ping hostbox, then what I'm getting responses back. I do not have to go check to see if it's turned on, plugged in, that the cable is programmed in, cables lit up in the back, and that the IP address of that box is configured. This is set. I can ping it. By the way, this was an old joke with systems engineers and network engineers, was you would call up a network engineer and say there's a problem with this device, and they'd ping it and hang up on you, right? And the idea is, well, my stuff's good. I can hit the IP address. Yeah, you could have firewalls in between there, absolutely. But typically, like, because of the way that these things work, I can find out all kinds of things about my network. Watch this. I'm having a problem with P01 Jump 01, so I ping www.google.com. And then I hit Control C, because, right, it's here. What just happened for me to ping Google, if Google isn't a local address, that means that I went all the way out to DNS, all the way up to layer 7. So I pinged Google on my machine. I went all the way out somewhere to the application layer for DNS. I got a response all the way back with its IP address. Then I took that IP address and I pinged all the way to Google and either got a response or didn't. Yeah, we could use traceroute too. Traceroute's a great tool. And I got all the way to Google and back, so I know that all of those functionalities are working. But what if it wasn't working? Let's say this wasn't working. What are my next steps? Well, I might do traceroute. I might do an IPR and say, well, can I ping 192.168.11.1? And if I can ping my gateway, my default gateway, that means that my device is talking to other devices. By the way, if my device is talking to other devices, nothing else has changed on my device, network's good, right? I can see things about my network. I'm on the right network. I'm on the right subnet. Nothing's changed here, right? But I just can't get out. Then I might start looking at things like firewalls. And I tell guys all the time, don't just point a finger at network. They hate it. They get it happening to them all the time. What we need to do is verify that from this box I can get to my default gateway. And then I might go ping something internal. Do I have something internal? So now I can ping further than that hostbox. And now I'm getting to hostbox. So now I'm communicating to my next hop, and I'm communicating somewhere in my organization. That's good. I'm also getting DNS. DNS is allowed. I'm getting Google DNS resolution. How am I getting that? cat@cresolve.conf. That's probably resolving internally first. But could I make sure that maybe I can find it over there? Right? There's all these kind of things where then I can check. And then now if I can't ping out to Google, but I'm resolving DNS to Google, I'm pinging my local gateway, I'm pinging some other device in my network, maybe even another device on somewhere else in my company, then I do start to think, yeah, there's something blocking me in there. Especially if it was working just a few minutes ago. This is like a new thing that came up. Something probably changed in the environment. So the being able to walk through your OSI model is one of the biggest things to me. Yeah, it's always DNS. We got a haiku about that. It's always they said it wasn't DNS. It couldn't be DNS. It was DNS. I don't know. Haikus are always 575, but I probably didn't do it right. But anyways, there's a haiku on DNS that's pretty funny. We'll look it up. Hold on. I got to keep looking things up. So DNS haiku. And there it is. It's not DNS. It's not DNS. There's no way it is DNS. Or it's DNS. That's 7. It was DNS. Yeah, there you go. 575. How do you learn the letters for the OSI model? We have a sentence for about a pizza guy. Yeah, so Mushroom, the main way that I would say to do it is just learn the model over time. But the common ones, and if I had to guess, I probably know way more common ones than I should, because my students are always telling them to me every quarter. But there's all people seem to need data processing. Please do not throw sausage pizza away. Please do not something. Please do not taunt Steve's pet alligator. That's one. I've always liked all people seem to need data processing, but that one's backwards. Please do not throw sausage pizza away. Please do not, taunt Steve's pet alligator. What other ones are there? There was a really inappropriate one my students told me the other day. What one was that? Hold on. I almost want to look that up. I need to just start keeping these somewhere. No, there's not necessarily a reduced OSI model. What there is the TCP IP model. So the TCP IP model looks like this. I have this in some of my college stuff. It's a 5. It's the same thing though, right? It's just By the way, all that matters really is like how you want to look at it, right? Here's the image in a new tab for you guys. Oh, that's hard to read. Hold on. Yeah, that's a pretty good one. So basically what they do is kind of similar to what a lot of us do in general, which is we group all these up. Application, presentation, session become application. Transport stays transport, network stays network, and then data link physical become network interface. That's it. Yeah, so that's the OSI versus the TCP IP conceptual layers. However, the way I like to look at it, and I've been teaching this so long that, like, by the way, and this isn't like a challenge, but you guys can go watch. I got on YouTube my little like primer, and I brain dump for I think it's like 3 hours on networking. But if I really spent some time and we really wanted to do it, I'm pretty sure I could talk for like 24 straight hours on this model without going over the same thing twice. I've been talking about it so long and studying it so long. But for me, the 7-layer model is perfectly fine, but the data link layer would get split. And the data link layer, this almost was an 8-layer model, because data link really should be media access control and logical link control. There's 2 functions happening at the data link layer. How do we do the media access control? How do we control the access to the physical? And how is the logical link controlling coming down from the network? So that's kind of a thing. What you also do is then look at the TCP model and know that you're in the network interface layer. You know that you're looking at layer 1 on the OSI. Yeah. But even just this stuff, like ping is such a great tool just to make sure, shooting right across the bow, are we here or are we higher? And if it's higher and I'm a network engineer, I honestly don't care that much, guys. Right? At the network level, network engineers care about this stuff. Maybe up to transport a little bit. But you know, if it's like, you know, I can ping the box and I can get a web page on it, but you're telling me like, oh, my headers aren't working on my web page, I'll be like, what the fuck do you want me to do? It's your web page. You're the one running it. Like, I can't help you with that. Anyways, my point is, like, understand what's in your control and what's outside of your control, right? So this one's very, very effective to me. This one, I would keep this one around and I would know what's happening at each of the layers, right? And we were talking even about pinging. We were doing one yesterday where we were interfacing between the network and the data link layer like this. Watch, so I'll show you guys this. We were pinging to yahoo.com, right? And that ping goes through. So we ping Yahoo, goes through. And then we do an IP adder, and we see that my Ethernet here has a maximum transmission unit of 1500, right? Some of you guys maybe were here yesterday and you saw this, so you're like, okay, what the heck does that mean to have an MTU of a 1500? So a maximum transmission unit of 1500 means that at the data link layer, as you're packaging things up here. When something gets handed down as a packet from, oh, I got a better visual for this. Hold on. Where is? Hold on. I'm gonna pull up this other one because it's what we were using yesterday. And then I went off and I ran the, so this is called the networking primer, I think. Prolog networking primer, yeah. Hold on. So I was, this is on the thing as well. So anyways, this is how things flow through our network, right? This is actually how things flow as they come down. Well, look at the network layer, you've got a packet, and that's going to be brought down as a data flow, and a header is going to be applied and a trailer is going to be applied. And this whole thing together, this data link layer packet, it's a frame at that point, is 1500 bytes. That's the maximum transmission unit. If something comes from here bigger and you need to fit it into 1500 bytes, data link layer is going to chop it up like a blender and put it in multiple of them. Do you guys all know that? Yeah. Keep the packet fragmentation down. I'm about to show that, core count. I'm about to fragment this packet and then not allow it to fragment, and we're going to break all kinds of stuff. So watch this. We can't really see it happen because we're pinging, but let's ping that, and let's do a C1. So we're going to do a count of 1, okay? And then let's add a size of 8,500. 8,500 bytes is way bigger than the maximum transmission unit of 1,500. So as this 8,500 bytes is coming down, it's going to hit that, and it's going to be split out into at least 4 frames. Now you're only going to see the 1, but it's going to say, hey, yeah, you sent this big old thing, 28 bytes of header on the front, 8,500 bytes total, and we got back something from there. But now I'm going to do something, and I showed this yesterday, but we're going to do a -M, which is the, it's called the mutex, and we're going to say do, meaning do set the don't fragment bit. It's not don't, because you have do, don't, and want. You have do, don't, and want. Do set the don't fragment bit, or don't set the don't fragment bit, or do or want the don't fragment bit. I'm going to send this anyways, and it's going to say, so what happened was an unstoppable force just met an immovable object right there. Look up TCP MMS clamping. Nice. So check this out. We're taking this big old, from as it passes down the layers. Ping got to the packet layer, or down to the network layer, and it's 8,500 and some header bytes on it. And then we went to stuff it into a frame. 8,500 is way too big to fit in 1,500. Does everybody get that? You have 8,500 of something and you try to fit it in something that can only hold 1,500, it's going to be too big. So it wants to fragment it and chop it up and put it in these little rail cars. But you said, no, this is a major award. It's a big long lamp leg, right? You can't chop it. Not allowed to chop it. Could you imagine if you went to ship something and you actually had to write on there, do not cut this, or people just chopped it up and threw it in different things and sent it? Doesn't matter much in the networking world, but it does matter to us. So some of you might say, Scott, why are you hammering this, or why does it matter? Well, guys, I used to run into this all the time with storage. They would assure me, my networking team would assure me that I had jumbo frames all the way across. Jumbo frames are 9,000. So I would do this all the way across with a do not fragment set, and it would break. And I'd go, guys, I can hit 3 servers down, but when it hits that core switch you have over there, it's not. And they're like, oh, we forgot to set it there. You don't have jumbo frames. And I go, I know I don't have jumbo frames. I just proved it, right? And again, it's not to like start arguments with people. It's definitely not to point fingers around. It's just to like get this stuff running. Like, guys, I need to be able to, like, because think about it. I'm looking. I tell my engineers this. I tell my bosses this too, and my managers over the years. All I'm doing on any system ever is this. I'm looking at a black screen with green or white letters. What the heck's going on? What's going on? And you're like, what's going on, Scott? And I go, I don't know. Tell me what to do. Well, 1, management doesn't know. And 2, like, nobody knows, right? We're the Linux engineers. We're the ones that are supposed to know. I have to understand how to look at the system from these, like, models that I have in my head about this. And I really like, if you guys know who C.S. Lewis is, I really loved C.S. Lewis's quote. He was a early 1900s. He lived through World War II, and then he was a kind of popular children's author and also adult Christian author. But he was also a radio host A lot of you guys probably don't know that if you have never read about him or anything. But he was a radio host. But he had this very famous quote. This has stuck with me my entire teaching career. And I was a Toastmaster and all that stuff. So I did public speaking and stuff. I always loved this. This is one of my favorite things, and this is how I think of like when I was just talking about holding all that in here and doing this. He said, "Radio is theater of the mind." Radio is theater of the mind, and what that means is, if I was like, "Hey, everybody here, close your eyes, like turn me off, do all this, don't have any visuals anymore. We're just here, right? We're just on a black screen like this. Everything I want you to understand or know has to be in your head." You have to, you don't have any of these visual cues, and that's my thing. So yeah, I could say, yeah, I would say that too. Reading is also kind of theory, but what his point was, I'm talking to you and I have to convey everything I want to talk to you from my mind. And it's the same thing with the system. The system here can't give me anything but this back unless I ask it. And I tell you guys all the time, there's only two things we do at a command line: we check settings and we set settings. They're the only things. Even if I ping www.google.com, I actually set my system to ping Google, and then I got response back. And I cat, an etsyresolve.com, and I checked a setting. Then I can go change that setting, right? But my point in saying all that is we got to be able to hold this stuff in our head and think through kind of what's going on, and that's a big part of like systems administration and working at that command line. I tell you guys, I have been down doing command line stuff so long that it's like that's the crux of what we do. We set things and we check things. That's it. All right. So this one is just kind of knowing a lot. This is maybe for our junior engineers, we've got something hanging on the wall that says, "Hey, here's the common problems. Here's the way to fix them," right? And this is not an exhaustive list, but this comes from like a hardware problems and symptoms. But it's what happens if a web server goes down. Well, you go and you restart the service, and then you go and you make sure that the caches aren't full on the memory, and you commit the caches down to disk, and there's all these things that you can do. And we could set these lists up, and it's common ways to deal with each of the different things and what the problems are around them, how the symptoms show up. But this right here is just knowing a lot of things, and this is valuable. But this needs a certain level of expertise. Well, all of them do, but this one, like, you'll know more about your system the longer you live in that environment. And you should hopefully be documenting these so that other engineers can come along after you and live a happier life, right? Like, because I always say my goal as an engineer is to not get called on the weekend. So I try to make other people's lives easier, because by me doing things well and documenting things, then I don't have those same problems, and neither do they, or neither do others, right? And then this one is prescriptive. This is like being a doctor. This is how doctors work right here. Look at the symptoms, identify the most likely cause, treat it. Doesn't fix it, go back to the next one. Hopefully you don't kill whoever it is before you treat the things. I used to work at a cancer research company called Caris, and we researched how to best get the treatment to the cancer, the person that was dealing with the cancer. We worked on how to get past the first things that weren't going to help. And yeah, prevention's a big part of it too, right? But in a system, we look at what the symptom is. This requires an expertise around what the behaviors are supposed to be and what they're not. Look at what's probably causing it, and then treat it with some type of solution. So, for me, I go to my Linux box. I can't ping something. Well, but I could ping it yesterday. Well, what's wrong? What's changed? What's different? Right? The symptoms are, I do not have this type of access. Identify the most likely cause, something changed in the network, whatever, and then we treat it, and if that doesn't, then we just keep flipping through it. This one requires, again, a lot of expertise. But this one requires expertise in the system you're in. This requires expertise in like a high level understanding of all systems of this type. So this is a good one, but this is not as rubber meets the road as some of the earlier ones, right? But this is still a very valuable and very valid way to troubleshoot things, right? And then we got systems thinking. This one requires by far the most knowledge, and the most understanding of that particular system. This is the people that have been working on a system for like 10 plus years, and they know where all the nooks and crannies are and all the problems and all that stuff. Systems thinking is understanding all the interdependent components. The way that we try to get to people doing systems thinking faster is, if you guys have ever heard of like trace logging or trace inside of systems, where we have like an application front end, we have a web presentation front end, we've got an application middle tier, and then we've got database back end. If we are tracing all of the movement of the data through that for a flow, that is kind of system thinking. So if you have good trace data, you can kind of supplant a little bit that idea that I need like these people that have been doing it for 30 years on this one system. But you got to understand how the pieces connect. What's the system supposed to do? How's the data supposed to flow? Comes in on my web front end. That is a reverse proxy to a bunch of application servers. That port always comes through on port 5000, never varies. It's always hitting a bunch of 5 Kubernetes systems that are a bunch of pods that are always up. Those pods communicate back on port 3306 to MySQL. They will always be connected to that MySQL device as long as it's up, and for some reason maybe that's not working anymore. And this kind of understanding of the flow is really important for being able to troubleshoot these types of systems, right? What are the systems and devices in between? Do we know how the data is supposed to flow within? That's anytime you're dealing with Kubernetes, you're dealing with what's called the SDN, a software-defined network. Now we got to go troubleshoot how that data is flowing, because it may be flowing within a couple of pods, right? Because you've got your normal network, and then you've got a software-defined network on top of that, where these devices are talking to each other over ports that you're not even aware. Like, you're not even looking at how those ports are opening and closing dynamically inside of those machines that are actually doing normal TCP connections. The software-defined networking, that is all getting logged to certain places as well, and you got to keep track of all that. Now, you don't have to dig into it unless it breaks, right? But it's no problem. What other devices are attempting? What's changed? And this is determining if you have good change management, right? Has the system been physically moved recently? That's a big one. Have things been rebooted? That's always what I do. I check uptime and who's been on the server, always, if there's a problem, right? All right. Then this one, so all of these are our troubleshooting things. These are different ways to troubleshoot that I find valuable, right? Yeah, that's up on Discord, by the way, this whole thing. This next one is not, strictly speaking, a troubleshooting in real time. This is a troubleshooting things in the future. This is failure modes and effects analysis. You will also get this if you go look at, I think, beginners. I have a couple of certs there that are free. They're not mine. They're certs that exist out there in the world. API Academy has some free stuff to do, and the Six Sigma Council has a free white belt cert that you guys can take. So if you're like, hey, Scott, I just want to go get some certs, and I don't want to spend any money, those two are free. Me and all the guys did the API Academy a few years back. That was absolutely, it was probably about 18 hours total between the 3 certs. You get 3 little cool certificates, and you can go put them up on your LinkedIn or whatever as, hey, I know how to deal with APIs. I know lifecycle management of APIs and stuff. You can also get Cisco skills. Yeah, but a lot of those, like, if you want to take a Cisco cert, it's going to cost you about $350, which is fine, but just not everybody, I know not everybody wants to spend money, so that's why I have the free stuff. I probably should put more free resources that are out there, because there are other certs that are free as well. Both of those are free. Yeah, about $350. Yeah, goddamn you, Loch Ness Monster. All right, systematic process to examine what could go wrong, what impact might it have, what's the likelihood of it occurring, what's our ability to detect and react. Yeah, no, I get it. I get the... All right, so here is one. This actually comes from, this is a failure modes and effects analysis. Step 1, round up all the possible failures. This is from a actual server build problem that I used to have. I think I told you guys I used to run about 5,000 servers at AAA. I was the platform engineering lead for Windows and Linux teams, right? Windows had between 3,000 and 3,500, and Linux would have anywhere between like 1,500 and 2,000, so about 5,000 servers total. And what would happen is we had about 200 dev teams that were building stuff, and we had production servers and non-prod servers and stuff. And what would happen is they could at any time, anybody on any of those dev teams could go push a button and it would deploy a server for them. It was like a little like a little kid pushing a thing and like having a little soda can fall out, and they would take it. And these servers were all automated through processes that I had built through vRealize, or so VRO is vRealize Orchestrator. Actually, so it's funny, Mushroom. I talk about this sometimes. I never lose sleep about anything, and the reason is because as engineers, we don't have to stress. I tell people all the time, if I document what's going on and I tell management and I give my recommendations, I do not stress again until that decision's been made. It's not on me. Now, if I lie to people or I don't tell them things, then I will always be the one stressing on things. But I tell people one of the reasons that I don't ever stress, and you'll never see my hand shake, as it were, right? It's the idea that I don't, not that I don't give a fuck. I mean, I do care, but it's not, my job is not to deal with it. It's the same thing with, like, if a manager pushes back on me in a meeting, I'm like, okay. And I go tell my manager, hey, they pushed back on me. This is where we're at. I'm either going to do what you tell me to do, or I'm going to follow that, but I am not going to, I won't get, like, you guys, and you can ask people that have been in meetings with me. I've worked for 20 years. There's a bunch of people in our Discord that know me professionally. I do not raise my voice in meetings. I don't fucking care. I'm by the way, you know, I was an infantry guy in Iraq. I got PTSD. I got a 0 and an 11. I do not let anything at work piss me off because I don't care. It doesn't matter. If you want to argue whatever and do it a different way, okay. You're the manager. But I'm going to present all the things. And then when things go wrong, I'm just going to be there with my email that said, I told you, you know. But anyways, I tell you guys this all the time. I don't ever, you never have to listen to me. I always want expert authority in an organization. I want to be the guy that people want to listen to. And that's always been my whole career. I've been the guy that I want to. But yeah, I do not bat an eye. When I go off work, like I'm actually logged in right now because I'm on call, but I don't lose a single bit of sleep over anything. Because that's not my job. It's the manager's job. It's the manager's job to deconflict things and get things out of my way. My job is to do good engineering. And anyways, that's part of this. So these were things that happened or could happen and go wrong in my system. Failure mode could be the initial image was unavailable. So the ESXi had ESXi is your VMware, and it has a back-end storage that all of them could point to. And maybe that storage was offline. So our current controls that could help us not have this problem would be to monitor vSphere systems. Automation job kickoff fails. So when VRO tries to kick off certain jobs out of my Ansible, which was eventually Ansible Tower, then maybe the system credentials were out of date. So we'd have to make sure that those were updated. And one of the ways that we fixed this was one of our solutions, was, well, typically, as long as you could build the server every morning at 4 a.m., we would build all our servers. Then tear them down, but build them. Make sure that the Play-Doh is not too dry to go through the little Play-Doh thing, right? Make a bunch of star-shaped servers. Then we would throw them away. But we would see that everything worked right. So that was part of our fix, was we daily built every morning all of our servers. And that was a very small percent of our overall processing. Agent register, so maybe we tried to register one of the agents and then that agent had credentials out of place, so another one of these daily build things would fix it. Scott's the kind of guy that you want in your team, type of leader you follow. And one Scott in this one. Yeah, there's a whole bunch. Yeah. And don't say Scott in our Discord ever, because the bot will correct you. That bot is the bane of my existence. Anyways, final build checks fail. So we get to the end and we test everything and something just breaks. This one's a problem because we don't even know what causes it. Sometimes things just don't pass the test at the end. We have no controls. That's bad. That's really bad, guys. So, FMEA, by the way, failure modes and effects analysis, I'm about to show you how this becomes mathematical here in a second. Super easy math, by the way. I won't do anything that was past 6th grade for you guys, I promise. This is 6th grade math. But the math's about to come up. But failure modes and effects analysis, you can go find all kinds of charts for this. This was a real one. This is actually something I did to fix things in my environment. Then here's our probability. Severity times probability times detection gives you a thing called a risk priority number. The risk priority number is, by the way, the assigning of scores. This can be 0 to 9. This can be 0 to 9, and this can be 0 to 9. Or 1 to 10. 1 to 10, whatever. It doesn't matter. 1 to 10 is probably easiest. But the point is, you use 10 digits, right? Or 10 states of nature. Then you take them, and you always have between 1 and 10 on each of these, let's say. And then you multiply them all. So 2 times 1 is 2. times 5 is 10. 3 times 2 is 6, times 5 is 30. 5 times 5 is 25, times 9, 225. 7 times 4, I know, basic math, right? I told you, nothing past like 6th grade. What's Ranger doing? Hold on. Somebody wants a Ranger check? What's that dog up to? Is he breathing? Yeah, he's doing good. Give him belly rubs. He is an old dog, guys. Means that the product can always be 0. Oh yeah, no, yeah, it starts at 1. Sorry, you're right. It's 1. I haven't looked at this in a while, but it starts at 1. Yeah, because you can never let it be 0. So 1 to 10, right? And then, by the way, the most you could ever have is 1,000. So the higher your risk priority number, the more dangerous something. Yeah, he's breathing. Yeah, he's breathing. Look at him, tired ass dog. Watch. Put my hand right there. I saw his ear move. I gave him a treat a little while ago when I was downstairs. But all right. So, anyways, yeah. So 1 to 10, and then we assign the scores, and then we just do the math real quick, and then the higher number is more impactful, so you want to spend more time there because you don't have a control. And actually, the final build check fails. I should have had that be a 10. I don't know why I didn't. Probably just for the example. But that would have still come out to what? That would be 28. That would be 280. So that would have been the highest if this was a 10. It would have been a 280, right? Because that should be, yeah, 28 times 10, 280. Yeah. So you guys see how this works? Pretty straightforward, right? Failure modes and effects analysis, very common, very simple engineering type thing. Requires a little bit of thought because what you're doing is a government type process to think through what could go wrong, what's the impact, what's the likelihood, could we detect it and react to it? These are the things that we're doing right here. Yeah. All right. That's that whole one. Let me get this out of the way. All right. Where were we at here? What was the other thing I was doing? Because I forget what I was doing. We got Ranger. We've got the book. And we were going to do monitoring next. Oh man. All right. Hey, how's it going, Bonnie? Hopefully this stuff's useful to you. We are probably... Look at that Ranger dog. I might take a little break here. I'll probably be back on streaming later because I wasn't kidding when I said I really don't have anything to do today. The wife's out of town. Ranger's laying around. It's kind of warm outside. I don't want to go anywhere. So we do run a Linux group. Our professional Linux users group is at about an hour and a half from now down in our Discord. And maybe when I run that, I'll also be streaming. Maybe I'll come back on streaming and just kind of talk through what we kind of talked through. When we do those, we tend to just kind of walk through. It's pretty straightforward stuff. Yeah, Ranger is... can I tell you that bed on the left there is one of the most comfortable things I've ever laid on. And the reason I say that is when me and my son bought that for him, we were at a PetSmart and we were like, Ranger needs another bed. So we bought him this bed. And it's got like a little divot from him laying in it. But I can tell you, we put it down on the floor and we both laid on it. And it's one of the most comfortable. It's for older dogs for their joints and stuff. It's an orthopedic bed. I think it was probably like 70 or 80 bucks. But it was like one of the best things I ever bought for him. And it was funny because me and my son would always buy Ranger more beds. And my wife would always throw away the older one. So he only had 2. And we were like, well, why can't he have more beds? And she's like, he's got enough beds. So then we started buying him blankets. And then she got mad that we kept buying Ranger blankets. Not because she doesn't want Ranger to have nice stuff, but just because we were like spoiling Ranger. So he's actually got a couple of little blankets too, but it's not cold down there, right? You know, it's like 73 degrees downstairs. I think it's about 90 outside. Oh no, it's only 76 in Phoenix. It must be because of the storm last night. We were getting in the 90s the last few days, so it's been brutal. So yeah, I appreciate you coming by, Finer. Hopefully this stuff's useful to all of you guys. Yeah, we'll keep going through the book. A lot of this monitoring stuff is the same stuff I do in my Homelab. And one of the things I meant to do this weekend, the Ranger Xmas, did you guys know that Ranger actually has, so right here, and I have some, I could show pictures of it, but I have, we have our stockings that my wife will hang, and then Ranger has his own stocking that's a little dog bone stocking, and I'm like, that's not effective as a sock. And she's like, I know, it's just a stocking. And I'm like, yeah, but a stocking's supposed to be a sock. But anyways, so yeah, Ranger has his own little stocking. Yeah, I use, so this monitoring that I do here, this same stuff, I actually do professionally in quite a few environments. Yeah. So my monitoring always looks like this. I'll show you guys my monitoring real quick. Some of you guys have been around and seen this. I don't know why that was closed. Hold on. Monitoring. This is how my monitoring works in my Homelab, and how it works at a few different companies that I've set up monitoring for. You got your monitoring architecture. Any server is running some type of agents, and then the different devices are either collecting those from pushes, or they're polling, Polling, from those machines to gather information. This is the time series database. This is the time series database. This is not a time series database. Loki isn't specifically. It's just an API endpoint that aggregates logging. You just throw logs at it, you pull logs off it. That's all you do. And you use the logql language for that. But this is what my home lab stuff looks like. Right here. And the next 3 labs, if you do our labs, so here's labs. If you do our labs, the next 3 labs are all about building those pieces out right there. And if you're in our Discord, we've got a projects channel. And in the projects channel, if you go to our projects channel, what the heck's going on here? Come on. It's taking too long. In our projects channel, we have a couple of these monitoring deep dives. And here was my monitoring deep dive presentation that I put together on how to do all this stuff. And then we had a companion guide with it, which was called the Deep Dive Project Guide, for you to fill out, and you could fill out and add pictures to and answer these questions, and then be able to get ready and have a little, you could turn this into a little portfolio for, hey, I know how to build this stuff out, and take that when you go to like when you go to try to get a job. Yeah, this was from Prolog. I had updated for 2024, but you know, you have nothing else, let's say, on a resume, you could at least have that project, right? That's what I'm trying to show you guys, is you can build all this stuff, and since you built it in the labs, you will feel confident talking to any of the pieces of it, which is the most important thing, I think. So, all right. Oh, what? Visual Studio's crashing? What the heck? I don't know why this thing keeps crashing. Not good. All right. We don't serve him, but yeah, I good guys. I try to put out stuff that's useful. I also play, you know, sometimes I play some video games online and stuff too. But for the most part, the goal of this is to show you guys you can do this professionally. I've been doing this professionally for 20 years. I've been teaching it for 15 years. I mostly teach networking and security and Linux, but all this Linux stuff is something you guys can do if you wanted to. And there's labs to show you how to do it. And then all you have to do is convince the company that you can do it and that you will do it. Those are the 2 things that we want to know in a interview, right? I even have all my interview stuff here. If you guys want to go over interviews, right? I haven't these in a while, but you know, I have all my technical questions for senior HPC people, right? There's minimum qualifications, and here's the questions that I ask when I do those things, right? So I want you guys to kind of know these things and know that you can do them. And then, you know, most importantly is we've got a Discord where even if I'm not around, there's all kinds of other people that you can go hang out and talk with. I used to always tell people this, like in the 80s and 90s out here in Phoenix, there was this place called Charter, and it was like a mental health place, and they had a little hotline, so like if you were going to kill yourself, you can call Charter, and they'd be like, don't kill yourself, and you'd be like, okay. But anyways, they always said in their commercials, if you don't get help at Charter, please get help somewhere. And I always like that. I tell you guys the same thing here. If you don't get help here, if you can't listen to me for another second, go find those guys that are gonna rage bait you into doing Rust or Go and TypeScript and Vim, you know, do all that crap, whatever. But find somewhere that will work with you to, you know, find. And I'm not one of those guys that's like, you're the sum of your 10 closest friends. I'm not telling you that, but I am telling you what you focus on is what you're going to get better at. So, and there's people who have aptitude for all kinds of things, right? But that being said, the people who focus on things are still going to do better over time than those people who have an aptitude for it. And I always think that saying is 100% true. Hard work will beat talent when talent doesn't work hard. I 100% believe that statement. That has been. I have seen more engineers in college fail from being the smartest guy in the room than people that'll work hard to be good at something. And I would rather have the person that works hard than the smartest guy in the room. I tell you guys that all the time. Like, I never try to present that I'm the smartest guy in the room, because who cares? What's important is that we can build stuff and we can get things working and stuff. So, all right, let's go find somebody to raid. Let's go find something. We'll put on our little intermission. We'll find a little end of stream. Let's go find somebody that's doing something fun out in the world, out on the internet. Let's go find. There are. Whoops, what the heck just happened there? Let's turn that off. And Running Man's up there. Let's go hit up. Let's go hit up Sony Chiba. He stopped by earlier. We like Sony. If you guys like video gaming, he's playing video games and stuff. We'll go raid over there. He's not doing tech stuff, but again, sometimes we just want to chill out. I think he's playing a new Doom game, or a newer Doom game. So say hi to him. Feel free to follow if you want. Follows are free. And I will talk to you guys later.